bass kick. Let the bass kick. Let the bass kick. Think about it.
So what we've done is we've added a bunch of new features.
Absolutely amazing.
.NET is a general purpose framework for building all of these types of applications.
You can be productive and code and build your UI quickly.
What?
Hi folks, how are you?
And the home screen shows you the sauna temperature.
And you can see down here on the lower right, it now knows the garage door is open.
Let's jump into the code now.
The .NET community has just always been a great community to be a part of.
This really is a state-of-the-art technology.
You can actually download this right now,
And get right to the code.
build some new applications on .NET Core.
Please have a great conference. Ask us lots of questions on Twitter. We're going to be there all week.
Sharp as well with this guy. So, yeah.
Yeah, so no new .NET without a new C#. This time it's C# 11. So really getting deep into the 2 digits here.
Yeah. Yeah, it feels like, but this time it's just one, it's one larger, right? It's one more than C# 10.
Yes,
All
yes, just that extra little bit. So we didn't bring slides, we just brought code.
Yep, we're going to dig right in, okay? So first up, it's tradition that Mads and I in our demos, we start with a very, kind of simple person demo where we have a person class. Now, what's cool about this is that we're using some new features that we've introduced over previous releases. We're using a nullable string there with a question mark. We're using init-only properties, but there's kind of a downside to this as well.
Yeah. I mean, we really want to make it nice to use object initializers and not have to, do constructors for everything. They can be a little cumbersome.
Yeah.
But something is a little off, which is that with object initializers, up until now, it's always up to whoever's creating the object to decide which things to initialize and which not to initialize.
Right.
And that kind of bleeds through here a little bit, right? Because you see there's some squiggles in there.
Yeah, there's some squiggles here. This is where the blessing of nullable is helping you. And essentially it's telling us that, hey, we haven't declared these as nullable, but there is an implicit constructor that will get called before the object initializer up here is run, before those properties get assigned. So technically, these properties will hold a value of null, and we have said we don't allow that. And this is kind of a It's kind of a stumbling block in some of these cases where I want to use object initializers. So often we try to find ways to work around this, and so users often are doing things that feel unnatural, right?
Yeah, but
you might have to assign it to null just to tell the compiler.
It is yeah, but this, now you just move the warning,
yeah.
right? Yes,
so
now,
you say null bang.
But now we have a place to put a bang and say, and I know what I'm doing.
Yeah,
you know?
yeah. Try and pass code review with that. Not for me. But this is the sort of thing we have to do, and it really is uncomfortable.
Yeah. You might even try to get around it by assigning a non-nullable string to it, right?
Yeah.
Do
this sort of thing.
The empty
as well.
string or something. But you're really just hiding a problem that's still there, which is that the object is not properly initialized. You can get the compiler to shut up about it, but it would really be nicer if you could ensure that it was properly initialized.
Right, and there's another issue here too, which is that the object initializer itself doesn't initialize all the properties I want it to. Like with a constructor, I can be very prescriptive about what things need to be passed, what I'm expecting from the user to initialize the object. And here, even if I assign these to null or I assign these to empty string, I don't really want those.
Right,
but if somebody's using an object initializer, I can't guarantee that they've actually filled in last name.
So wouldn't it be nice if you could tell the person creating the object, you have to initialize this. It's required.
Yeah.
And that is.
And so we can do that now.
Yeah.
And so the nullability warning goes away because we're telling the compiler, well, I mean, we're expressing in the language that this is a required property. Therefore, it means that when it's initialized, it is going to be initialized. We don't have to worry about some of these details around this time where it might be null. We've guaranteed that. And so if I do the same thing with last name, then looky there. Because I haven't specified last name up here. So it says required member must be set in the object initializer or attribute constructor. Now that's curious. Attribute constructor.
Yeah. So let's celebrate the red square.
Yeah. Celebrate
this is
that.
like,
Yes.
Yes. You now expressing a contract.
Yes.
Whose job is it to initialize this property? And unless you put required, it's the class's own responsibility.
Right.
But if you put required, you're pushing that responsibility, that requirement onto the person initializing the object.
Yeah. And so we can correctly initialize it as that contract defined.
Yeah.
Right. Now that attribute piece I mentioned earlier was kind of goofy, where it said attribute constructor, and it turns out since C# 1.0, we've allowed properties to be assigned as optional kinds of for parts of the initialization of an attribute. And so while doing this, it kind of felt like we should also attack that problem as well. Since the object initializers are all about initializing an object through properties, attributes also have a way to do that. It's kind of merged together. So if I were to make this an attribute, you'd see the same error. So we'll just call it an attribute. Yeah, sure, that's a thing. And if I have the same code here, you'll get the same error. And so now, with an attribute, you can also do this. It's kind of a nice way of just taking it all the way through the language, but also back to C# 1.0 and improving the experience that already existed there.
Yes. Where now you can actually have the old style of optional attribute parameters also be required.
Yeah. It's fantastic. Yeah. All right. Let's move on. This has been a cool feature. I'm really excited about this because it feels like over the course of the language, we are continuing to make these kind of small improvements across initialization and really getting to a place where it starts to really coalesce and feel really good.
I mean, it's been a theme for a couple of releases now to make object initialization flow more naturally, have more expressiveness and more conciseness, and this is another step in that direction.
Well, let's take a look at something else.
Yeah.
We've got C# 11 is full of features, and since we're looking at things that improved C# 1.0 from long ago, there was another set of things that we've wanted to do over the years for many years.
Yes.
That also appear in this language.
So everyone who's had the pleasure of doing math in C# and then trying to abstract over the specific kind of number that you're talking about, you will, even if you just used system.math, you've gone and seen all these overloads. There's an overload for each possible numeric type of absolute value and so on. And you might wonder, what does the code look like inside of all of those overloads? And it looks exactly the same. But we've had to write it like 12 times or however many overloads we put out.
Oh, so just to kind of illustrate this, the demo we have here, there's a function. Again, we're using top-level code here, so there's a function inside that. So we have a method that will take an array of integers and just adds them up. Okay.
It's a numeric algorithm. It's a beautiful numeric algorithm.
It is genius. We slaved over this one day. We really were toiled over it. Yes. And then we're passing an array in here. And if I run this, you can see that it adds them up successfully, which is great. But now if I wanted to make this work over other numeric types, what if I wanted a different sort of like bytes or doubles or anything.
Yeah, I mean, what you really want is
basically I'd have to copy and paste this and do it again.
It would, what we really would want is to make it generic, right? We want to say add all of t, and then this t, then somehow
So we're going to return a t. Now we're going to take a t array. I guess this is going to be a t.
I think that's
and that'd do it.
So that would be cool if you could do that. Of course. You can't plus random t's and they can't be 0. But, if this was just all about instance members, we would put a constraint on that generic. We would say where t something something. And wouldn't it be cool if we could put a constraint on that is like somehow says that I'm a number. I have operators and things that make me a number.
Yeah, so I did that, and I used iNumber, which is new in .NET 7, and when I hover over that, I see now that the plus equals error went away, and in fact there is some interface that has the operator plus that is generic and can be used
this
for this.
This is magic.
It is magical.
Yeah.
The only problem I have now is I still can't convert int to t, but I know that when I'm doing generic methods, I can dot in and look for the static things.
Well, you didn't used to be able to.
No, you didn't.
On a type parameter.
That's correct.
But now there's stuff in here.
Yeah. There's one that would work if I were a mathematician and really good at math. I would know that additive identity is what I need here.
Yeah.
For the rest of us, we could just say 0. And so now this is completely generic, and if I build and run, it still works.
The sum of those numbers is still 15. But now,
and wait, there's more.
What if you use another kind of number?
Yeah, so right now this is an int of int array, but if I throw a double in there, that will cause the inference of the array type.
Oh yeah, now it's a double array. Yeah.
And now it's calling add all with an array of doubles, and it still works. And
and now it's using doubles plus and 0.
Yeah. Right. So this is generic math in C#11, and it is driven by really a much larger feature.
Yeah. So this is sort of the domain that we chose to double down on.
I see what you did there.
Yeah, we're not just inting down anymore. We're doubling down.
Yes.
On the like the thing where we took the BCL, put interfaces and everything in, but it's really like a special case of a broader language feature that we added. That is, allowing static members and interfaces to be virtual or abstract.
Right. So let me just I will go to definition on this iNumber type, and we'll see what this has. And this has static members, and these are actually interestingly, if you get to how this is implemented, they're just static members. They are default interface members as well. They have default implementations, but this iNumber brings in a whole ton of interfaces.
Look at all those interfaces.
Yeah, there's all sorts of things, including that iAddition operators that we looked at before. If I were to F12 on that, you see that, well, this has a static abstract operator.
Yes.
Right?
Because
of plus.
Operators are really just static members, right?
Yeah.
They're one kind of static members, and all the different kinds of static members can now be abstracted over an interface. You can say whoever implements this, they must have this operator. They must have this static member, like we saw the static property 0 before, and then you use generics to get at those, like we saw in our example there.
I mean, it's a great feature for the generic math domain, which is really kind of what drove us to really do it. But
and before you move away from here.
Oh, sorry. I did move away, though.
Oh, you did move away.
But go ahead.
That's
I'll go
fine. I just also wanted to call out
yes.
another little language feature that we added, just as we're here, which is that you can now overload your operators, all the ones that in their primitive form have a checked form.
Yeah.
You can also overload like the plus operator with a checked overload, and in that case, that's the one that gets picked if you're in a checked context.
Yeah, this is and this was, again, it was something that kind of came out of us trying to implement this generic math domain. That, well, this is needed to really fill it all out. And you can see that we went a little nuts with filling it all out. As I look at the iNumber again, there's just a lot of interfaces here, and you can see the scroll bar. It really is composed of many interfaces that can be used to define your own numeric types or things that can be constrained on. But there's also something I want to call out that's really interesting, because it has nothing to do with numbers at all.
Right.
But it's just a really great use of this new feature that is static abstract members on interfaces, or being able to implement static members from interfaces in a sense, right? Because you can also have those defaults.
Well, let's have a look, because being parsable, what does that actually mean?
Right. It means to take a string and give me back an object.
An instance of the type.
Yeah.
So a type that's parsable, that doesn't really mean that things of that type have a instance member on them, right? You can't if you walk up to like a person and say, parse yourself. Well, too late, it's already a person object. What you really want to do when you're parsing something is you want to get a string and then create the person.
Yeah.
So that's usually the job for a static member, right?
Yeah, and I mean, this goes really well in the BCL because we have these parse and try-parse methods on our numeric types, but also on things like GUID, right? Which I'm not adding together, but they're also still parsable and can be, and now you could constrain on this interface to be able to, kind of have a little factory method that might, given a string, produce things out of it.
Yes. So this is really good. If we can have a look at that, there's a parse and a try-parse. The parse is the simpler one of them. It's a static method. It's abstract in the interface. So you're telling people who implement the interface they want to be parsable. Well, you got to have a static parse method.
Yeah.
You take in a string and a format provider, and you return the type of yourself. Like, so the intention is, class C, when it implements the iParsable interface, it will pass itself as the type argument, so that the thing that will be produced out of its parse method is indeed one of itself.
You're going to see a lot of these T-selfs throughout here because they're often, it's about implementing an interface, but I'm actually the generic parameter on this. This is kind of a pattern we've used throughout.
It's so you get strongly typed results, right?
Yep.
You saw the same with the with the addition operator. You don't want to just get some interface result back, because then you lose your strong typing. You want to be where you have, you thread the strong type through the interface.
Well, this is fantastic. So there are other features we could show here. I think static abstract and interface is one of the things I'm very excited about it, because I feel like that whole kind of embedding of kind of factories almost into the language in that sense, right? These static abstract factories is something that I'm really excited to see what people go and do with it. I mean, we've done the generic math piece, but this is something that much more flexible to see what libraries, Nix libraries we see that do very interesting things around serialization and all sorts of stuff that I'm really excited about.
It's super open-ended, right? We thinking about design patterns, for instance, like we saw that factory it was an abstract factory, right? But it was also a static factory. It takes those two classic design patterns and puts them together and gives you something that is, combines the power of both. And I wonder where else people are going to find that kind of application. This is really one that we are going to see uses that we had never thought of, and that are going to just be exquisite and beautiful. This is kind of raw new expressive power.
Yeah. I'm blown away by it. So, all right, let's kind of take a step in a different direction.
Yeah.
We can talk a little bit about we talked earlier about required properties and how we kind of continue to refine and evolve larger feature areas in the language. Another one that we've been consistently doing that with over many releases, I think most releases, since C#7, is pattern matching.
Pattern matching, which is this gift that keeps on giving, right?
Yep.
In C#7, we added pattern matching for the first time. It did just a few key things, but already then it was like really, it was opening up a new way of working with different shapes of objects that was more declarative and had, less confusing if then else's and casts and so on in it.
Yeah, for me, when we first did it, I thought it was a really great moment of design where we used the is keyword, which was already technically pattern matching.
Yeah.
Right. We were saying, well, if it's this type, well, now is it this type and I can give it a variable, or is it this type and it's length of 2 or something like that. That's something that I feel like that's caused that keyword, which has been there since C# 1.0, to continue to just evolve and get more powerful. We've introduced, and we did the same thing with the switch statement, but introduced the switch expressions. How might I do this? This is a pretty reasonable implementation of this.
Yeah.
But I think it would be interesting to try and do this with pattern matching.
Let's try to do it with pattern matching.
So
essentially, we want to do a switch expression. Instead of all this imperative logic, let's try to go all out and do this declaratively with a switch.
This is the nerdiest way to do it. This is the so let's do it this way.
Yes.
Now, to be able to match on an array is a trick, right? I mean, we could match and say, okay, this array has a length of 0 or something like that. But that's
we don't really up until now we haven't really had patterns for things that are list-like. You want to talk about the elements of the incoming thing. So that's what we can do now with list patterns. So you can say, for instance, and we use square brackets for that. Is this an empty thing? In that case, return 0. Except
Actually,
it has to be t.0 now.
T.0.
And but then if it has something, what is that? Let's say it has one thing.
Okay, and so we can use a recursive pattern here and say, oh, it's one thing, and we'll pull that first thing out of it using a variable.
A var pattern.
A var pattern.
But that could be any pattern in there. We could say if the first one is null, then do this. But we'll use the var pattern here. And then
so,
it's just that.
Yeah, and so then we can just kind of have a contest, I suppose, to see what gives out first, the compiler's ability to process the size of this file or to produce cases for it. And we can just keep on going, right?
Yeah, but that's
because this is telling me that, hey, I haven't covered length 3 yet, so I've got a ways to go.
Yeah, so this is not sustainable to keep adding more things, but we need a way essentially to say the rest.
Right.
What we haven't talked about yet.
Right, and so similar to range expressions, we use ... here for that, right? And so that means instead of just the second element, it means match the first element, put it in here, and then all the rest of the things, put them in this variable. Second, we should probably call this something else like rest. And so now this is another array. Okay, which contains the rest of the elements.
This actually uses the slicing that we introduced in C#8.
And I can be very clever, and now I can make this recursive.
Yes.
Yeah, that feels good, right? Although one thing, I bet you were just about to point it out too, is that it kind of feels like now we don't really need the second one, right?
Yeah, I mean,
if I look,
let's try to swap them around and see what happens.
Yeah.
Now we get an error saying we'll never get here.
Right, because it's subsumed by the branch above. That's awesome, by the pattern above. That's great.
Yeah, so pattern matching telling you, it's doing a more in-depth analysis of what you can do and not. It's just giving you feedback when your pattern matching is kind of off.
Yeah, I would say that though one thing about this that's a problem is that it's kind of slow. Right, we're allocating. This is now an allocation factory. We're allocating new arrays.
Yeah, this is using slicing on arrays, which is not the best.
But we have ways of doing that.
Yeah,
and we can use a span right here, and then we can come in and also say use a span right here, and now you'll see that on the sliceable, this thing is sliceable, and therefore we can get another span as the rest of it, and we are no longer
slicing spans is cheap.
Yes,
because it's just kind of looking at the same thing. So very cool.
That's very cool.
Yeah.
All right.
There's one little sleeper feature we should get to before.
Oh yeah. Yeah, for sure.
Before they tell us to leave the stage.
I just started a build to show that it does run. All right. Next up, then let's talk about this last sleeper feature.
Yeah. So string literals in C#. Great for like Shakespeare. Not so great for JSON or XML.
No. In fact, if I run this, I mean, you could see how it prints, right?
Yeah.
But I had to come in here, when you copied and pasted this, you had to come in and escape these quotes. You can make it a verbatim string, but then you still have to escape the quotes by putting 2 double quotes.
Yes.
Yeah.
No,
it's really annoying.
Yeah. So new kind of string literals that we call raw string literals.
Yeah.
And they are the ones that have no escapes in them whatsoever.
Right.
Delimited by...
Delimited by 3.
Yes.
Exciting. And so you can see, maybe if you look close, you can see that the colorization on these went away, because those are no longer escaping double quotes. Those are now part of the content.
Part of content.
Yeah.
Everything in there is part of the content. But Dustin, that someone would say, what if you want 3 double quotes in your content? What if you paste something in that has 3 double quotes? Then it's going to get confused, right?
Yeah, then it gets confused, and this now ends it, and that's a problem. So in the spirit of C# 11, I would say just add 1 more.
Yes, take it to 4.
Yeah, take it to 4. And so now you can do exactly that.
Always contain any content by just putting more double quotes around it than it needs. Really cool.
We can also make these multi-line by introducing. But the problem with that, or not the problem, but there's one restriction that this guy has to be on its own line.
Yeah.
And we will clean up the front and the back of that. And so if I come in here and run this, you'll see that this is now multi-line. But this is always annoying too, doing multi-line, because
they go to the margin.
They always go to the margin. And so if this were in a method body, I would be slamming this against the left side to try and strip the left. Or maybe I was clever and wrote code to do that, which seems also not in the right direction. So, but I can indent these just fine. And if I also, indent the trailing delimiter, you can see this little line, if you can make that out. That's what that's doing, is that's showing you where it's going to trim the left margin.
Yes. So this has a left margin trimmer built in, which you can control with the end quotes there to see what it is. And so we're out of time.
Here we are.
But we should just mention here, there is a story for interpolation of these guys as well. So you want to copy paste something and then start poking holes to compute values and insert their string representations. That's all there as well.
Awesome.
Okay. So with that, thanks for watching. Many more C# features. Go and play with it. And if you haven't already, send a quick tweet so that we can get questions here right now from Richard Campbell over there in the corner. Richard, how are you doing?
Nothing like language geeks for breakfast. Hi, I'm Richard Campbell, and we got some great questions for Mads and for Dustin. I'm going to start with this one right here from Jay Sakamoto. It was one of the first questions that came in asking, is C# 11's required and init property effective for property injectors, like inject foo service foo of get and init on my Blazor code? Because if I could get rid of the workaround null bang, I'd be a happy person.
That's a very specific question.
Highly specific platform question.
Blazor people want their love, man.
I assume they do. Yeah.
So I would say go try it.
Yeah.
But
I mean, the required
C# 11 code is going to C# 11 features show up in Blazor.
Yeah. So exactly. So I can't see right here without looking at it whether.
No, it sounds like something you should try. Right.
Yeah.
Right. Take it out for a spin.
I would say if you've been writing null bang and that works today with an init only property, I would say it almost certainly works to take the null bang off and do a required property.
Yeah, some code brings you love, Dustin, and some doesn't. And you guys have shown some great things. So I'd be excited to take those all out for a spin. I hope Jay Sakamoto does as well. Let's grab another fun one here. This is from Maran, whose name is Upside Down. And he says, does the C# 11 required keyword participate in inheritance too? Is it possible to override it?
That is a great question, because this was like the source of like 90% of our design discussions.
There's a lot of discussion around
Yes, it totally, requiredness is inherited. So your derived class will definitely also require your required things. There is we discussed, to what extent should this be overridable and how granular should that override be. And in the end, we said, okay, we don't know that there are scenarios for very granular override. So we put in an attribute called set required members attribute. And if you put that on a given constructor, then that is exempting that constructor from the requiredness of the member. So essentially you can say, this is a special constructor, like a copy constructor. This initializes all the things, even the required things. So when this constructor is called, don't give them errors for not initializing. That was the override that we picked. We can always refine that later. I mean, that's a C# again already next year, but we want to see solid user scenarios to make that worth our while, essentially.
Yeah, that's exactly right.
So great question.
Yeah, and I really appreciate all the thoughts you guys have on these particular problems. Watching your presentation hit me right away. How many of these features that you get to show today, you've actually been working on for years. You know, I know you put out C# 11 just this time last year, but I got to think some of the things I saw today, especially around generics, they've been worked on for a long time.
Yeah, the abstract virtual statics, or the abstract statics and interfaces, that feature was actually prototyped the first time over a decade ago.
Sure.
Yeah. That was back when it was all, you know, the classic .NET runtime, and we didn't have the same ability to evolve the runtime. This really needs tinkering with the runtime itself, not just with the libraries or compiler. And we couldn't do it back then, so we had to not do it. But it's been on the radar for that long.
Yeah, and it occurs to me doing the history of .NET work, like generics have been part of .NET since the very beginning. They were part of the original specifications written in the late 90s. So it is cool to see these things still surfacing that were part of the thinking right at the very beginning.
Yeah, I mean, essentially we're trying to stick with the spirit of C#. The really core ideas that were there from the beginning, we keep trying to refine those, and we keep trying to do our design in the spirit of those, even as we take C# in a direction certainly of more terseness and brevity, kind of make it feel more lightweight and more approachable for new adopters as well. We try to keep those core concepts, you know, rally around those rather than, you know, slam things in.
Well, Mads and Dustin, you guys hit me hard first thing in the morning. I'm glad I had a cup of tea early because it got me thinking about a lot of stuff. Thanks so much for putting this great presentation together. Hey, there's our first talk for day 2. I hope you really enjoyed it. Make sure you hit .NETconf.net and do the survey. Without the survey, we don't know what you like, what you don't like. We can't find out all those things. And check out our great sponsors. Without them, none of this would be possible. They have some awesome swag bags. The draws will be coming tomorrow, so we'll be winning some cool stuff there. And don't forget your subscription to Code Magazine. The link's right below me. Coming up next is Stephen Taub, the wizard of performance tuning. And he's going to be talking all about performance in .NET 7. It's amazing to me that the code base continues to evolve and keeps getting faster. So the code you wrote yesterday on 6, running even faster on 7. There's nothing that can compare to that. Like, there's very few platforms that actually get faster as they age. But we keep seeing this version over version over version. New numbers, new speed. It's really a remarkable thing to see, and I can't wait to see what Stephen's going to be telling to us about. He's on Teams, so we're going to see him from remote. I'm Richard Campbell, and I hope got him here with us. Doing that technology thing, you know, it's always fun to have all these different pieces working together, but we're good to go. So talk to you at the end of this session.
Thanks a lot, Richard.
All right.
All right. Thanks a lot, Richard. It's great to be here. It's always hard to follow the Mads Dustin show. They're wonderful to watch, but I will try to do my best. There's nothing I like more, at least in the technology world, than talking about making things fast. And there is a lot to talk about in terms of making things fast in .NET 7. As some of you may know, I've taken it upon myself every year for the last 5 years or so to, towards the end of each .NET release, getting ready to ship, sort of documenting the myriad of performance improvements that have gone into this release. And I did that again this year in August. And if you were to print it out, it comes out to more than 200 pages, just sort of highlighting how much stuff from a performance perspective has gone into this release. If you haven't read it, I'd encourage you to. But the reason I bring it up is to say there are huge numbers of improvements. There were over 500 pull requests and improvements discussed in this PR. That's only a subset of the ones that there are. Obviously, I'm not going to talk about 500 different performance improvements in the course of 25 minutes. So instead, I've pulled out just a representative few and sort of tried to up-level them a bit to look at them through sort of a lessons learned, or how we think about the kinds of performance improvements we want to make in a given .NET release. And I should say, when I say we here, I don't just mean those of us on the .NET team or those at Microsoft. Many of these performance improvements, over 1/5 of these performance improvements, have come from folks outside of .NET, outside of Microsoft. We have a wonderful .NET community, and if you're not already participating in the .NET repos, I would highly encourage you to do so. So with that, let's dive in. So the first sort of category here is about trade-offs. For those of you who aren't familiar with the English idiom of having your cake and eating it too, it's all about having two things that are sort of diametrically opposed, and you find a way to have both of them rather than having to choose between them. And a really great example of that when it comes to .NET and managed languages typically in general is around JIT compilation. So with a JIT, where you're compiling all your code as part of the process's execution, you have this trade-off to make between how much time do you spend fully optimizing your code and how much time do you spend at startup. So you want to get really great code quality, but that requires more time to compile it, to analyze it, which then negatively impacts your code actually getting going. So one of the technologies that was introduced in .NET Core 3.0 is tiered compilation. This is an instance of having our cake and eating it too. With tiered compilation, we actually allow the JIT to compile a given method multiple times. It can compile it once and do so with basically few optimizations enabled, as few as it can muster, such that it can compile it really, really fast and doesn't have to spend any time on analysis and optimization. And then if it finds that that method is on a hot path and it's getting invoked over and over and over, it can recompile it, this time with all the optimizations it can possibly throw at it, backpatch the application such that all further invocations take that highly optimized route. And this gives you a really great startup without sacrificing code quality. In fact, you can even get better code quality with this, because when the JIT does that initial what we call tier 0 compilation, it's able to instrument the code for a variety of things. Not only can it instrument it for the number of times the method is being invoked in order to determine when it needs to tier up, but it can also instrument it for other things. For example, with a given interface, what is the concrete type that is typically being used for that given call site, and it can optimize based on that, and other things that it can learn about the method from that initial invocation. Now, the problem where we haven't been able to have our cake and eat it too is that this doesn't apply to all methods. There's a category of methods that could actually be really important for throughput, that could be really long running, where optimizations could be really valuable, but that aren't frequently invoked. And if you imagine a method that has a loop, you could be sitting in a really tight loop doing a whole bunch of processing, but only invoke that method a few times or even once. Your main method, for example, is typically only ever invoked once in your process. And so by default, tiered compilation was disabled for methods with loops until now. So in .NET 7, there's a new technology as part of the JIT called on-stack replacement. And this, again, lets us have our cake and eat it too. In addition to tracking how many times a method is invoked, it also instruments loop iteration counts. And when a loop has iterated enough times, the JIT is able to generate a brand new optimized version of the method, jump from the unoptimized code into the optimized code, transferring over all the relevant local state, and continue executing there. And as a result, we're able to have tiered compilation for all of these methods, including ones with loops, which we couldn't in .NET 6. So let's take a look at this. I've got a very simple example here, trivial code, not something that you would actually write because it's computing something you already know. 10,000 times we're looping through all of the characters, 0 to 65,000, and we're checking and counting how many of them are ASCII digits, basically the numbers 0 through 10. Obviously, the answer is 10. We don't really need this to compute it, but it's some computation to make an example out of this. So let me run this. I'm going to build this for .NET 6, and I'm going to build this for .NET 7, and then I'm going to run this on .NET 6. And when I do so, we can see it's computing an answer of 10, and it's taking just over half a second to do this computation. Now, this is with tiered compilation, but loops are off by default. And if we saw my method here, it's just a main method with a big loop calling this little helper function, but this function is only ever going to get invoked once. Now, if I were to override that default and I were to set .NET TC quick JIT for loops, Now I rerun this, and we can see because that main method was opted into tiered compilation, now it's taking over a second because it's unoptimized, but it's not being invoked enough times to tier up to tier 1 with fully optimized code. If I instead run this now with .NET 7, note I'm not unsetting this environment variable, which is actually set by default. Now when I run this in .NET 7, not only is it not taking a second, but it's taking even less time than it did on .NET 6. So now it's taking less than half a second to compute the same results. And more so, I can even fully understand what's happening by taking advantage of another set of new features in the JIT, which is that the JIT can now tell us information about what it's doing and when. So I can say .NET JIT disassembly summary equals 1. And now when I run this, we see that the JIT has output a line for every method that it compiled. Now, obviously, in order to run Hello World, it's actually there's actually more than 7 methods that are running as part of my application, but most of them are coming from the ready-to-run images that are shipped as part of the core framework. The JIT had to compile these 7 methods for a variety of reasons, and we can see one of them is my main method, and indeed, it started out at tier 0, and then because it was executing the loop so frequently, it very quickly tiered up to a tiered 1 with on-stack replacement. And in fact, I can go further than this. I can say not just JIT disassembly summary, but I actually want to look at the assembly code that's generated for my main method. Now when I run this, I will see that there are 2 blocks of code very quickly spit out. And if I scroll up through this, all this assembly code here, I can see that first, I have an assembly code output for tier 0 compilation with minimal optimization. And we can actually see that these optimizations aren't kicking in. If I scroll down a bit, we can see that there's a call to that one-line trivial helper function, which you would normally expect to be inlined. But inlining is one of the optimizations that's disabled as part of tier 0. So in my unoptimized code, I see that I indeed have a call to that function. If I then scroll down to my next block of code, we can see it rejitted that method. Now it's using optimized code. And if I scroll down to approximately where we saw that call, now I see these few instructions. And if you know your ASCII table, the character 0 is decimal value 48. So this is that inlined is ASCII digit, subtracting character 0 and comparing against the number 9. So on-stack replacement and as part of tiered compilation is a really welcome addition to .NET 7. Another example, another category of lesson learned is if you're writing libraries, or you're writing services, you'll often deploy, and then you'll find that your consumers end up having to sometimes rewrite the same functionality over and over as part of consuming your work. And an example of this comes with reflection invoke, for example. So reflection invoke, you use reflection to get something like a method info, and then you want to dynamically invoke it. So you call method info.invoke, you pass in your object array of arguments, you get back your object result. It's very dynamic. It's also relatively expensive. And in order to work around that expense, we found that a variety of consumers of .NET, including ourselves and our own libraries, were spending a little bit more time at startup to use reflection emit to actually generate custom little invocation stubs where once at runtime we learned what we needed to know about the method, we could generate a custom invoker just for that method, and then we would have a delegate to that custom invoker that would make it really fast. Well, we don't want everyone having to re-implement all that functionality themselves. So in .NET 7, we've implemented that as part of reflection invoke. So I have a simple little demo here. I have 2 methods, one that has 0 arguments, one that has 1 argument, and I'm just doing a benchmark that over and over is going to invoke them using reflection invoke. And if I compare the runtimes here for .NET 6 versus .NET 7, we see the 0 argument version where on .NET 6 it was taking about 45 nanoseconds. It's about, 7 times faster, 6 times faster on .NET 7 by having this reflection emit functionality built in. And similarly for the 1arg method, with what was taking 82 nanoseconds on .NET 6 is taking about 20 nanoseconds on .NET 7 for about 4 times faster. And this is just one of those things where you upgrade and all of a sudden, if you're doing this in really hot loops, you're going to notice a performance boost. Moving on, another category that is sort of near and dear to my heart is it's really easy after you've implemented a solution to a problem to forget that all the research you did, things may have evolved since then. and there might be a better solution available to your problem. And you can see all the research going on in academia and in various corporate think tanks and work groups. There's a lot of interesting research happening in computer science that we need to reconsider every release. Are there areas we could improve based on that research? So one example where this impacted .NET 7 is some research from MSR, actually, Microsoft research, that's gone into our regular expression engine, or some really nice new math, basically, that came out of, I believe it was JP Morgan Chase, around how to do some math around calendars. That's allowed us to improve some of our core primitives in date time, getting the month, day, year, stuff like that. And then some lovely work out of a professor in Canada, Professor Daniel Lemire, who he and some of his associates came up with an approach for parsing floating point values about twice as fast. And that is now built into .NET 7 as part of double float triparse. So let's dive deeper into one of these, in particular, regular expressions. So some of you may remember back in 2016, there was an outage at Stack Overflow, where for, I don't know, it was 20 or 30 minutes, the system was down. And Stack Overflow released a really nice postmortem after the fact, detailing what went wrong. And what went wrong was a regular expression that hadn't been fully validated for its performance characteristics, getting past a particular input that basically spiked CPU on all the front-end tier servers. So what I've done here is I've just extracted the details from that post-mortem. I've got the particular regex here and the particular input they described, which was basically 20,000 characters. And in the bad case, it was 20,000 characters that did not end in a white space. And now I've run this on .NET Framework 4.8, .NET 6, and .NET 7 using the good input. So we have two inputs here, a good input and a bad input. And now if we look at just the good input, we notice something really nice. .NET 6 is about 10 times faster than .NET Framework 4.8. .NET 7 is about, 15% faster than .NET 6. Yay, we're making forward progress. Now we try the bad input. And the good news is .NET 6 is still about 4 or 5 times faster than .NET Framework 4.8, and .NET 7 is more than 2x faster than .NET 6. Woohoo! You can see the downside here, or the bad news. The bad news is all of these numbers are like 14,000 times worse than the good input. There's this huge disparity here. And that's what this research has gone into address with a new option in .NET 7 that is regex options.non-backtracking. This is a fully implemented engine that's able to support most, not all, regular expression constructs. But if you limit yourself to that subset, it has this exact same semantics as if you're using the regular backtracking engine, so you can switch back and forth. And the important thing two important things to note, actually. First, for the good input, it is a little bit slower than at least the .NET 6 and .NET 7 implementations. In this case, for this particular input, it's about 5x slower. So this isn't always necessarily going to give you the best performance. However, you notice that for the worst case, it is orders of magnitude faster than all of the other numbers. And in fact, it is exactly the same whether it's a good input or a bad input, subject to minor noise in the benchmarks. And that's the really important thing with this option. You get the same semantics as with the backtracking engine, but you get consistent performance regardless of the input that's being provided. Some really exciting work in .NET 7 here. Another category of work is sort of, or of improvements is thinking about all the places that we can reuse existing functionality. As developers, we like to kind of hand roll things, but often if you just take advantage of the built-in helpers for things like searching with index of, every release, when we make those operations faster, anyone who's relying on those operations themselves gets faster. And so we've done work in this release to not only improve those primitive operations, but also use them in as many places as we can in our own code, such that not only your code using it gets faster, but our code using it gets faster, and then your code using those indirect uses gets faster, and so on. So here's a simple example. We did some improvements in the vectorization of index of, for searching strings, spans, etc. In this particular case, I've got the complete stories or works for Sherlock Holmes from Gutenberg, and I'm searching for elementary, my dear Watson. And you can see in this particular case, when I search for elementary in .NET 6, this was taking about a millisecond, and on .NET 7, it's taking only about 57 microseconds. So a huge improvement there. what's that, 20x, because we're doing a better job of figuring out exactly what to search for and how to vectorize that search. Similarly for ordinal and nor case, we're also employing a better form of vectorization now, and so this also gets about four times faster. Continuing in that theme of taking advantage of these helpers, any place where you're not, it's worth reconsidering, are there workarounds that you've employed where you'd be better off just getting rid of your workaround and going back to the original thing. So here's an example of that. This comes from some real code, which I've simplified down. If I want to look to see whether a URL begins with https://, I can use starts with, ordinal ignore case, because I don't care about whether it's capital HTTP or lowercase HTTP and so on. Now, at some point when someone wrote this code, they must have benchmarked this and realized that they could do it faster if they just open coded it, if they just did it themselves. So we have they're checking the length here to make sure it's at least 8 characters. Then they're doing some really cool ASCII tricks, recognizing that the uppercase ASCII letters differ by only 1 bit from their corresponding lowercase letters. So if I just OR in 0x20, I can do a single comparison for each. And they probably benchmark this. And in fact, when I benchmark this on .NET Framework 4.8, I see indeed the open-coded one is 10 times faster. Woohoo! Good day's work. 2 nanoseconds instead of 20 nanoseconds. But then let's say we run it on .NET 6. Well, it's still faster, but both of the numbers have actually gotten faster. The 21 nanoseconds has dropped to 6 nanoseconds. The 2 has dropped to 1. Still better, but is it worth it? Maybe. Depends on the use case. Now we go to .NET 7. And now, not only is the open-coded version way more code to maintain, it's also twice as slow as the built-in implementation, where the JIT is now recognizing these patterns and is able to generate the most optimal implementation it can muster for the simple version of the code. And so anytime you're employing these kind of workarounds where you want to revisit them and figure out whether we can just make the central thing better, everyone can use the central thing, and anytime it gets better, everyone's code gets better. And speaking of getting better, another important lesson is no matter how much you've optimized, there's always more opportunity. There are always new things you haven't explored. Maybe there are improvements elsewhere in the system that you previously dismissed because they're too slow, but now they're actually highly optimized and you can take significant advantage of them. And a great example of that, again, comes from regular expressions. So here is this particular benchmark. Isn't actually one that I came up with. This is from an open source repo that's comparing the performance of regular expressions across a whole bunch of languages and frameworks. So I've just copied that expression as well as the input that repo is using. And I'm counting how many times an email address, which is what this expression is meant to find, occurs in this input text. And if I run this on a variety of previous releases of .NET, we can see on .NET Framework 4.8, this was taking about a second. You go to .NET Core 3.1, it improves by about 10%. That's pretty nice. You go to .NET 6, and oh man, it gets what, about 20x faster at about 49 milliseconds. And then you go to .NET 7, and it gets even orders of magnitude faster at about 620 microseconds. But then there's even more opportunity. So one of the things we've done in .NET 7 is introduce a bunch of additional methods onto regex for doing both specific operations like counting, which is what I want to do here, or enumeration without actually allocating, sort of amortized, non-allocating matching with regexes, as well as be able to pass in spans that I can slice or get from wherever it may be. Maybe I stack allocated some memory, or maybe I got some data from native code. I no longer have to copy it into a string to search it. I can just pass a span directly into the regex engine. And now when I just change the code to use this simpler code, it's also faster. It got about 20 microseconds faster, and you'll notice that lovely allocated column is blank. That's because there was nothing allocated as part of this operation. So there is always more opportunity. And then finally, one last category to think about, and there are many more than this covered in the paper, but one more for this presentation, is being thoughtful about your defaults. And we strive, when we design APIs, when we design language features, we try really hard to come up with good defaults, where if someone uses something, they're going to get kind of really great average case behavior, average case performance out of the box. We don't always get it right, and I imagine you don't always get it right either. So it's worth thinking about those defaults both for new things and revisiting previous choices. And an example where we revisited a previous choice in .NET 7 is with compression, and specifically with broadly compression. Broadly is a compression algorithm from Google. We've been shipping an implementation, a Broadly stream type and Broadly encoder and decoder in .NET since I believe .NET Core 2 or 2.1, around there. And if you look at the Broadly compression algorithm, like many compression algorithms, it has a knob you can turn, a dial. In Broadly's case, it goes from 0 to 11. And on one end of the dial, you have really, really, really fast compression, but maybe not the best compression ratio. So maybe you end up with a larger output. And at the other end of the spectrum, you have the smallest possible file size or output size it can muster, but it might take a really long time for it to figure out how to optimize it fully. Now we can see I benchmarked both size and time on a particular file in this case, and we see from 0 to 11 a nice sort of linear progression. Excuse me. As I turned up that dial, going from about 2.5 megabytes down to about best compression ratio down to about 1.7 megabytes. But on the time, we see not so nice a linear scale. In fact, towards the upper end, it starts looking extremely exponential. Now, the problem is that in prior to .NET 7, we chose a default of 11. Which meant that by default, if you just said new Broadly stream, you were getting the rightmost side of these graphs. That meant best compression possible, but also absolutely abysmal throughput. So with one of the smaller significantly performance impacting changes in .NET 7, we basically changed our default from 11 down to something more in the middle, around 4. Now, this does mean that by default, your output sizes might be a bit larger. In fact, if I run a simple benchmark, we can see that for this particular input, the resulting output is about 20% larger than previously. Now, all you have to do is set a compression level, and you can get exactly back to what it was before. So we're just changing the default. But in exchange for that 20% increase in size, we have about a 50 or 100x, about 50 75, I don't know, I can't do math off the top of my head, somewhere between 50 and 100 x improvement in throughput. And we think this is a much better use of your time when using Broadly as part of your algorithms. So that was just a really, really quick tour through just the tip of the iceberg. If you have a few moments or maybe a few hours, I'd welcome you to go read the blog post about .NET 7 performance improvements. I'd welcome feedback. We'd love for you to actually get involved and contribute to the next incarnation of that paper by contributing pull requests to .NET 8, which we've already started working on and which is going to be an amazing release a year from now. So thank you very much. Back to you, Richard.
Thank you so much, Stephen. You blow my mind as always. I can't believe the ongoing performance improvements we continue to see from C#, and you got some great questions coming in from Twitter. I'm going to start with this one here from Menham asking, let's dive deeper because he doesn't know we're already feeling like we're at the bottom of the ocean. Okay, not a question, but boy, oh boy, he's not wrong. He had another question, which I thought was a little more technical here. Same fellow. Aren't there some cases that this type of looped optimization in .NET 7, which Stephen's talking about, actually involves some logical bugs?
To my knowledge, there are no cases where we introduce bugs. If there are, that would be a bug that we should fix.
Yeah, I would presume so. And you always have a test suite for all of that as well, right? Whenever you do an optimization, you match behavior exactly in the new in the optimized version.
Yeah, every PR we run a pull request, we run about 8 million tests across multitude of operating systems and versions of operating systems and so on. Plus then kind of not as part of PRs, we have an additional set of tests that we run kind of on a rolling basis on a huge number of platforms. Now, there are always gaps. There's always the possibility that we'll introduce bugs, but we have a very, very large test suite in order to try to catch these issues. Some slip through. That's why we have servicing releases, where every month we will ship bug fixes for things that are either brand new in that release or maybe that have been latent for many, many years and are only just noticed. But if you do find a bug in how the JIT is compiling loops, we would love, love, love to know about it. So please open an issue in .NET Runtime repo. Yeah, and so GitHub's there for a purpose, right? We'll be able to put the issues in directly to you and see them directly addressed back again. Hey, let me give you a little more philosophical question as well, which is, why didn't you optimize this stuff in the first place? That's a great question. I mean, we strive to optimize things in the first place. In some cases, there are opportunities where we just didn't notice them. Maybe we got smarter or we learned from other people. For example, the index of case. There, we're actually taking advantage of a really nice algorithm that was designed by someone outside of Microsoft that's become really popular amongst various frameworks and languages in recent years. And so we're taking advantage of, we're building on the shoulders of giants, taking advantage of somebody else's work there. In other cases, we're able to build on our own shoulders, work that we've done in previous releases to improve sort of lower level things or add new lower level constructs that we can then use elsewhere in the libraries. For example, we did a lot of work in .NET Core 3.0 and .NET 5 to add literally thousands of new methods that represent direct hardware instructions for doing SIMD. And then in .NET 7, we added new Vector 128 and Vector 256 APIs for at a higher level for taking advantage of all of those hardware instructions across platforms. And anytime we add those kinds of intrinsics or helpers, we can then go and take better and better and more advantage of them elsewhere in the platform, finding more and more opportunities to sort of leverage those underlying performance benefits. In other cases, it's research. I mentioned all this stuff coming from MSR or from other companies or from academia. There's always more opportunity, and as much as we try to get it quote, quote, right the first time, invariably there's always more to do.
I really appreciate your point that computer science research continues to go on, and MSR bringing you things and moving that hardware underneath you so that you now have to take advantage of it. I get that too. I was also thinking that sometimes your customers use your product in a way you've never thought of, and it introduces a new optimization opportunity.
And in fact, many of the performance improvements that come from outside of our team are things where we just weren't looking at it. Someone else had they were using some code path that we weren't focused on, and it ended up being a bottleneck for them. And the beauty of open source is they can come in and contribute a fix to something we may not have touched or may not have realized was even an issue, and they can improve it not only for themselves, but for everyone else that happens across that code path in .NET.
Wow, I can't imagine trying to do my own optimizations to the code base. That's stunning to me. But I guess it's a possibility. Does it happen very often?
It's actually pretty common. About 20% of the performance improvements that I sort of document in my paper came from outside of our team. And a lot of times it's removing an allocation here or finding that some code here could have a fast path that's actually quite common. Or there are certainly some of the more intricate ones, someone going in and actually adding an optimization to the JIT. Those are more impressive generally. But there's a wide spectrum, and we love them all.
Stephen, I'm wowed as usual. Thank you so much for your contribution to .NET. I love that my code runs faster with each new version. And we've got to move on to the next subjects, but make sure you do your survey. Links below me here. We need that feedback to know exactly what's going on. And don't forget our great sponsors. They've put together some awesome swag bags. And if you do the secret decoder, tomorrow we'll be doing a draw. Now it's time for me to hand over to Jared Parsons, talking a little bit about how language features actually get built. So if you wanted to understand how the plumbing works, we're talking to the right guy. And I'll talk to you afterwards.
All right, hey everyone, my name's Jared Parsons. I'm the C# compiler dev lead as well as a member of the C# language design team. And here we're here today to talk about let's design a language feature. And what we want to do in this session is kind of pull back the curtain a little bit and show you kind of how the language design process works. How do we start from a problem and an idea and get through all the twists and turns to a shipping feature that we deliver as a part of the .NET and C# releases. And what we're going to be doing in this session is we're going to be using an example of a feature we shipped in C# 11 to kind of take you through that process. And that is file local types. Now, all ideas start with a problem. In this particular case, the problem came from our source generators teams. Now, for those of you who are unfamiliar, source generators are a way that the library authors can plug into the compilation process. They can look at the code you're writing and use it to generate code to augment your application. They can add new functionality. They can add optimizations by moving stuff that used to be done at runtime into the compile time part of the process. And we're shipping a lot of generators with .NET 7. We have like the JSON generator, the library interop generator, and like what we're going to be looking at here today is the regex generator. Now, what the regex generator does is normally when you use a regular expression in .NET, at runtime, that expression has to be parsed. They have to generate all the code to do the matching at runtime. That can impact things like startup. It can limit your optimization opportunities. But now in .NET 7, we have the ability to, at compile time, do all of that work. And you can see here that I have this nice little partial method called getEmailRegX. And I have this attribute generateRegX, which tells the regex generator, hey, here's a regex that I want you to process at compile time. And we can do a nice little go to definition here, and we can look at what this generator is doing. It's taking that regex, it's processing it, and it's generating all this beautiful code here, nicely commented, that's actually processing that regex. And it did that all at compile time instead of at runtime. Significant performance wins for our applications. But the regex, the generator authors came to us because they found a bit of a problem with this approach. Because in order to do a lot of their generation, they have to generate these helper types, like you'll see here, this derivation of regex, getEmailRegX 0. And they said, this is a bit of a problem. We really want these types to be implementation details of our generators. We don't want users depending on them because this is something we want to evolve over time to continue making these scenarios better. But unfortunately, it's a part of the compilation and users can see it. Worse off is that when users are typing, IntelliSense actually shows it to them. It starts leading them down the path, telling them, hey, this is a type that you should use. Look at all these cool members. Take dependencies on them. And this is something they worried would inhibit their ability to evolve these generators in the future. And also, there's another problem. What happens if the user defines the exact same name type that they want to generate in their code? Well, that means that their generated code stops working. And in order to solve this problem, they have to complicate their generation process. They have to start scanning the compilation, looking for any types of that name, and making sure they don't have conflicts. And overall, they felt like that this made the generator scenario a bit more fragile, a bit more incomplete. And they were looking for ways to solve it. But they also had an idea. They came to us and said, listen, why don't you let us write private in front of these top-level types? And the effect we would have there is make that type local to this file. It doesn't conflict with types and other files that other people can't see it. And this is where kind of the language design process starts. We have a problem, and we have an idea for a solution. And it fits in with some of the big themes that we're shipping in the current version of .NET and C#. Now, you may have, at this point, be asking yourself, did I come to the right presentation? The kind of promise this presentation was is going to talk to us about all the problems you hit in the language design process. But it's just one word. This is just one word and one scenario. How hard could this really be to design? Well, first off, let's talk about that word. Because one of the things that we focus on a lot in language design is syntax. And this is a new type of syntax that we have to look at. And one of the first questions we start asking ourselves is this word going to stand the test of time? For example, right now, the idea is just how can we make types local to a file, but a logical way you could extend this feature in the future is making it apply to members, methods, and properties, and making them local to a file. And private's not going to work if we did that, because private already has meaning in those scenarios. So that's just not going to work. The next thing we talked about is, what if we just take two existing modifiers, slam them together, and let's create a new one. And let's use private internal. And this may seem silly, but this is something we've done before. A few releases ago, we introduced private protected to express a new form of accessibility in C#. And it was a very successful feature. But it is a bit wordy. It doesn't really ring the scenario we're trying to get here. It doesn't really scream this is local to a file. So the next thing we talked about is maybe we just use modify private. We say, hey, private was a good idea, but let's give it a little more meaning by saying file private. And this is going to resonate with customers. This reads really, really well, and people are going to kind of get an intuitive understanding of this by looking at it. It's also a bit wordy, though. It is using two words where we felt like one word might be enough. And so eventually we kind of said, let's just use file. File is nice, it's descriptive, it's simple, and it's going to extend to other scenarios in the future should we want it to. And after a lot of discussion, this is where we came out with. This resonated the most with the language design team, the generator authors, as well as the various community members we talked to. And I've made this process a little bit silly, talking about the ways we deal with words. But the look and feel of C# is incredibly important. And we spend a lot of time talking about it, rat-holing, and going back and forth on the ideas. And we spend a significant amount of time on even little tiny problems like this. But the next thing we do, and we did in this case, is we said, hey, Have any other languages done this before? Because if other languages have solved this problem, we can look to them for inspiration. We can see what went well with their implementation. How do customers use this feature in their ecosystem, and what can we learn from it to make our feature better? And when we looked around, we found lots of examples of other languages that do this. For example, F# has the concept of signature and implementation files. Very similar to like header files and C files in C++. But they have this really nice property. Only things that exist in the signature file are visible to other parts of the program. If you have a type that is only in an implementation file, it is limited to that file. And that is almost exactly what we're trying to build here. Has a bit more ceremony involved, but it has the basic properties we're going for. And this is a very successful feature in F#. It's used in lots of programs to wild success. Next, we looked at like Golang. Golang has a similar concept called package level visibility. Their mechanism is a bit different. Uppercase type names are visible outside the package. Lowercase type names only visible within the package. It's simple, but it is very effective, and it is highly used by the Go community. And these are not the only two languages we found this in. In fact, when we looked at other languages, pretty much every language we looked at had this type of capability. And this made us feel really good about this feature. It made us feel that we were going to be using a feature we're designing a feature that was not just usable by our source generator community. It was going to be something that was going to be generally usable by the C# developers. And so we felt really good at this point. We felt like we were on the right track and going the right direction here. So we took a step back and said, okay, before we get further into the design process, one of the things we want to do is establish the core properties of these features. What are the things that the experiences we are trying to deliver when we get to the end game here? And this is really important because sometimes you can get very deep in the weeds in language design, very deep in the spec, and it really helps to have these properties established that you can come back to and say, okay, this is the problem we're really trying to solve. How do we apply it to the current thing we're doing? And the core properties we had here is that if you have a type or a member marked with file, we want to make sure that, first off, you don't have to think about any other name conflicts in other file. What you're writing is what you get, and you can just simplify your world to this file. Also, this type cannot be observed outside of this file. I don't have to worry about people taking dependencies on it. I don't have to worry about any kind of weird conflicts. It is just right here. And lastly, what we're doing should not be observable by other languages. I mean, if we go through all the work of actually doing this in C#, but then F# can see all these types, it devalues the feature just a little bit. So with that in mind, the next thing we often do in language design is we say, hey, can we generalize this? Yes, we have a problem, we have a solution, and it looks like it's going to solve it. But is there a bigger problem we can solve here? Can we tweak this idea just a little bit and get a lot more bang for our buck when we do this feature? And there are two ways we looked at generalizing this feature. The first one was we said, hey, what if we also said, let's make types local to a namespace. Let's have this idea where a type is only visible to the namespace it's declared in. And when we looked around the kind of the .NET ecosystem and even like the C# compiler code base, we found a lot of evidence that this would be a valuable feature for customers. To the point that we got pretty far in this design, but eventually we kind of stepped back and we said, yes, this is valuable. It seems like this would add a lot of good to the language. But it isn't actually necessary for us to ship .NET 7. And we do have a finite amount of resources for innovation in a given version of .NET. So we kind of put this one on the back burner. We said, this is a good idea. It's going to have value. But let's come back to it later, maybe in a new version of .NET. What we spend a lot of time on, though, and what we're going to talk about here, is whether or not we should let file apply to methods and properties. Now, intuitively, this does probably seem valuable. Like if I want to make a file local, a type local to a file, maybe I want to make a member local to a file. But there's a big gap between saying you want something and figuring out how to make that a reality. Like, what do we do in the compiler to make that enforcement real? And the first thing we thought about was maybe we just make file an access modifier. In the same way you have public and private protected, let's just make file a new modifier. Unfortunately, that has a lot of problems. First off, you have to go and change the IL specification for .NET to recognize the bit pattern for file. And then you have to go to all of the languages in .NET and make sure they recognize it. We have to go to F# and we have to say, hey, we have this new access modifier and we really need you to recognize it. And lastly, you have to go and update a ton of libraries. Like, there are a lot of libraries and code that look at metadata in libraries. So you have to change reflection. You have to change like any kind of metadata reader. And ultimately, this is an enormous cost to the ecosystem. And while it would work, and this is a valid way to do it, the cost is just out of proportion with the benefit that we would get from this. But we weren't done. We had another idea up our sleeves. What if we just took those methods and we emitted them with an unspeakable name? So an unspeakable name is a technique where when we admit to metadata, we just put funny little characters, usually less than and greater than signs, in the name. And that is a tried and true way for compilers to say, we want to hide this member from other compilers. This does not have the ecosystem cost associated with it. All the compilers recognize this pattern, and it would give us a way to hide these members from other languages without boiling the ocean. And C# does this a lot today. For example, if you use anonymous types, we emit them with this like unspeakable name where we have that less than and greater than sign as a key to ignore this particular type. Same with anonymous delegates that we generate. And even if you used a record before, part of the with process of records is we have to clone the original record before applying the new property. And that clone member is emitted with an unspeakable name because we don't want people using it. We want that to be an implementation detail of the compiler. And we could apply the exact same logic to file members too. If you said file void create, we could emit it with an unspeakable name. That would make it invisible to other languages. That would make it local to the file and really kind of achieve those goals we were going for here. Unfortunately, we found out that when we dug into this, that this has a number of side effects that are really unfortunate because a lot of features out there depend on the name you emit from members matching the name that the developer wrote in code. For example, interface hookup depends on name matching. If you're doing any form of reflection, like data binding, the developer needs to know the name that they wrote is the name that is in IL. And even C# features like dynamic depend on the names matching. And so while this would work, we could implement a like coherent feature here, it would massively subvert user expectations and break other scenarios. And we decided that that was not a good path for us to go down. And this kind of ended our exploration of using file on members and properties. We had a couple of ideas on how we could make it work, but we decided the cost was just not in proportion with the benefits of providing it. And so the final design we came up with this feature was we were going to give the developers the ability to annotate their types with file, and those are just going to be very local or private to the file they're declared in. And at this point, you might be saying to yourself, like, isn't that where you started? Didn't language design just go in like a big circle here and spend about like a couple of weeks doing it? And largely that's true. Modulo changing private to file, we ended up basically in the same place we started. But this wasn't wasted time. Along the way, we looked at other languages. We gained confidence that this is a general purpose feature that people are going to benefit from. We explored new features that we could do in the future in the form of namespace local types, as well as we charted a path forward for how we could extend this in the future to apply to members. Yes, we ultimately decided the cost wasn't there this time, but it could be the cost dynamics could change in the future. So while we did end up where we started, we have a better understanding of kind of what we're shipping. And we should always do this. We should be pushing the boundaries in design and trying to generalize. Sometimes it works, and sometimes we find a much bigger set of scenarios that we can tackle. But sometimes we end up largely where we started, and that's okay, as long as we kind of get this enhanced understanding as a part of that. But we're not done yet. As I said earlier, we have to find a way to kind of make this work. It's great to say that this type is local to this file, but how do we make that a reality? And as we talked about before, naming is the key here. We have to find a way when we emit this type into metadata that it has a name which is local to the type. And this name has to have a couple of properties. It needs to be unique per file, it needs to be hidden from other languages, and it needs to be the same between builds. If I build my code 10 different times, I need to get the same name every time. That's just a general property of compilers that you have to have. But it does mean we can't do anything cute, like saying that the name is just GUID.new GUID, which would meet the other two properties very easily. Now, when we think about kind of a solution for what are we going to name these types, a couple of the parts of the name are very easy. We need to include the namespace the type is declared in, as well as the actual name of the type. But we need to create a segment that makes it unique to that file. That little part right here. We need to figure out what that is going to be. And we talked about a couple of ideas for this. Firstly, we said, why don't we just make that the file path? After all, that's the whole point here, is to make it unique to the file, and the file paths are unique. Well, unfortunately, file paths have a couple of properties with them that are bad for us. One, they have an unbounded character set. Every file system defines what is legal for them. And many of those identifiers and characters in file paths are not legal as names and metadata. Also, paths can be arbitrarily long, to the point where it would kind of exceed the limits we have for identifiers in IL. And so we kind of discarded that as a solution. Then we talked about, well, why don't we just use the file name? We could force that to be unique, right? Well, that also didn't really work, and we had to kind of discard that as a solution because file names can be duplicated. But then we kind of stepped back and we thought, and we said, okay, every time you compile, files are passed to the compiler in the same order. So instead of using the path of the file, why don't we just use the index to where it was passed to the compiler? So as you can see here as an example, when we compile this simple program, we have 3 files, application, data, and container. Container is the 3rd file, so it has index 2, and we can just use that as that unique little segment there. And that works great. That actually solves all of our problems that we talked about earlier. We now have names that are local, unique to the file, and we have a way to implement this feature. But at this point in time, we did something we do with every feature, which is we involved the rest of kind of the C# IDE team. This is the team that is building kind of the Visual Studio and VS Code experience for C#. And we involve them because when we ship a feature in C#, we don't just think about kind of the language and the compiler. We think about the ecosystem of features that make up that developer experience, because we want these features to pop everywhere that you can use them. And they pointed out a flaw in what we had done here. They said, hey guys, we have this really awesome feature. It's called Edit and Continue. And you know what you can do with Edit and Continue? You can add and delete files from a program. So that customer, they could just say, hey, why don't I just delete data.cs? That in turn is going to change the order of files passed, change their index. That type name is now going to flip to have a different number in it, and that's going to result in a ton of root edits. And this is a big problem, because Edit and Continue is a super valuable feature for our customers. And we just inadvertently made a design which basically made Edit and Continue extremely hard to get right. But the benefit of involving more voices here is they came to us and they said, hey, what other ideas did you all consider? Let's talk it through. Maybe we can help you out here. And we walked them through the process we'd gone through, the ideas we discarded. And they said, hey, file paths were actually a good idea, but why don't you just put them through a checksum first? Once you put them through a checksum, it'll be unique on one side, unique on the other. Also, it'll have a fixed character set and a fixed length. And that solves all the problems you all originally had with file paths. And they were right. It was a fantastic suggestion, and it ended up being what we shipped. We now take the file paths, we pass them through a SHA-256, and use the result in IL. Now, that name is super unreadable compared to the ones that we were talking about before. But at the same time, it doesn't matter. This is an implementation detail of the compiler. What matters is we now have a mechanism to implement file local types. And with that, we essentially have the solution that we were going for. And now we can kind of see that solution in action. So if we go back to this original example where the generator author said, hey, we want to use private, you can see that we have all these errors here because of the duplicate type names and such. Well, we can now just flip this over to file. And you can see immediately the errors go away because there's no longer a duplicate type problem. This type is specific to this file. It is completely isolated, and the generators can think only about this file when they are writing their code. Even better, when we flip over here, you can immediately see the error squiggles change because this class no longer conflicts with the one that the generator was producing. And as a result, we have an error up here because there's no member instance on this type. Now it's even more fun is we go up here, if we start typing like we did before, notice IntelliSense is not offering me to use get email regex because it is specific to the other file. It is not available here, and as a result, IntelliSense is hiding it. But it's not like we hide it all the time. If we go to places where it's legal, we can see IntelliSense is happily suggesting it to me. It's showing me it's there for me to use. And so now we have kind of solved this source generator problem. We have made this overall scenario a lot tighter, a lot more reliable, and we've also provided a feature that customers can just use generally in their C# code. All right. And so thanks so much for being a part of this session. So I think now we're going to flip it over to some Q&A questions.
Thanks, Jared. Awesome stuff. It's amazing that we're still talking about files today. You know, it's not something that ever goes away, although I'm talking to kids these days using technology, and I hate to say kids, but I'm in my 50s, so I've been doing this a long time, and it seems like a younger generation user doesn't even think about files, even though we know they always exist. So I'm really impressed with the work that's going on here. Is this a feature that was really driven by user demand, or did you feel it needed to be addressed?
So this is a feature that we've had kind of rumblings for in the past. Like there has always been a bit of a desire to say, hey, as programs have gotten bigger and bigger and bigger, how can I effectively, we have great mechanisms for hiding code between assemblies. You can use internal or private and keep code isolated to an assembly. But as assemblies have gotten bigger, customers have pushed on us on ways of how can I isolate parts of my library or parts of my application so that they just don't inadvertently talk to each other in ways I didn't want. And we've had numbers of suggestions over the years. Early versions of the Roslyn code base, we actually had a unit test where we would dig into all of our admitted code and make sure that certain namespaces weren't talking to each other. And so we've had rumblings on this for a long time, but we've never just had that push to get us over the edge and say, all right, it's now time to invest in this and make this a real feature. The generator scenario was one where it finally gave us that push. It's a feature we've kind of wanted to do before, but now we have a compelling scenario that is part of one of our big themes for .NET 7 that could really kind of put a nice little bow on that whole thing. And so that's what kind of gave us that push to go over the edge and design and ship this feature.
And at the same time, you're banging right into that sort of hardware versus software thing. I mean, fundamentally, a file is a singular entity. So you really don't want to have multiple pieces of code trying to touch it at once. Like every time you run into that separation between what we can run in multi-instance parallel and so forth versus what's physically on a disk, that's got to be a problem.
Yeah, it can definitely be a challenge. Files are really problematic. And even if you think about the fact that Roslyn, the compiler, is actually an API.
Mm-hmm.
This is an API that we provide to the IDE team for helping them generate IntelliSense, for users compiling code on the fly. File paths there's not necessarily physical files when you're doing a compilation. Some of these things are just in memory. You can absolutely construct compilations in memory and emit code. And one of the things we really had to struggle with is in a lot of corners, you don't actually need even file paths. You can actually manipulate the APIs and libraries so that you're just compiling code without any paths associated with it. And how do we solve those problems? And those ended up being some interesting challenges kind of in the compiler. But yeah, the mix between physical and non-physical files has really gotten blurred, particularly as we've moved the compiler from this kind of physical command line batch tool to a full-fledged API that we hand out.
Yeah, right. And the concept of a file being separate from the physicality of a file. Because of course the other part when I think about the physicality of the file is now we're stepping out of that managed memory space. We're trying to talk to the operating system. I'm not going to say Windows because it might not be. And how does the operating system actually address that physicality of the file on the drive, wherever that may be, or whatever that may be?
Yeah, it can definitely be a challenge. We have lots of fun with the file system, and particularly having to deal with the fact that file systems are not consistent. One of the ideas we end up with a lot is what do we do with case sensitivity? Because we have to decide things. Are you giving us the same file twice and things like that? And even on a given file path, parts of it can be case sensitive and parts of it can be case insensitive, depending on how weird your file system implementation is.
Well, right away, it's Linux versus Windows. That's the one you're going to run into for sure. But how much of that is owned, at the lower level into the operating system runtime versus what would live in the CLR for you?
A lot of that is handled in the libraries for us. Like, they deal with a lot of the low-level kind of managements of the files and the interactions. We are, at the compiler level, we're a little bit removed from that. We're mostly just opening files and writing them to disk. So a lot of that is abstracted from us. Mostly, like I said, the biggest challenges we have to deal with is just whether or not paths are case sensitive or not.
And I'm actually going to grab a question from the board here. This one's from Inva. This latter part, I think, is very powerful, which is how do we follow these discussions, having really enjoyed your thinking and your team's thinking through a language design feature? Is there a routine way that you expose that to us, that we can actually see those conversations you're having when you consider new design features?
Absolutely. So if you go to the GitHub repo .net/C#lang, that is the repository where we kind of host our language design process. So we have regular language design meetings, typically 2 times a week for 2 hours each. After each one of those meetings, we post notes from that session. And so that's the way to kind of follow the active discussion of the language design team. We also, all of our language design process is done in that repo. All feature ideas pretty much start out as discussions. And then from discussions, we evolve to actual proposals that can be championed by people who are on the C# language design team. And then from there, they start moving through that design process, and you can follow them in the meeting notes. And also, you can just ask questions. Like, most of the language design team is pretty active in the repo. If you ask questions, we can get the right people kind of on there to tell you how things are going and why we have or have not pursued certain ideas.
And I got to think this part of the fun part of that whole thing, exposing that all on GitHub now. That's the new way to work. It's only been a few years you've been like that.
Yeah, we've been on GitHub, I think, about 6 or 7 years now, but it did take us some time to take what used to be kind of this very internal process where we just kind of had internal documents and internal meetings to how do we expose it to the community? How do we get them involved? And how do we even set a path down for them of hey, if you have an idea, these are the steps we want you to take so that we can treat it seriously, invest our time in helping you make that real and start pushing through the process. And we've been increasingly successful over the last few years, as I think pretty much every release now, we have 1 or 2 features that have been very largely driven by community members, from all the way from the design to implementation.
Jared, that's super awesome. Thanks so much for your time. Great talk as always. It's really a great insight. Hey, we got to cut straight over to the next one. I've got a panel conversation to do next, and I get to participate to some degree. So come with me as we come sit with Michaela Hutchinson, Davian Edwards, and David Fowler, real architects in software. Not like me, I'm just a professional storyteller, but somebody has to manage these folks, and I'm going to be able to take your questions directly on the board here as well, so we'll be able to keep going. Let's kick this thing off, guys.
Awesome.
How do you get to designing language features? We just saw Jared walk through a great piece, one particular case, but how much of this is internal inspiration versus what your customers are asking for?
It's a bit of both, I think. It's a bit of both. For example, during .NET 6, we worked fairly closely on the ASP.NET Core features to do with minimal APIs. And the desired outcome for the coding experience that we wanted for our customers with regards to what code you actually write in the CS file in the first 15 minutes of using ASP.NET Core, we were hitting some aesthetic issues. We was we don't want the code to look like that. We want it to look like this. And then the reasons it didn't look like that today were due to language design things. And so we worked with the language team to drive those changes through. So that's one example. Then obviously there are examples where people log issues on GitHub or wherever it might be.
So, and I'm aware, so we've talked about this on .NET Rocks at times too. It's the issues that come into GitHub, that is your meeting, right? That's part of your whole conversation about design for everything.
Every week we triage with the whole team all the issues. We sit around as a team, we sit in the room, we go over every issue, and we decide what we need to put as feedback for every issue. So what's funny about designing features and language design features are, we wanted the code to look a certain way. That seems very easy from the onset, but to actually change the language to get that code to be written is insane. We had to fix issues in overload
resolution,
and we have to fix a couple more things like that. It was very difficult to actually get the changes in to make the code look good. And for us, it was like, let's just make the code look like X. That was
so
a
you
big
sort of drew
issue.
that on the
we
board.
Drew on the board.
It should be
that was
expressed
a
like
vision,
this.
but it was like, then Jared was like, we're going to have to change this and that and this has to gel with that feature and this other feature. And we were like, okay, but in the end, we want this.
It's probably like working with an interior designer.
Oh, yeah.
And the customer is like, well, I want the wall to be this color. And then the interior designer is like, I don't think you understand all the things that have to happen for that to actually work. And I'm not a language wonk by any stretch of the imagination, so it's a very, it's quite an in-depth learning experience when you say, but why can't it just look like this? And then the 400 things that hold about why.
And of course, on one hand, I feel like, are we really that focused on aesthetic? Is that important? But I'm all for readability of code. Is that really what you come down to? Is like, when I look at this, this means what I think it means?
Yeah, a big part of it is syntax. Like, one of the big things that we can do is paper over runtime goop with syntax. So the language can let me do var f equals some function. And for that to work, the language has to infer like 10 things, but the end experience is that f infers the type of function that's being written. And it looks great. And if you didn't know the language design, you would think that would work to begin with. Because like, why couldn't the language infer? I'm telling it the arguments, the return type. Why is that hard to do?
Yeah.
And then you dig into the actual design, and you sit in the room with these people that built the compiler, and you understand. You're like, okay, whoa. Okay, that case. Okay, this case. Okay, generics. Okay, open, close generics. Object, delegate. Like, which one wins? So it's really complicated.
Yeah, it's a plumbing kind of
It's
problem.
plumbing, yeah.
It's like, it looks like a faucet on the top, but
Yep.
wait till you get under the cap. There's all kinds of things going on down there.
Yep.
Yeah, I'm a huge fan of things doing what you expect them to do, but that's partly about setting expectations and partly about staying true to expectations. So once people get a sense of how it works, they can actually trust that. So every decision you make, you have to evaluate whether it's breaking those promises you've made.
I love that point, Michaela, too, because you're also talking about changing code I already have working, right? When you talk about changing that view, you are talking about, it's quite possible that I'm going to fire it up with the new compiler, and it's actually laid out differently. Like, am I happy? Do I recognize my own code anymore?
Yeah.
The big thing is going from a thing that was an error to a thing that now works.
That is not an error.
Yeah.
We actually changed a bunch of that stuff in .NET in C# 10, I think. And there's a big debate, like, do we want, when people recompile their libraries, that they get this new behavior change? And I think we actually went over and compiled a bunch of code on GitHub, and we found a couple of cases that were like, this library would break if we made this change. And then we have to make a call, like, do we want to make that change? Is it going to be opt-in? Is it going to be a warning? So yeah.
And the longer the language has been around, the more code there is in that language, the harder it is to make those type of changes, because you have to consider so many more cases.
Finger in wind. How many people are using this feature? No one is.
Yeah.
First preview, you broke my library.
Yeah, everybody is. Yeah. Well, and it is always that great debate about you're not necessarily your customer, right? I mean, even though C# is used extensively inside of Microsoft, you're definitely going to bump into folks who use your languages and your tooling different. And I think that brings up a really powerful question. Like, .NET is one thing. It is not just C#. There are other languages. There are the base class libraries. There are the APIs. And there's the runtime. How often does the conversation get into about how do we get this feature, where should it live?
Yes, absolutely. And then even with the context of the runtime or the base class library, there are layers within that as well. In today's modern .NET world, we have we have the BCL, which is the system.star, typically the stuff that ships in one of the runtimes. And then we have Microsoft.extensions, which is a set of BCL extensions, which it's hard to kind of explain the delineation there about.
I would say dependency injection-based libraries that live in the BCL are kind of that extensions-based.
That's fair. That's fair.
Lineage.
And it's stuff that it admittedly started with the development of DNX and ASP.NET Core. And then has moved into sort of its own island that gets reused among a couple different app models since. And then obviously we have the app frameworks on top of that. We have the WinForms and WPF, the existing ones, and then we have ASP.NET Core and other frameworks. And so when it comes down to like where does this live,
right?
And whether do we utilize, say, the runtimes type system, or do we utilize language features in order to allow expressiveness and to build constructs that people can then build their apps on top of? We debate this stuff all the time. Like, should this be a base class that you inherit from? Should it be an interface that you implement, or should it just be a language feature that you utilize in order to take advantage of this mechanic? And that's, as sort of designers, something that we do quite often.
And there's not one right answer, right? Like
No.
many of these things could have been implemented any of those ways.
Absolutely.
Or do you put it in all the places?
Yeah.
Do you rate limit HTTP client and pipelines and streams? And do you do it in ASP.NET Core? So for rate limiting, we actually put it in the BCL, the core abstraction, the core implementation, and then we built stuff on top in the BCL, in ASP.NET Core to rate limit requests. So we decided that feature was super generic and can be used for more than just HTTP. So we split it into and broke it into like core, implementation, and abstraction in the BCL, and then a feature in ASP.NET Core to rate limit incoming requests. So that's
Now,
pretty often.
Michaela is newer to the architect team. Like I've talked to you guys for 10 plus years. I think, Michaela, we first talked back in it was the Xamarin days?
Yeah, it's been a while. Yeah, I came up from the Xamarin team. I was originally a dev, then became a PM, then kind of ended up in the middle, which is really what an architect is.
You used to have a real job. How'd you end up running with these guys? Like, honestly, why choose to be an architect in this scenario? And I'm just thinking you bring particular experiences to the table for the architects too.
Yeah, so my area of focus is tools. I recently ended up on the tools team, and I'm very happy about that because tools is always an interest I've had about making these tools that help people build things easier. And I like to think very holistically. Like I'm one of those people who, when you try and build something, tells you all of the other things you're going to break when you build it that way. I like to focus on how we solve those problems, not just give you the problems, but yeah, I like things to be consistent and make sure that we can set those expectations for people and make sure that it works for as many people as possible. And being an architect is really the place to be doing that.
Yeah, no, it's an interesting locus of you're also making decisions that are going to impact people for a really long time. So it doesn't come with a light burden. You know, related to that, let me grab this question from Dimitri, who said, who decided that minimal API is aesthetically pleasing at all? Because I think there's an interesting question here about what is the aesthetic. Like, and then you throw in the word minimal, because that's a kind of aesthetic right up front.
Yeah. I mean, there's an interesting history. The one thing we haven't talked about, which I was going to mention as part of language design, is we can't ignore the ecosystem, the competitive landscape. Like, obviously, we sometimes have to react, or we sometimes take influence from changes that we see happening in the wider programming language,
competitors,
or software development industry. And one thing that was fairly apparent was that when looking at the experience of very new developers, building APIs, which is a very common thing for new developers to be building these days. Everyone builds APIs. Even if you're building a front-end app, you build an API for it to be called. That when you compared some of the more modern frameworks that really focused on we are for building APIs, and you compared to what that looked like in the first sort of 15 minutes, compared to what it looked like to use something like ASP.NET Core in the first 15 minutes, there were some differences. And then on top of that, there were some other forces like we wanted to make MVC faster, but we had kind of hit the limit about how much more we could take out of MVC without impacting what makes MVC MVC.
Right.
And so those kind of two things together led to Fowler and some others doing some investigations, right?
Yeah, so we started a project called Feather HTTP, and the goal was to talk to non.NET customers and give them a tutorial where they have to write a React front end and a C# backend. No ASP.NET Core, no names, just C#. And they all had a preconception of .NET being old and crusty and for the enterprise. And by the end of every interview, we did like Go, Python, these devs, and they felt like it was JavaScript. And that was the first okay, so most of the people don't even know about modern C# and how it looks, how it works, how it does feel like other frameworks. And that led into kind of a functional approach. I think in general, there are kind of two approaches to doing web APIs. If you look anywhere, like Node, Go, Java, there's two styles. There's a class-based approach where you have a top-level class like a controller, and it has methods that are routed to by attributes or some declarative means to declare a route. And then I have a function, and I have the function maps from a route to a function, right? And those were basically the two styles that were out there, right? And we kind of dipped our toes in the other style. Like I think Damien did it in like 2.1. You can call map get, map post, map put.
Felt like I had a big
no one knows
about that.
No one knows, right? It's not like we kind of didn't say it was a big thing, but it was a thing that was there for a long time. And minimal APIs was the first time we were trying to say, okay, let's embrace this functional approach and just kind of like support direct to, I think we call it route to code. That was the internal code name. Could we make it more direct to route to code? No classes, less indirection. I could just close over state and just write functions, right? Because it's more simpler, it's direct. You can see it all in one place. And how do we simplify startup, program, app settings? There's like, file new project is super useful, but it has 4 or 5 files. And then you add a controller in a different folder. So like, you have to go find that class. So how do we start new developers who have never used .NET? How do they find their function? How do they understand by looking at the code that / will return hello world? And minimal APIs came out of like, I think me and Damien sat down and we were like, we started from the Feather code base and we drew out the end goal. We wrote a to-do app with EF, and I think that was it.
In Markdown.
And SQLite, in Markdown, in a gist.
In a real file.
It's still there in a gist. And we said, okay, we need to change the framework, languages, and tools to get this endpoint. And every preview, we would check to see how close we were to that end goal. So we changed EF APIs, we changed the language, we changed ASP.NET Core, and every preview, we would go, how close are we now to this end state? And is the end state still good? Right. So that was how we kind of push ourselves like past our typical design principles to get to this like end goal.
It's always my fear with simplification like that is then as complexity gets added to the app, as the feature set as we go deeper into what we actually need to do, are you managing that complexity well too? Because the actual functional parts of the app are going to be complicated.
Well, there's that, and there's also the tooling aspect, and that a lot of that structure or that ceremony. There's a word that comes up a lot when we talk about minimal, is the lack of ceremony. A lot of that ceremony that exists is not only useful with regards to creating structure for your app, which helps understanding, helps organization, but it also can create structure for tooling to attach to and tooling to leverage in order to make your code more dry or make it easy to find things. So I know Michaela from the tooling side obviously focuses on those types of aspects more than we might 100% of the time, but we had to take that in consideration as well, which is like, okay, if we're going to remove a lot of this structure towards this goal, what does that mean for all of these great tooling features that exist today? How is tooling going to allow someone to navigate from here to there or to do this type of refactoring, whatever it might be? Or what type of new tooling innovations can we create when people are going to be working with this style of application rather than this style of application? Right. So there's always a bit of a cycle, I think, between runtime, framework, and language design and the tooling design. And obviously with the language team, Jared was just up, they work very closely with the tooling team. In fact, they have basically together, the C# tooling and language team are basically part of the same unit. So they have to think about it a lot. And on the framework level, we have a little bit more distance between us and the tooling, but we definitely think about that a lot.
Yeah, because I got to think, if you don't put tooling around a feature like that, people aren't going to use it. Like ultimately, do the squigglies show up in the right places? Does it become a refactoring option? Like, how do I learn about this new feature?
Right. So very controversial. We changed the template in .NET 6 to start with the new minimal ceremony, like that template. And that discussion internally was, and Damien made the change, so if you want to blame someone, blame him. But the discussion we had internally about how do we get people to see this feature, to even know that it exists, right? So a brand new customer comes to our platform, they do .NET New API or web, and they see the startup class and program and like the 4 files, and it's more complicated. How would they ever find this other way?
Right.
That we want to be the primary way that new developers find this tooling. And this comes to a problem where we have a lot of different customer cohorts. We have like enterprise developers who are like bread and butter, and then we're trying to get these new developers that wouldn't otherwise look at our stack.
Right.
And how do we like trade off what to put front and center with those 2 cohorts of customers? Right?
So you're never going to take a feature away.
Right. Exactly. Exactly.
Because people's code depends on it.
Yep.
But
yeah, I like to think in terms of off ramps, like when you have the fast way, and you have maybe a more complex side underneath that lets you have more flexibility and do more. Like, how do you let people get, like, once they hit the limits, once they realize that maybe for their use case the fast, simplified way doesn't quite do what they need to do, how can they find their way off? Like, you don't want them to just like go straight off the side of the overpass. You want them to have a nice ramp down, and tooling is a big part of that, right? Whether it's tooling that helps you discover those other features, or tooling that helps you transform your code, or there's all sorts of things.
Because I think there's two. The greenfield brownfield scenario is very different there. The new person coming in greenfield is going to use the new language features, especially if the tools put them front and center. But how much push do you have on brownfield to say, you know, you're using a C#2 kind of approach to this. We got C#11 here. Let me show you the refactorings of that.
Yeah, it's not really terminology we use, but I guess that is a natural mirror to off-ramps, which is on-ramps. How do you get people onto the more readable, smoother, simplified way if it is the better solution for them? How do you help them take advantage of these more modern approaches and more modern features? And refactorings are a huge part of that, and analyzers. There's only so much scope those have, though. Those aren't going to help you currently with your project files or, yeah.
And that, you know, Menren asked this question specifically at Roslyn. So much of this new magic is part of Roslyn. I remember talking to Mads back in the day saying, I'm feeling like we're about to have a Cambrian explosion with the open sourcing and the compiler as a service mindset and so forth. But how much does it affect how you do tooling today? Like, you now have those analyzers. You have the ability for C# to analyze itself a lot. Like, how much does that shape both the frameworks and the tools?
A lot, actually. It's interesting that there was a running meme inside the team that I'm on, which is every time we say we'll just fix that with an analyzer, I usually retort and say, great, that means we'll never fix it.
Yeah.
And that's mostly just because we have to build the muscle to write the analyzers.
Right.
And you know, analyzers are not a solution to all problems. There are so many, as I mentioned before, there are things that we can express using language constructs. There are things that we can express using the type system and runtime features, which obviously are tied to language constructs, but they are separate and distinct concepts. And then there are things that we can express and enforce using framework constructs, or app-level framework constructs, the things that we have there. And sometimes when we can't express something in a language construct, we might be able to enforce it with an analyzer. So rather than saying you must implement this interface, we may say, well, we'll detect when you're doing something that we can't protect against with a language construct by creating an analyzer instead.
Right.
But we need to build up that muscle so that the team that builds ASP.NET Core builds the analyzers for ASP.NET Core. And that's something we've been working on a lot at the moment.
And are those things just going to run automatically, or do we actually have to convince the users to use those analyzers?
Well, I mean, that really speaks to Michaela's point about on-ramps and
Yes.
off-ramps, about how do we get those people to use those things?
Well, and some people look at the new editor and the way that code gets decorated with all of these tools and say, that's noise, not information. I mean, I know the difference between a red squiggle and a blue squiggle, but it really gets into the various pop-ups, arrows, like when do you know you need to do a refactor, or there's an opportunity for a refactoring. And this, falls pretty clearly to Michaela. It's a tooling thing.
Yeah. Well, that's a very valid perspective. A lot of the things that analyzers suggest that you might do are a matter of personal choice or aesthetics and so on. So it is important that we have tools to suppress them or to change the severity of particular analyzers in your editor config file. So that is something that tooling does give you. But yeah, it can be very overwhelming if you open up a file and it's just all squiggles.
All we know for sure is all your code is wrong.
Yeah.
That's what we know.
Yeah, and there's also big differences between the different kinds of experience as well. Like if you're writing code and you see a squiggle in the code you're writing, like that's very different than you do a build and you have like 10,000 analyzer warnings because it's run over your entire code base. And the first, like, the squiggles maybe don't seem quite so intrusive because they're more maybe approachable. But when you have the bigger, like we do have code cleanup tools that help you fix whole swathes of analyzers, but that can be fairly difficult to review. So there's always trade-offs, and Yeah, everything's trade-offs.
Nothing comes for free. Otherwise, you would have done it automatically, right? I mean,
and even analyzers. Yeah, like there are limits on the analyzers we can build. Like there are some analyzers we would like to build, but we just can't because they're too expensive computationally, that we just can't run them in the background, or there's only so many we can afford to run.
Yeah, I could see analyzer propagation becoming a huge issue, especially when the cop-out solution is just make it an analyzer.
Yeah, and then an extension of analyzers that we talk about, Michaela mentioned refactorings, which are generally manually invoked by the user, so they're not so bad. But we also have source generators, which is a fairly new thing, but they run while you're coding. They have to run while you're coding because they actually generate code in your app. And so at some point, performance becomes a consideration. We can't, and Michaela just hit it on the head. It's like being an architect and designing any of these features is about trade-offs. It's literally the #1 principle. You are never going to be able to make everything perfect. You are always trading off some part of the developer experience, some performance, some aspect of how accurate what you're showing is and at what point in the development lifecycle you're seeing it, against all the other things. And so a lot of our job is arguing about what is the right trade-off to make this release.
Discussing
strongly.
Yes, with vigor.
With vigor. What the right trade-off is to make. And the equation changes from release to release. Sometimes we get 3 or 4 versions away from when we made a particular trade-off, and we decide that was wrong now, it's wrong for today, so we make the other one.
Wrong, or just we didn't have the information.
Things have changed.
Sure, yeah. And I immediately think in terms of execution performance when I deploy this app versus the development experience performance, because a lot of those analyzers and so forth, they're running at my dev space as well. Like how much is that impacting my dev cycling?
Right, and the variance in dev workstation performance is huge.
Yes.
Sorry, Michaela.
We get so much feedback on performance of the developer experience because people get frustrated when they're writing code and things freeze up and they have to pause for a couple seconds, and there's the running joke about going and making a cup of coffee while your code's compiling, and hopefully that's not so much of an issue anymore. But if you invoke a refactoring and it takes 20 seconds, that's a real stall, and those kinds of paper cuts build up.
Yeah. That's a great expression, a series of paper cuts.
I am worried that when we shift things from runtime to tooling time, it turns everyone into a compiler author. And I don't think everyone has let that sunk in yet. You're basically shifting time. So we think about using source gen to improve time at startup and runtime time for the actual app when it runs, but you're moving that time to build time. And I think that works well when you're doing 1 or 2 or 3 small things. When it's like 50, or every package decides to source generate everything because it's faster, then we're going to have performance issues at build time, which we have already, right? But so I think those are things to think about as we're trying to move to this new world of having people write code for libraries and ones that run at build time.
And historically, we've had this difference between debug builds and release builds, which don't maybe mean as much as they used to. But I think there are definitely opportunities for thinking of the different kinds of inner loops and outer loops and so on. Of when you're writing code, you want to optimize for build performance, and when you're building your code to deploy, you want to optimize for runtime performance, and that's always been the case with C++ compilers and the different optimization levels and so on. And maybe that's something we need to be thinking about again as well, now that we have source generators doing a whole lot of work that's really targeted at runtime performance, not developer time.
Yeah, I think it's very fair. We got just a few minutes left. There's been a sort of a gestalt set of questions in Twitter, so I'm going to paraphrase them around open source libraries, open source projects. And let me throw in add-ins and things for on the tooling space as well. Do you get into a conversation about should we just be using these open source libraries, or is this a language feature we should add, or there's an add-in that people seem to like, should this be incorporated into the tool? What does that conversation even look like for you?
Trade-offs again.
Yeah.
we've been through, and we continue to go through a bit of a journey on that. Folks who have been with us through .NET Core 1 to about 3 may, if you were using ASP.NET Core apps, you kind of saw the result of a lot of that journey as well. We made
JSON.NET.
JSON.NET was one, but also the introduction of shared frameworks in .NET Core 3 forced us to make some decisions about where those lines exist and how we draw them. And so today, if you create an ASP.NET Core app, some of our templates include open source libraries as NuGet packages, as references.
Right.
We don't have other parties' open source in our shared frameworks. Currently. We used to, and we got rid of that, to try and draw a line between the two. But like a lot of, as we said before, this is a trade-off between what different cohorts, I think Fowler said before, want in our community. And we continue to have that discussion.
Mm-hmm. Yeah, I think it's a constant balancing act. And also what the customer wants. Whether those features make sense or not. I mean, I think about the ecosystem in Studio, Michaela, and just all of the tooling that exists there already, versus what do you add? Like, do you have to have that conversation about, is this stepping on an existing ecosystem member?
Yes, that's a very important conversation to have. Like, I think historically there has been a tendency of customers to use the Microsoft blessed thing, and maybe some people don't want to use something unless there is such a thing. But we don't want to be suppressing the ecosystem, right? We want to have a super vibrant ecosystem, people building things and other people using those things and us using those things. So part of this is about expectations and historical baggage. Part of it's that we have these trade-offs of when we bring something into the default templates, it has certain expectations, and those are something that we can't necessarily put onto a third-party library. It's complicated. It's a lot of very difficult discussions.
Yeah, and not always easy choices, right? If it was simple, everybody would be doing it. And I appreciate all the work folks do around there. One last question here. This is from Joe Cuerva, who says, what is the state of green thread support in .NET? Oh, David's all excited.
Yeah.
So we built a working group. This is kind of built up over years of seeing people like doing blocking on thread pool threads and the slow thread pool growth, and we made changes to that in .NET 6 and 7 to make it better. But the fundamental issue will always remain. The moment you have async and non-async methods, and the day somebody ever wants to do an async thing and a sync thing, there's issues. So we have this experiment going on where the runtime team is trying to implement a new primitive in the runtime called a green thread. The idea is that you can call any blocking API and it will magically yield this runtime-based thread. So it's basically like threads, but in the runtime itself, not in the operating system. And it actually works. And I have a branch. It's actually all open source. For runtime, it's on the runtime lab repository. And then for ASP.NET Core, it's a branch. And it works. It's really slow right now. It's really slow. Don't try it. But it isn't crashing. So
that's
happy
cool.
about it.
That's awesome. Damian, Michaela, David, thank you so much for this conversation. It's so much fun. I hope folks really appreciate it. And hey, if you get a sec, fill in that survey. The links are available there. Let us know if this is the kind of conversation you want to have. And with that, I'm going to pass this over to Dan Roth, who's talking a little bit about .NET's love of WebAssembly in .NET 7.
Hey everyone, I'm Daniel Roth. I'm the product manager on the ASP.NET team for Blazor. And in this session, we're going to talk about all the improvements to WebAssembly support in .NET 7. .NET loves WebAssembly. Now, WebAssembly has enabled a new era of modern web development by providing a standard binary-based instruction language for the web. WebAssembly made it possible to use virtually any development platform in a browser to build web applications. Over 5 years ago, the .NET team began on a journey to see if we could run .NET and C# code in any browser on WebAssembly to enable web development full stack with .NET. Now, building a .NET runtime for WebAssembly is a difficult challenge. There are many technical challenges. The runtime needs to provide API compatibility with the .NET Platform APIs within the constrained browser environment. You also need to provide access to those browser-specific APIs and existing JavaScript libraries. At the same time, the download size of the app needs to stay small so that the app loads fast. You need to have good runtime execution performance, as well as tooling for debugging and profiling and logging and tracing and all these things. Fortunately, the .NET Runtime team, together with the .NET community, was up to the challenge, and .NET support for WebAssembly is now a supported part of the .NET platform, and has been for several years now. This enabled support for Blazor, our client-side web UI framework based on components that is part of ASP.NET Core. By supporting .NET execution on WebAssembly and web browsers, .NET is able to provide a complete full-stack web development experience. You can build your front end and your back end using the same languages, frameworks, and tools, which reduces costs and reduces complexity. Now in .NET 7, we've made a bunch of improvements for running .NET on WebAssembly. We now have enhanced WebAssembly debugging support, improvements to hot reload. We have expanded the web crypto support on WebAssembly. We're also using the latest WebAssembly features like WebAssembly fixed width SIMD and WebAssembly exception handling to improve performance. We have a new improved JavaScript interop model that's specific to WebAssembly and optimized for WebAssembly. And we even have a preview of multi-threading support for WebAssembly that you can try out. Let's take a look at each of these areas. Now, debugging .NET code on WebAssembly is a tricky challenge. We don't actually use the normal .NET debugger to do this. Instead, we connect to your app, to the browser, using the JavaScript debugging protocol, and then we tunnel .NET debugging capabilities through that channel. This has the benefit of enabling you to both debug .NET code and JavaScript code at the same time, but it does make it difficult to provide a full fidelity .NET debugging experience. In .NET 7, we've made a lot of improvements to the .NET WebAssembly debugging support to improve the fidelity of that experience. We now have support for the Just My Code setting. You can inspect multi-dimensional arrays using the debugger. The call stack window will now correctly show the name of your async methods. We correctly handle the new keyword on derived members. We added support for many of the debugging attributes that are in the system.diagnostics namespace, and we just made a bunch of general reliability improvements. Let's go take a look. Let's look at the debugging improvements for WebAssembly in .NET 7. OK, so here I have a default Blazor WebAssembly app that I've got running in Visual Studio. I've already started it up, and I've got it running in the debugger. I've got the counter up, and I've set a breakpoint in the counter component in the increment count method. When I click the button, we hit our breakpoint, and there we are debugging .NET code running on WebAssembly in a browser from Visual Studio. That's pretty cool. Now down below, we can see the state of everything that's in our component. And it's nice and clean. Now, if I go into the Visual Studio settings and I turn off the Just My Code setting, let's turn off Just My Code. Now we see like all of the internal implementation details of Blazor and ASP.NET Core, and that can be very useful. In .NET 6, this was the only view that you could get. You would get all these additional details. If you ever wanted to just focus, though, on just your code, there wasn't a way to do that, but now there is. You can turn on Just My Code, and the Blazor WebAssembly debugger will now honor that. So that's really nice. Let's go ahead and let this execution continue. Now what I'm going to do is I'm going to add a little bit of code to my counter component. I'm just going to add a random variable here, an array. And this will be an integer array, a multi-dimensional integer. I need a new. And then we'll just add some random data in here just to show what we can do with this. All right, so there's that. And I'm going to go ahead and hot reload that into my Blazor WebAssembly app. And that should work. All right, great. We've got the check mark that says that hot reloaded successfully. Let's go ahead and click the button again so we hit our breakpoint. Now below, notice that we can see our array2D variable, and we're able to now inspect multi-dimensional arrays with the Blazor WebAssembly debugger. That's new in .NET 7 as well. OK, let's continue execution there. The last thing I want to show is in the fetch data component. This is this component that pulls down some JSON data from the server and dynamically generates a table of weather forecast data. It has this onInitialized async component lifecycle method. It's an async method. If we set a breakpoint right here, and then we try to browse to the fetch data page, we hit our breakpoint. And then if we look at the call stack window, notice that we see the actual name of our async method. I think in .NET 6, this would print out like, move next for like every async method, which was pretty bad. Now you get a much higher fidelity .NET debugging experience for your WebAssembly apps. So that's just some of the improvements. .NET WebAssembly debugging just continues to get better, and we're working on continuing to improve it in future releases. All right, let's go back. And let's talk about hot reload. All right, so in .NET 6, we introduced support for hot reload, which is the ability to apply code changes to your running app during development and have those changes apply immediately without having to rebuild the app and restart it. We have hot reload support for WebAssembly-based .NET applications, including Blazor WebAssembly apps. Admittedly, though, the hot reload support for Blazor WebAssembly was initially a bit limited. I think the only thing you could really do was method body replacement. Everything else, you had to actually restart the application. In .NET 7, we've made lots of improvements to hot reload support for .NET on WebAssembly. You can now apply the following types of changes. You can add new types. You can add nested classes. You can add static and instance methods to existing types. You can add static fields and static methods to existing types. You can add static lambdas to your existing methods. And you can add lambdas that capture the this to existing methods that already are capturing the this previously. So all these changes mean that you can stay in your development flow and see changes faster in your running .NET WebAssembly apps. Now, before I move on, it's worth calling out that we know there's still lots of changes that we need to support here to keep that flow really fast and fluid. This is an area of active investment, and you should expect even more improvements to hot reload coming in the upcoming releases. All right, web crypto. On WebAssembly, we've expanded the set of crypto algorithms that are now available when running on WebAssembly. This is the list of new algorithms. Now, I want to make sure it's clear that this doesn't mean that you can now safely store secrets in the browser. Just like with JavaScript-based apps, .NET code running in a browser on WebAssembly can be completely inspected by the user. Any secrets can be extracted from that code. So don't put any sensitive encryption keys or data into your browsers, but you can still use these new algorithms for a variety of purposes, including hashing and so on. What about tooling? The .NET SDK comes with specialized tooling for working with .NET WebAssembly applications. This tooling is available as optional .NET SDK workloads that you can install either from the command line or using Visual Studio. Now, for example, the .NET WebAssembly build tools provide support for WebAssembly ahead of time compilation, which gives you much better runtime performance, runtime relinking, so you can reduce the size of the .NET runtime WebAssembly bundle, and also native dependencies, where you can link in new capabilities into that WebAssembly bundle. You can install these tools for .NET 7-based projects by running .NET workload install WASM tools, or you can select the optional component in Visual Studio. Now, if you still need to work with .NET 6-based projects using the .NET 7 SDK, you'll need to install the new WASM tools .NET 6 workload. The .NET WebAssembly tools, build tools in .NET 7 are not compatible with .NET 6. So if you're a library author and you're using these tools and you still want to support .NET 6 and .NET 7, you're going to need to multi-target it. Okay. There's also the new .NET WebAssembly experimental tooling workload. This is a new workload that contains experimental project templates for running .NET code from JavaScript, as well as preview support for multi-threading. These features now are still in active development, so they're not ready for production use yet, and they're likely to change, but we hope that you'll try them out and that you'll share feedback with us. You can install the WebAssembly experimental tools by running .NET workload install WASM experimental. Now, we introduced WebAssembly ahead of time compilation in .NET 6 to improve the runtime performance of .NET apps running on WebAssembly. In .NET 7, ahead of time compilation produces code that is much faster thanks to support for some new WebAssembly features. WebAssembly exception handling and WebAssembly fixed with SIMD, or single instruction multiple data instructions. You can enable these features using the WASM enable exception handling and WASM enable SIMD MS build properties. And if you're specifically interested in SIMD, it's worth noting that it's not supported in Safari just yet. The WebAssembly feature is standardized, but Safari hasn't quite got the implementation done yet. Hopefully, Safari will get that addressed soon. We also have a new improved JavaScript interop model for WebAssembly apps in .NET 7. This new model is strongly typed and highly optimized for efficient execution on WebAssembly. In Blazor apps, this new model replaces the existing IJS unmarshaled runtime interface, which is now obsolete. Now, for general purpose JavaScript interop, you're still going to want to use the IJS runtime interface, which will work across all Blazor hosting models. Like if you want to write some JavaScript interop code that works in Blazor Server, Blazor WebAssembly, and Blazor Hybrid, you should continue to use IJS runtime, because those aren't WebAssembly specific. But this new JavaScript interop model for WebAssembly, that is great when you only know you're only going to be running on WebAssembly and you care about getting optimized WebAssembly-based execution. Now, to use this mechanism with existing JavaScript-based apps, you can import the .NET.js JavaScript module into your JavaScript code, it's now a proper ES6 module in .NET 7. You can then use the JS import attribute on your .NET methods to import JavaScript functions so they can be called from .NET. You can then also use the new JS export attribute on .NET methods that you want to make available to be called from JavaScript. Now, this model provides a rich attribute-based programming model for controlling how marshalling is done across the .NET and JavaScript interop boundary, and it also supports sync and async methods. It supports promises and tasks, proxying objects, as well as marshalling callbacks. Now in Blazor, if you want to use this new JavaScript interop model, what you need to do is you use the JSHost.invokeAsync method to import JavaScript modules into your .NET code. From JavaScript, you can use the new get.NET runtime function to access the .NET runtime that was set up by Blazor so that you can make JavaScript interop calls back into .NET code. Well, let me show you what I mean. All right, let's go back to Visual Studio. OK, so in Visual Studio, in order to show this feature, I'm going to use the new experimental .NET JavaScript, .NET WebAssembly project templates. To show that I've got those installed, we can just run .NET workload list, and there it is. You see I have the WASM experimental workload already installed, and that will give me these new templates. These templates are experimental, but the features that they use are not. They are supported as part of .NET 7. All right, so let's do File, New Project. Here are those two new templates. The first one is a WebAssembly browser app. This is a project that will set up running .NET from JavaScript within a browser on WebAssembly. There's also this WebAssembly console app. This is a project that will run .NET from JavaScript in a console app using Node.js. All right, we're going to use the browser-based one for this demo. And let's call this WASM browser app. Looks good. And we'll use .NET 7. I don't think we need to save that. OK, now this project is not using Blazor. This is just using the raw .NET runtime capability of running .NET on WebAssembly. In a sense, we're kind of peeking under the hood of what Blazor does in order to be able to run .NET code in a browser. Let's see how we do that. So if we start in index.html, we can see that all that's doing is importing this main.js module, which is defined in the application. In main.js, we're importing .NET.js. That's the runtime API for starting up .NET from JavaScript on WebAssembly. And then from .NET, we're grabbing a couple functions: the set module imports, get assembly exports, and get config. What do we use those for? Well, set module imports allows you to create named modules, sets of JavaScript functions that you want to make available to be called from .NET and C#. OK, so in this case, we just have one. And we want to be able to get the current browser address location by calling window.location.href. Now, in .NET code, the way you do this is you have a class, a partial class, and then you can attribute a static method with JS import. You reference the name of the module that you set up previously. In this case, it's the name of the file. It doesn't have to be that. It can be any string. And then the specific function that you want to bind to. So we're binding this get href C# method to this JavaScript method in JavaScript land. OK, let's go back to main.js. So we've set that up. Well, we can call getConfig to get details about the .NET application, like the main assembly name. And then we can use getAssembly exports to get all of the .NET methods that have been exported so they can be called from JavaScript, so the other way around. Here we're using those exports to call myClass.greeting. If we go back to program.cs, we can see that myClass.greeting has the JS export attribute on it, and it's just returning a string. It's actually calling getHref, so it's calling back into JavaScript to get the browser location, concatenating that into a string, and then returning that string back to JavaScript. And it's calling console write line in the process. All right, so that's what this does. And so we get that string back in JavaScript, and then this is just logging it to the console. And it's also putting it into the HTML DOM. There's no UI framework here. This isn't Blazor. There's no component model. So if you want to interact with the DOM in this world, then you're just using JavaScript interop to deal with the DOM. This is all the stuff that Blazor handles for you. And then we call .NET Run to call program main. In this case, we're using top-level statements. So the only piece of code in our program main function is this console.write line. So let's run this. And when this comes up in the browser, it's it's pretty plain. It's not a UI framework here. We're mostly just demonstrating how we can call .NET functionality from a browser. So there. So here's our our string that we got from that greetings method, and it's got the correct browser location. If we go into the browser dev tools and look at the console, we can see all those console logs being written. So and then there's hello browser also from program main. OK, so that's cool. This is something you can use now to run .NET code from any JavaScript-based code using WebAssembly. Now, how do we use this from a Blazor application? So I'm going to switch out of this project, and I'll show you an example of using this new JavaScript interop model from Blazor. So in this application, what we have, this is going to do hand pose tracking using a JavaScript library. So it uses JavaScript interop in order to do that. The library is MediaPipe, and it does hand pose tracking. So it's going to set up my, hopefully my webcam. But there I am. OK, so if I put up my hands, you can see it knows where my hands are. And then down below, using Blazor, we're displaying some information about which hands are visible and where they're at on the screen. Pretty neat. All right, so how are we doing that from Blazor? Well, if we look at index.razor, we just have this one component, detect hands. We can go to definition on that to see where that's defined. That's in this other Razor class library that we're referencing. And we're setting up the video feed and a canvas to overlay the hand locations. And then we've got some rendering logic that's going to display where the hands are at. And that's all based off of this detection result property, which is defined on the component. OK, so how is that getting populated? Well, that's all being done using JavaScript interop. Let's go to the code behind for this component. So in the C# file. So we have uninitialized async for the component. We're checking that we're actually running in a browser, because remember, this JavaScript interop model only works when you're running on WebAssembly. This is not like the other Blazor model where it works with all the hosting models. So this wouldn't work from Blazor server. Here we can call jshost.import async to import a JavaScript module. This is the one that's associated with my component, just sitting beside it in the file system. And we give the set of exported JavaScript functions from that JavaScript module a name that we can then reference later. OK? And then we call onInit on this interop class, and that's where we're setting up all of the methods for that to handle JavaScript interop. OnInit, here we have the JS import that's referencing the module name that we imported using JS host. And this is the JavaScript function that we want to call. We want to call this onInit function. And here we can see some of that attribute-based programming model for controlling how types are marshaled across the boundary. It's using a new C#11 feature. I don't know if you noticed, generic attributes. That's pretty cool. All right, so let's go look at the JavaScript code. So where is onInit? Here it is. So onInit gets like a reference to the component instance. And then it's calling get.NET runtime to get the actual .NET runtime instance that Blazor had set up 0 means, the first one. There's only one. It's the only runtime that you ever need. Then it calls getAssembly exports to get all the exported .NET methods so that they can be called from JavaScript. And we just have one of those. I think it's this onResults method that we're using with JS export. Okay, and then somewhere in init, we're setting up this onResults callback. And then below in onResults, whenever we get results from MediaPipe with the hand post data, way at the bottom, it actually uses that detect hands export to call back the onResults method in C# land. So that's how we're getting the results back from JavaScript. So that's how this is working. It's pretty cool. Thank you, Pavel, by the way, for setting up that demo for me. What I think is really great about this is showing how you can take .NET code and use it from any JavaScript-based application. It could be Angular app or a React app. It doesn't have to include Blazor in the component model. You can reuse your .NET code anywhere that you can run JavaScript. All right, let's go ahead and shut that down. And let's go back here. Now, the last thing I want to show is multi-threading support. Now, browsers are normally single-threaded. You only have one thread. That means if you do anything that blocks the one UI thread, then your app effectively hangs. There's no other thread to continue execution. But you can emulate threads in a browser on WebAssembly using web workers, and then share memory using shared array buffers. So we have a preview of doing this for .NET 7 that you can try out. To use it, you're going to need to install that WASM experimental workload and set WASM enable threads in your MS-Build project file. Now, this isn't supported at all in Blazor yet. That's something we're working on for the next version of .NET. So in order to try out this feature, you're going to have to use these experimental .NET WebAssembly project templates. Let's take a look real quick. OK, so if we go back to Visual Studio, let's open up this math project. Let me make sure I'm on the right branch. I am. OK, so this project, let me go ahead and run it. What we do is this app will solve systems of linear equations. And it's using a .NET library from the community to do that called MathNet. It's a great name. It reminds me of Square One TV from back in the day. And so it tries to solve these large matrix of variables, which takes a lot of compute. At the same time, it's also running a little animation in the corner of just displaying the letters of the alphabet. So in this version, where I'm not using threading, like if I look at the code and what this is doing, it's just calling solve. So it's just running a bunch of compute on the main thread. That will block the main thread. So if I click solve, watch the letters. So we're on N, and it just stopped moving. We wait, the computation completes, and then the letters resume. That's because we blocked the main thread with that solve. So that's a bad experience. We can make this better. Let me switch to a threaded version of this application. And I'm just going to rebuild to make sure that let me stop this. Stop the old app, and let's rebuild the solution. OK, and so in this version, we're now, instead of just calling solve, we're actually creating a thread. And we're doing the calculation off of the main thread, and that should allow the animation to continue. So let's see if that's now working. Hopefully I didn't mess up any caching by switching branches like that. OK, so we got the animations going. Let's click. Now watch the letters as I click solve. I'm still using the old one. Let me do. That's still the single-threaded version. Let's do this. Empty cache, refresh. I might have. OK, let's. OK, so now if I do solve, yeah, see the letters keep going while we're calculating, and we solved our system of linear equations. So that's using threading. So we were able to unblock the main thread. So that's a preview of multi-threading. Not ready for production use yet, but you can certainly give it a try. Now, all of these great new .NET WebAssembly capabilities enable a whole bunch of new powerful experiences on the web using .NET and C#. For example, our friends on in the Uno platform, they have an application framework for building multi-platform apps that run on a variety of platforms, including the web, using a WinUI-based programming model. They use the same .NET runtime that we use for Blazor. By moving to .NET 7, they were able to dramatically improve their performance. 20 to 50% better performance on their critical paths. They're seeing that exception handling is much faster thanks to that new WebAssembly exception handling support. They're using AOT and getting dramatic benefits from AOT. They're even trying out multi-threading to get smooth UI animations and transitions. You should definitely check out Jerome's talk later today, where he's going to walk you through how they're using .NET 7 to make the Uno platform great. You can learn more about Uno at platform.uno. All right, and with that, .NET 7, lots of great improvements for WebAssembly. I hope you enjoyed learning about them. Be sure to give them a try. Share with us your experiences. Right after this session, Steve Sanderson is going to show using these features to build a real-world Blazor WebAssembly app, so stay tuned for that. And with that, I think we'll now see if there are any questions.
Nice demo save, Dan. You're the best. Let's grab a couple of good questions there. This is from Black Love, who said, how does WASM debugging work with different browsers? Are all browsers made equal in the WASM world?
Well, from a WebAssembly standard perspective, yes, like all modern browsers support WebAssembly. From a JavaScript debugging perspective, they are different. Now, Chrome and Edge, those are all based off of the the Chromium engine, so they have the same JavaScript debugging protocol. So we support debugging Blazor WebAssembly apps with those Chromium-based browsers. We do have work in progress to also support Firefox. I believe it's not quite done yet, but it's getting pretty close. So we're trying to support as many of the JavaScript debugging protocols as we can. But yeah, they're not all the same. Currently, you do need to use a Chromium-based browser to get that debugging to work.
Makes me wonder if we're not going to get to a place where there's going to be a debugging standard, just like many of the other standards for browsers as well.
That would be nice. That would make things more convenient, certainly.
I bet. But it's certainly easier for you, but it'd be better for all of us, too. We could actually have an agreement on how all of those different things work. I'm going to grab another question here. This one's from Farul, who says, what's the state of WASI for .NET?
Ah, good questions. OK, so WASI is a system interface for when you're running on WebAssembly. This is more for when you're running WebAssembly on a server. Like here we were talking about running WebAssembly mostly in a browser, but there are a bunch of folks that are interested in could you use WebAssembly for server workloads? There's a bunch of reasons why that could be beneficial. WebAssembly has a natural isolation model, so if you're trying to run hostile code in a server environment, you could get really great density with a WebAssembly-based server execution. WASI standardizes an interface with that WebAssembly code to the underlying host. Like if you want to access the file system or network or other system resources, it provides you a way to do that. We are definitely monitoring the WASI WebAssembly efforts. We have prototypes and explorations where we have WASI support for .NET. No concrete plans to announce yet, but we're definitely looking at it and investigating it, and we're interested to hear about your scenarios.
Excellent. One more question. See if we can fit this in. It's from Dimitri, who says, for a question for Dan, can I make my Visual Studio stop, or I guess break, on an exception thrown by WebAssembly code without actually having to put in the breakpoint?
Yeah. So when you're running in a browser, the normal pattern, like if you're in JavaScript, is actually the exceptions don't, like I know in a native desktop app, for example, you expect that the exception will like tear down the process. Like you'll throw an exception, it doesn't get caught, and the process goes down. When you're running in a browser, that's not usually what's done. And so in Blazor WebAssembly, we follow that pattern. We kind of catch the exception at the outermost layer. That's why when you're debugging and you throw an uncaught exception, it doesn't actually like break in the debugger because it doesn't see it yet. So that's just kind of a characteristic of running on the web. You can, of course, enable like first chance exceptions, and that should work.
It's a resume next by default world in the web, actually.
That's right.
So I get that's part of the challenge. Although it's interesting to think in terms of at some point in that execution, you might have more than one error that you could now drop back into Studio and say, okay, well, what have we got? What complained? And see where the different execution threads occurred that generated those errors.
Yeah, maybe there's an opportunity to make the tooling better there. That's an interesting thought. We should look into it more.
Yeah, and it gets back to my original whole stretch on the idea that debugging could be a set of standards, because now we could have a collection of objects for the different errors. Like that to me would be fascinating. We could make better quality web pages.
Yeah.
You're all in? We're going to write all those good things for it?
Are we going to do that?
I'm excited you're committed to doing it,
We hope that those browsers get on that right away and start standardizing those things. We do benefit from a lot of great work from the standards community that let us build standards-based web apps. Everything we're doing with .NET and WebAssembly and Blazor, it's all based on the open web. There's nothing specific to .NET here. We're just using pure open web standards. As those standards progress, we're able to make .NET on the web even better.
Awesome. Dan, thanks so much for that. And let me push over to Steve Sanderson, who's going to dig into some nitty-gritty around Blazor and WebAssembly.
All right. Well, thank you very much, Richard. And hello, everyone, and welcome to this session where we are going to be doing some application building with Blazor. Now, I'm Steve Sanderson. I work at Microsoft. I'm on the .NET team. And the idea with this session is to get a little bit more advanced. So we're going to be digging quite deep into a lot of code in this session. And it's mainly intended for people who have some existing background with Blazor. Now, if you've never used Blazor before, there's going to be a lot of code and APIs that you might not recognize. So I'm not promising this is the best starting point for you. Hopefully you can follow along. But those people who have used Blazor before should have a good time. Now, we are going to use a mixture of .NET 7 new APIs and some of the existing APIs that you already know and love to build an audio browser application. Now, the idea with picking this audio browser scenario, it's really just to get you thinking about a different type of application, because I know we've all seen applications that read and write databases. Let's think about something a little bit different. And it doesn't really have to be audio. It could be any type of file. We're just using audio as an example. So consider this. Your user has got some files on their hard drive. Could be audio files, could be some other binary files. Maybe it's log files or some binary data generated by industrial machinery or something, who knows. And you are a developer of a web application and you want some way of working with these files. So you need to get that file data into your web UI so that you can read the data and maybe save changes to it. And you don't want to force the user to go through a process of uploading those files somewhere. That's quite inconvenient. You just want them to work with the file data right there on their hard drive. So that's what we're going to do with our Blazor application in this talk. So let's see how we're going to attack this challenge. I'm going to do this in 4 phases as we build up different parts of the application. And I will have to move quite quickly, so I won't show you every line of code, but I have put the code on GitHub and I'll give you a link to the full thing afterwards. So let's get started with trying to access files on the user's hard drive. So I've got a starting point here. Here's an audio browser application, which is Blazor WebAssembly. And I've got this also a Razor class library called Media Files API, where we're going to put some of the underlying API stuff in case we want to reuse it with other projects. Now, if I run that with a Control F5, you can see it's not really doing very much so far, it just prints hello world. And that is because I have created this using the new empty project template from .NET 7. So we only have one page in this application called index, and it's just going to say hello world. But I've also created this dependency injection service called media files, where we're going to add access to the user's file system. And that's coming from this Razor class library over here. And you can see it doesn't have much logic in it yet, but it does know how to load this JavaScript module. So why would we be doing that? Well, the APIs that we're going to use to access the user's file system come from the browser. It's a fairly recent spec. It's only a couple of years old, called File System. And this gives us some APIs in JavaScript that can access files. So we're going to do that here. And my real purpose is to show you some hints and tips for making your JavaScript interop code really nicely organized. So you can see we know how to load this media files.js file here. And that is coming from here. And that doesn't have very much in it yet. We're going to need to fill that out. And if you were looking closely, you might have been wondering, what is this JS module thing? Is that a framework feature? Well, it's actually not, although personally I think it probably should be, and I might start to argue that we should put this in .NET 8. But at the moment, it's just a general pattern. Don't worry about reading all this code. Obviously, there's too much. This is just a generalized system for being able to load a certain JavaScript module, for knowing how to release it when you're finished, and most importantly, for being able to make invocations into it. So it knows how to wait for the module to be loaded, and then when it is loaded, it can pass on an invocation. So don't worry about understanding that in detail, because it's a bit advanced. We are simply going to use it. So let's start by adding the ability to request access to the user's file system. And we'll do that using the show directory picker API. And we're going to return the name of the directory they've picked and an actual JavaScript object that represents it, so we can get the list of files later. Now, we don't want to work with JavaScript directly. We want to wrap that in a nice, strongly typed C# API. So here we go. I've got a method called show directory picker, which will return a JS directory. Now that doesn't exist yet, so we better define it. And you can see it needs to have a name and an instance on it. And we can do that really easily with a C# record type. And it's going to have name and instance. And I've also marked it as disposable because JS object references themselves are disposable. So we'll want to release that when we're finished. All right, so now we've done that and we've followed this simple pattern, we can use this inside our UI. So back in my UI, I am going to add a button. And when you click that button, we are going to try and open a directory. And we're going to have to fill in an implementation for that. And the implementation is going to ask the user to pick a directory using our DI service. And then we'll get the name and we'll display it on the screen. So let's see if this all works. When this reloads, we should hopefully see the button that we've just added there. That's a bit big. And when I click it, it should bring up the directory picker and I can pick a directory. I'm going to pick this particular folder that's got some audio files in it. And when I do that, the browser says, hey, user, do you want to let this web application access this directory on your hard drive? And we'll say yes. And then we'll get the name of the directory back in our .NET code. So that's a good start. But we don't actually just want to display the name of the directory. We want to show the actual files that are in it. So to do that, I'm going to follow the same pattern that I followed before by adding a bit of JavaScript code to wrap a certain JavaScript API. In this case, I'm adding a function called getFiles, and that's going to loop through all the entries in this directory. And for each one, it will return something with a name, a size, and a last modified date. And then I'll continue following my pattern to add a C# wrapper around it. So it's really easy to use. Right, so this is my getFiles async method, which is going to take a directory and return an array of JS files. And then we'll define JS file. And if you remember, it needs to have a name, a size, and a last modified date. So we'll just add a C# record that looks like that. Okay, then we can use that in our UI again. So I'm going to slightly amend this code now so that as well as doing what it did before, it now also tries to get the files from the directory. And then instead of displaying the name, I'm going to use a razor for each loop to print out the name and size of each entry in there. So let's just check that that's all going to work for us. I'm going to open my directory again. And this time when I do so, you'll see that it displays the names of the files and their sizes. All right, so that is pretty good. Now, what else can we do? Well, I want to improve a few aspects of this, and I don't have time to show you every step of the way. So I'm going to cheat a bit here by jumping forwards to a predefined state in my code here where I've added a little bit more functionality. I'll show you what it is. So let me just restart this and I'll show you what I've changed. Okay, so I've added an icon into this button. I've also added the ability when we pick a directory to show you the name of the directory and the number of files in it. And perhaps most importantly, I've added a feature where it remembers which directory you opened. So if I hit the reload button, you'll see it immediately goes back to that same directory. And I don't have to keep clicking that file browser, which would get pretty annoying. The way that works is that I've got this oninitialized async lifecycle method. And when this component is initialized, we'll call back into the browser to say, hey, if you opened a directory before, can you open the same one again? And we'll get the files out of it. Okay, so that is pretty straightforward. But I still want to improve the appearance of it in at least one more way, which is to do with the way that it looks while it's loading. This is a WebAssembly application, so hopefully it will load quickly, but depending on your user's network connection, they might have to wait a second or 10 seconds, it depends on the network. And while it's loading, what does it do? Well, it displays loading in black and white like that. It doesn't look very attractive. I don't even think it looks very professional, to be honest. So I want to show some tips for how we can make this look a little bit better. And my first tip is try and make your loading screen look like the same structure and style as the page when it has loaded. So in this case, we've got this kind of gray bar across the top, and I want that gray bar to show up while it's loading. So what renders that gray bar? Well, it's having a menu with a span inside it. That's what my CSS rule is looking for to render that gray bar. So I'm going to go to where my loading indicator is here in index.html, and I'm going to put in a menu with a span inside it, just the same. And then I'm going to put my loading messages in there. And let's close that correctly and get back to having the menu. And finally, we've now got back to some valid markup. All right. And once I've done that, eventually, there we go. I can come back to my browser and hit the reload button, and now you'll see the gray bar stays there while it's loading. I hope that state is showing up on the broadcast, but I think that looks quite a lot slicker. But we can do a bit better still, because if this application does take a few seconds to load, it'd be really nice to show an actual progress bar. And that's a feature that we've got baked in with Blazor WebAssembly and .NET 7, and it's super easy to use. I can do it without writing any code, actually. I just add some HTML. So as an example of how we can add a progress bar, we could do it like this. And this is literally the whole thing. I'm using Tailwind to set up a box that's got a certain height and a certain width. And then I've got another box inside it, which is a different color gray. And I'm saying the size of the box inside it is scaled according to the Blazor load percentage. And that's all we have to do. So now when I reload, so going a bit too quick, I'm going to have to slow down the loading so that you can see it. So I'm setting my network to be extra slow and clearing my cache. And now you can see that we've got a real loading progress bar that goes along as the site is loading. It's a nice subtle loading bar, which I think is better than having a big one in the middle of the screen, especially when it just sort of whips past really quickly in most cases. All right, good. So we've got access to local files. Let's move on a little bit by improving the functionality of the UI. We'll set up an actual grid with some sorting and searching because maybe the user needs to work with a larger amount of data than this. And this brings us to one of the .NET 7 preview features, which is a grid baked into the framework called Quick Grid. This is a preview level for .NET 7. So we'd love your feedback about that. And it's pretty easy to use. All we have to do is go to somewhere where we were doing a for each loop before. We'll get rid of that. And I'm going to drop in Quick Grid instead. So Quick Grid is complaining at me initially. The reason it's complaining and why we've got this red squiggle here is because it wants a queryable of T to display so that it can dynamically change pages and sort order and things. And I haven't given it that. I've just given it an array. And it won't be happy with that. So I'm going to change it to a queryable of JS file like that, just to show we're not limited to doing querying over database content. We can also do it on in-memory data as well. So I can turn an arbitrary array into a queryable using this asQueryable extension method like that. Okay, and now our grid is going to be happy that it can work with that data. So when I save that, it should compile properly this time. And if I switch back, my UI becomes blank because, well, my grid doesn't have any columns yet. Let's put some columns in there, shall we? We'll start quite simply with these 3 columns for name, size, and last modified, and I'll mark them as sortable. And hopefully that's all we have to do to get an initial UI that starts to look quite nice. And we've got multiple columns, we've got sorting, that's all good. But some aspects of the way it appears don't look so great. I really don't like the way this size has been formatted. I don't really even know how the user is supposed to understand this number. I want to show a value in megabytes or kilobytes or something like that. And I can do that very easily just by pulling in a third-party NuGet package that deals with that kind of format for me. So I've changed this property column now to use this third-party library called PrettySize, and that is going to render the size in a more recognizable format. So now you can see it displays a number of megabytes or kilobytes, and that is a lot better. Okay, cool. Right, so remember I also said I wanted to have a search feature. And that's quite important because maybe the user doesn't just have 4 files, maybe they've got a lot more. So in this directory over here, I've got 1,200 files, it's quite a lot. You can't really expect the user to manually search through this list. You'd want to have a search feature. This, by the way, is a load of samples of humans speaking, which comes from the Mozilla Common Voice dataset, which is a really nice one. So thanks to Mozilla for that. And to add searching, I'm not going to go through this step by step. I did do that in a talk yesterday, so you can go and see it if you want to. But I'm just going to show you the finished code for doing searching. It's not too difficult, but we've got limited time and I want to show you more stuff. So here's what we've got now. You see we've got this little search icon. And when I click on that, a box shows up and I can start typing stuff. And on every keystroke, it's updating to produce the search results. And of course, I can still do things like sorting within that. Okay, so how does that work? Well, what happens is I've got a field to keep track of what the user is searching for here, called search name. I've got a text box, which is bound to that field. And I'm using a new .NET 7 binding feature called bind after to say each time this binding updates, we want to update the filter. And what I'm doing is I'm simply adding a where clause onto my queryable there. So that's all it takes to do that. Pretty straightforward. All right, good. Let's move on. Let's think about rendering some previews of the audio data. I want to render actual graphical waveforms, but it's going to take us a few steps to get to that. Let's start moving in that direction. Firstly, where is this preview going to appear? Well, I'm going to add a new template column into my grid here with a title of preview. And I could start putting all my UI logic in here, but it could get a bit complicated. So let's factor out a separate component, and I'm going to call it audio preview, like that. All right, now I haven't defined that just yet. So the code editor will offer me the option to create a component from this unknown tag. So I'll click on that, and you'll see that's added a file for me now, which is initially blank, and I'm going to drop in a bit of initial content. So my initial content here says the audio preview will have a parameter called file, which will be an actual JS file object. And this is going to be required. And we'll add some real logic here in a minute. But for now, it just displays to do and the name of the file to check that we've wired it up. And if I go back here, you'll see that the editor is complaining at me saying you're supposed to pass a file and you haven't done that. So I'll do it. And what we'll pass is whatever file is the current grid row, and that's called context in this case. So with all that in place, if I come back here now, you'll see it's now rendering this preview component, which says to do, and then the name of the file that we should render a preview for. Okay, so how do we render a waveform? Well, the first step is going to be getting the actual audio data out of the file. And that could be a bit tricky because we could have multiple different types of files. For example, back in this other folder over here, you can see I've got some MP3s and I've got some WAV files, and there could be other types of files as well. So how are we going to decode all these different types of files? Well, you could start using multiple different libraries to handle different file types. And I actually did start doing that when I first was preparing this, and it was working okay. But then I had a bit of a brainwave, which is we're running inside a browser here, and the browser already knows how to parse a wide range of audio files. So can't we just get the browser to do this for us? And the answer is yeah, it's actually quite straightforward. What we can do is we can use some APIs that are built into the browser like this. So I've added this in the background sneakily. You didn't see me, but I did. And what this does is it goes through a slightly awkward process to get access to the raw bytes from the file. And once it's done that, it can decode the audio data from it. And we'll pass that efficiently back to .NET through binary interop. And then we can access that through our DI service in .NET. So let's do it, shall we? I'm going to drop in a bit of logic that says when this preview component is created, we'll decode the audio file. And just to get started with, we'll figure out how many bytes we get back when we've decoded it. And I'm just going to render that to the UI right now. So let's render this message. All right, let's check if this works and we're able to successfully decode files. And the answer is yes, we can. So in the case of something like a WAV file, you'll notice that the decoded size is pretty much the same size as the file on disk because it's not compressed. Whereas for an MP3, the decoded size is far bigger than the file on disk. So that makes sense because MP3s are very compressed. Okay, now we don't just want to get the decoded bytes from the file. We actually want to render a waveform from it. How will we do that? Well, we could start rendering it using something like Canvas APIs, or we could use Sharp or some other bitmap renderer like that. But there is potentially an even easier way to do it, which is using SVGs in the browser. Blazor has for a while had the ability to generate SVGs dynamically, and it's a really powerful and quite easy technique. To be honest, I think it's a bit underutilized, so I'm trying to market this idea a little bit because it's a very powerful and useful thing to do. So how could we generate an SVG of a waveform? Well, let's build up towards it. I'm going to give you an example of an SVG. Don't worry about understanding this weird goop right now. Let's just see what that renders. Okay, you'll see it renders 3 vertical lines. Well, why does it do that? Well, it's what this path says. So this first instruction here says, move to 10 across 0 down, and then draw a vertical line down from there. And then move again, draw another vertical line, move again, do another vertical line. So that's 3 vertical lines. So we can use that to render a waveform. We just have to generate a big string like this that encodes all the lines in the waveform. And I've written a little bit of C# to do that. It's a bit too much code to go through step by step, so don't worry about understanding it in great detail. I'm just going to show you, I'll just quickly sort of mention a few of the details about how it works. So we're receiving the raw byte data. We're reinterpreting it as a set of floats because that's what it actually is. Then I'm setting up a couple of string builders, one for the top half of the graph and one for the bottom half, because I want them to be in different colors. And then we're looping across the image horizontally. And for each column in the image, we're finding the highest and lowest audio sample in that part of the file, and then appending some SVG path instructions. Okay, so that's the whole thing. Don't worry about it if it wasn't completely clear, but we're going to use that now. So I'll add a waveform SVG field right here, and I'm going to populate it by saying the SVG equals generate waveform SVG from the data that we've decoded. And then finally, I can render that into my UI, just like this, with the top path and the bottom path in a slightly different color. So let's try that out, shall we? I'm going to restart my application, and now you'll see it actually does display real waveforms. So that's pretty good. Let's just check it works if I move to a different set of files as well to make sure everything's really happy. And it seems like it is working. Okay, great. So we are doing well. Right, the last thing to think about is performance. So we're probably feeling pretty good about ourselves as developers right now because we've got everything working, but does it really perform well? And I'm sorry to break it to you, but bad news, there are some scenarios where this is going to behave quite badly indeed, because we have been a little bit naive in some of our implementation decisions. So let me show you one of the ways that this is going to go wrong. Let's start with if you've got a big directory with lots of files in it. I'm going to reload this directory, and then I'm going to try and scroll down to the bottom really quickly. And my UI is really laggy. I don't know if you can see, but that gray box is following ages behind my mouse, and it's kind of all locked up and where are the waveforms? This does not seem to be working well at all. So what's going on? Well, eventually it shows up. But what's going on here is that we have very stupidly decided that we're going to when a directory is open, we'll load every single file in it into memory, and we'll decode every single file, and we'll render a waveform for every single file, no matter how many of them there are or how big they are. And that doesn't really make sense. We would ideally only load and generate previews for the things that are actually on the screen. And the good news is it's very easy to do that. We can go back to the grid, and we can tell it to enable virtualization. And that means that it will only render the stuff that's on the current screen. So we'll only instantiate audio previews for stuff that's on the screen. So we'll only load and render stuff that's on the screen. You get the idea, okay? So let's try this now and see if it's a little bit better with the large directory. So now when I scroll to another point, you'll see it immediately just generates the previews for whatever matches my current scroll position. So that is clearly far better. Okay, so again, we might think that we've finished now and we've solved all the problems, but there could still be another issue. And to illustrate that, I'm going to jump forwards in the implementation one last time to a place now where I've got the ability to track some timings of what's going on. So let me show you what I've just changed there. Let's get this going. All right, so firstly, I've added a play button. I don't know if you can hear it. You might not hear it, but it was playing out of my speakers just then. That's good. But I've also added this little timing information here where it says 4 milliseconds. And I've set it up so that every time I click this waveform, it will re-render it and measure how much time it took to do so. And you can see it takes, like 3, 4, 5 milliseconds or something to render. And you might think, okay, that's fine. That's fast enough, isn't it? But what if these files were much bigger and we had a lot more audio samples to walk through? So over here, I've got another directory now with some full-length songs. So these are multi-megabyte files. They've got many millions of audio samples in each file. Here's a whole song. Don't know if you can hear that, but there you go. And how long does it take to render these waveforms? Well, if I click this a few times, you can see it's taking in the realms of about 40-ish milliseconds. And again, you might think that's okay, but what if the files were bigger still? Or what if the user was working on a low-end mobile device, which had a much slower CPU? Maybe it would actually be quite laggy. So to make things faster still, the big technique that we've got for Blazor WebAssembly is ahead of time compilation. That's not new in 7. That was already part of the 6.0 release. But one of the great things in .NET 7 is that the runtime team added a lot more optimization for the way that the AOT code generation process works. So it can produce significantly faster code. I don't have exact numbers, but I've seen micro benchmarks that have been around 50% faster or even faster still than that. So I'm not promising anything specific for your app, but let's see what happens when we AOT compile this one. So I've actually already AOT compiled this and published it. And I'm going to start this up from a static file server here. This is the same application code that you just saw us work on there. And I'm going to open the same big files directory here. And we should see that runs rather a lot faster. So the same big file that was taking 40 milliseconds before is now taking in the realms of 2, 3, 4 milliseconds. So that is something between 15 or 20, well, 10 to 20 times faster than we had it running before. So that is a big improvement indeed. Okay, so we've done a lot of app building. We've made the performance good. We feel pretty happy. I just want to throw in one last bonus for you. Bearing in mind that this application is implemented in WebAssembly, running in the browser, and it's just working with files that are local on the user's hard drive, that means it's absolutely trivial to turn this into an offline capable PWA. Again, it's not a new feature, something that's been in Blazor since the beginning, but it works really nicely in this case. So let's just see that happening. So I've got this AOT compiled application. I'm going to click on the install button here. That's going to now pop up in its own separate window. I'll let Windows pin it to the taskbar. And that means that this user now has on their application taskbar the icon for this application. They can click that and it pops up in its own window separately from the browser, and they can now do all the same things that you saw us do before. And so effectively, they've got something that looks, something that feels like a native desktop application. It works offline and it performs really well thanks to the AOT compilation for working with their local files. All right, so there we go. That's all we're going to have time for in this session today. If you want to get more information about this, you can get the code for the finished application from the GitHub repo that I've given you a link to at the bottom there. And if you want to learn more general stuff about Blazor in .NET 7 or all of ASP.NET Core in .NET 7, you can use the link at the top there, and that takes you to a blog post that's got tons of extra content. So there we go. I hope that's been useful. If you've got any questions, you can ask them right now, or you can contact me through Twitter, or you can contact the whole Blazor engineering team through our GitHub repo. But that's the end of me for now, and I'm going to hand back to Richard in the studio. Thank you.
Thanks, Steve. Awesome demo, as always. You always knock them dead, showing all the cool things. Hey, you're getting a great view of the studio here. You're realizing we have more than one set here in the location, as well as our remote sets as well, with the different speakers in different locations. It's a hybrid world, not just for you, but for all of us as well. Got a few minutes here left to answer a couple of questions. I think we've got Steve away, so let me take one of these on. Kai asked the question, that's an awesome demo. Is this code open source? I'm curious about the Tailwind bits. And I think Steve pointed this out right at the end of his talk, that all the code is actually on GitHub. Not only Blazor itself, which has always been an open source project, but specifically the sample apps we were just seeing, they publish everything into that repository. So you can always learn from it and even contribute to it. That's part of the power of this way of developing. One more question up here, and this is from Mir, asking the question, can we call multiple APIs simultaneously in Blazor WASM? Now that's, I think what you're asking there, Mir, is really about multi-threading, and multi-threading is a feature we're going to look at in the perspective of .NET 8 and Blazor, so that's supposed to be next year, but there's already previews out, so if you want to experiment with it, and you will be using experimental bits, you can try that on today, so you absolutely have that choice. Blazor is amazingly young. It's hard to realize, and I had the good fortune to be there back in 2016 at the NDC in Oslo. Steve Sanderson did a talk kind of out of the blue, and remarkably, thinking about our days so far today, David Fowler was in the room when this happened. He showed it for the very first time, this idea that he could run C# inside of WebAssembly. Of course, at that time, the C# he was using was a very odd, old, open source project. So he kind of cobbled these bits together, kind of without any warning. We were able to watch this talk where he wrote some code that actually ran in WASM, and suddenly we were running C# on the browser. And I remember David Fowler looking like his head was going to explode. He was just holding on to it, wondering, like, is this really real? Of course, that then turned into this open source project. It was completely experimental for a number of years, largely as they figured out how are we going to make .NET live in WASM as a whole. Today we have this amazing ecosystem. It's kind of emerged, but it's only 6 years ago that we saw those very first bits that even looked like that. That's the fun of a .NET Conf and this whole open source movement around .NET, and I hope you're having a great time too. And I'd be remiss not to call out our awesome sponsors, the folks that help make this show possible, and they are running that secret decoder event so that you can actually win some of the swags. There's a ton of good prizes, so check out the links. Do the secret decoder test and be part of that. The draw is going to be tomorrow. There'll be lots of fun things to win there too. And hey, don't miss out on your Code Magazine subscription. If you're a viewer, you can be a subscriber too. Get some paper. Get back to the old magazine fun that Code Magazine is actually. I think we're just about done here. We got to hand off to our next topic, which is Playwright. I've got Debbie and Max waiting over on Teams. Let's send it to them and I'll talk to you later.
Thank you very much, Richard. So yes, we're going to test Blazor applications with Playwright. My name is Debbie O'Brien. I'm a senior program manager at Microsoft. I'm working on Playwright, advocating for Playwright. And I have with me
Max Schmidt, and I'm a senior software engineer in the Playwright core team. And today we are showing you how to test Blazor applications with Playwright for .NET.
And that's us running in Berlin because we get so much time to do sport because our tests run so fast. Am I right?
Absolutely.
Okay, so for those that don't actually know what Playwright is, Max, how would you define Playwright?
Now, Playwright is a very modern end-to-end testing framework to test modern web apps, and you can do it in any browser, any platform, any language you want. Like we are available in Node.js, we're available in Java and Python, and obviously where we are focusing today in .NET. And yeah, any browser. What does it mean, Debbie? It means like we are available in Chromium, in Firefox, and WebKit. So for Chromium, this means you can use us in Microsoft Edge, you can use us in Google Chrome, and any Chromium-based browser. So you can test Android applications, you can test WebView 2 applications, and you can test also Opera and so on. For WebKit, for example, yeah.
If you're on a Windows computer, you can test WebKit Safari, right?
Yes, WebKit Safari. So usually if you're a QA tester and you're usually on Windows, it's hard to test WebKit. It's hard because WebKit is only available inside Safari normally. But with us, you can either do manual testing in WebKit, but you can also do automated testing by writing Playwright scripts for end-to-end testing.
Excellent. And Playwright runs in full isolation. Now, how I define this is I write one test and then I write another test and nothing leaks in from one test to the other. How would you define isolation?
Good point. Isolation is like from other end-to-end testing solutions. Usually after each test or after each test file, you restart the browser, right? And restarting the browser takes a lot of time, usually between 1 and 3 seconds. And what Playwright does differently is we have this concept of browser context. A browser context is an in-memory browser profile, which is fully isolated from other browser contexts. And each of the browser contexts has pages underneath. So you can easily represent multi-role testing scenarios by using multiple browser contexts. For example, you can log in on one page with your admin account and on the other page with a user account, and then write an end-to-end test and test against these both roles at the same time.
Which is kind of really cool, and it kind of makes sure that there's no flaky tests, which means your tests are going to pass and you can have a great weekend, right?
Absolutely, absolutely. So none of these tests then depend on each other since every test gets a different browser context. And that's available in all 3 browsers.
Excellent. And one of the things I notice when I run my Playwright tests is that they are super, super fast, right? But how is it so fast? What's going on behind the scenes?
So, good point. So, why are we fast? We mostly explain it by saying this concept of auto-waiting. Playwright has auto-waiting by default. This means when you have, for example, you click on a button, Playwright not simply clicks and then fails if the element is not there. Playwright essentially performs a variety of different steps. So first, for example, we wait until the element is there. Then we make sure that the element is visible, that the element is stable, which means it's not running any animations or something like that. We make sure that the element is clickable in the end, and we also make sure that the button is enabled. And all these steps will perform until the timeout is reached, so you don't have to rely on time.sleep like compared to other solutions.
That's cool. Less work to do. Tests run parallel, run super fast. Everything is fantastic. And we also have very powerful tooling. Now, I'm going to share my favorite tooling, which is my favorite feature is CodeGen. Max, what do you think of CodeGen? Like, just look at this, right? Basically, with CodeGen, I can set up like my application here, right? I've got this to-do app, and I can literally start writing into that to-do. I'm going to write some tests, then I'm going to do the washing. And as I'm writing the test, you can see over here in the inspector window, my test is being created for me. I'm not writing any code. I'm literally clicking like what the user would do. And right before my eyes, that test is being created for me, and I can then copy it and put it into my editor. I mean, that is cool, Max. What do you think?
Definitely. So you don't have to worry about finding the right selectors. It will all automatically generate it for you.
It's amazing. I love it. It's my favorite. What's your favorite tool?
My favorite tool is Playwright Tracing. Let us show it to the users. So Playwright Tracing is a tool to essentially debug Playwright tests which run anywhere. For example, inside the cloud, which means on your CI. Playwright Tracing will, on the left side, list all the Playwright steps which got performed, like a fill, a press, a click, or whatever. And it will show us a small timeline at the top. And the most powerful thing, it will not show only a video or a screenshot, it will show you a snapshot of the site. So you can use Chrome DevTools to take a look at the snapshot. You can take a look at the CSS and the DOM structure before, during, and after a certain action. And on the right side, you will have a lot of debug information available. So all the arguments you pass to the call, and you see console, network, and also the source. So it will all the way down to the C# code, like which line performed which step.
It's very cool. Like, we recommend running this on CI when the test fails, but I love actually running it in development when I'm developing because I just get to see what's going on. It's kind of cool.
Definitely.
So, Max, let's talk about Playwright and .NET. What is the .NET experience like in what's the Playwright experience like in .NET?
So you can use Playwright with .NET in, as of today, 3 ways. So you can either consume it as a library, so you can write your own scripts, you can write your own .NET run programs, you can use it anywhere, like in .NET 6, 5, or .NET 4.8, but you can also use it with our available MS tests and NUnit integrations. And MS Test, speaking of that, that's the integration where we are focusing on today, and we are writing a small test today.
Yes, I love seeing live demos. Let's do it. What are we going to test?
Let me share my screen at my terminal. So here we have a small terminal, and let's scaffold
Where do we start?
Let's scaffold a new MS Test project by saying like .NET new MS Test, and let's call this folder maybe Playwright test.NET Conf. And what this gives us is a new MS Test project inside a Playwright test.NET Conf directory. And we can open this folder once it's generated in our favorite editor, in our case, this one here, in our case, VS Code. So let's open it.
So hang on a second. We're working with .NET in VS Code. Can we do that?
Yes, absolutely. So there are extensions available for any language in VS Code and for C# as well.
Amazing.
So let me open it in full screen here. So as this project file got here generated and a small basic unit test and some global usings. The first step, what we want to do with this basic MS test project is to install Playwright, right, Debbie?
Yeah, I mean, can't run the test if you don't have Playwright.
Yes. So let's install it. So it's essentially this. So this will install two things. It will first install Playwright, and it will also install the MS test integration. And let's make sure that the project still builds. And then we can
does it
start.
install the browsers as well?
By default, not. So good point. Playwright is structured in a way that you need to install the library or like the stuff, how you consume it, and you need to install the browsers. The way how you install browsers is like in .NET that you have this bin directory, and there you have this powerful Playwright CLI. We will see it later. It's the way how you launch CodeGen and how you, for example, open WebKit on Windows. But it's also the way how you install the browsers. So we can do this here. Let's see, it's a bit hanging here. Let me open my new terminal. Maybe that helps. A lot of things are running on my machine.
Installing our browsers, right? And which browsers are we going to get installed by default? Does it install all of them?
So by default, it will install all the 3 browsers, which means like a Chromium, a Firefox, and a WebKit. I executed it here, so you see, and it was pretty fast, right? Because the browsers are already there. So this is a step you need to do on every CI run, or once you have installed it on your machine. So cool. Let's write our first test. Let's see. We have here our unit test. Let's jump straight over to the docs and grab here our example test, which we can run for this demo. Let's copy it in here and fix the usings a bit and run this.
Okay, so this is a nice easy test where we're basically going through the documentation site, the main page. We're looking for the Get Started button. We're going to click that Get Started button and it's going to go to the intro page. Simple as that.
Yes, and it's making sure that the title is correct and the URL is correct, right?
Yeah.
So we executed it here with a .NET test. And it said,
already passed.
It said passed. Debbie, did you see a browser?
I didn't see anything, like literally, no, there's no browser.
Is it fake? Do you think it's fake?
I mean, I wouldn't trust it. Would you trust it? I mean, I know I write great code, but I don't trust that.
Definitely not. So let's try to make it headed. Headed is essentially the way how we launch it with a graphical user interface. By default, they are launched headless. So to do this, you can specify here this Playwright, this .NET setting by setting playwright.launchOptions.headless, and we set it to false. And then we should see a browser. Let's see.
Okay.
There is a browser. Very. This was quick, Debbie, right?
I mean, it was too fast, right? I have no idea what went on.
Yeah, let's make it a bit slower. So.
Oh my God, our tests are so fast that we're going to slow them down. Is that what you're saying?
Yes. Only to see that something is happening. So I set here the slow-mo to 1000, and this should run it again and delay every action by 1000 milliseconds.
Just to prove to me that the test works. I like it.
Yes.
So now it's going to go slow, obviously, which is what we want. And here we go. We've got our browser. We clicked and we went to that page. Perfect.
Yeah, still pretty fast. Anyways, cool. So you can run it in different browsers as well. You can, for example, here saying playwright.browser name. Should we run it in Firefox or in WebKit, Debbie?
Oh, let's do Firefox.
Firefox, okay. Let's say playwright.browser name Firefox and execute the same. And this will essentially spawn a Firefox instance. Nice. Here we go.
Look at that. You can see the difference in the browser. It was very fast, but I saw it.
Yeah. We can first come to a little debugging utility and show that to them by saying await page.pause async. What this does, it will pause the test execution. So you can debug it by using DevTools, by seeing the logs, seeing the Playwright actions, and you can also step through them.
Which is kind of nice. So if you do have any errors, you can go through it step by step and figure out what's going on.
Yes.
Excellent. So this is going to launch up my browser. And from there, I'm going to see the browser, but I'm also going to see the inspector like the code gen, right?
Yes, you should see it. Let me, we're all up to date for restore.
And would this be considered your most favorite debugging way? Because there's a couple of ways, right? We've got page.pause, but we also have the PW debug. What's the best way to debug?
The best way to debug, it depends where you run it, right? If you run it remotely, then using Playwright tracing. If you run it locally, using the built-in debugger. Let me remove it with Firefox. And yeah, Firefox is normally a little bit slower than Chromium.
Okay, so we're going to open this up and we're going to debug it. And well, we don't need to debug it because the test passes. And if this is not going to launch, then we'll go straight in and create a test. Because I'd like to see CodeGen in action, even though I showed the video, but I want to see us actually build something.
Yes. So it seems like .NET has some problems here with launching. This might be all of this live stream software running on my machine. Let's try to jump straight into CodeGen, Debbie.
Okay, so I want to create a new test. And this is our most favorite way of creating a test. Now, you could totally go to the file and just write all the code yourself. Like, totally okay to do that. But if you use CodeGen, it's just going to save you a lot more time. It's going to make your life more easier, and it's going to help you choose the right selectors. So you don't have to think like, which one am I meant to use? Which one is the best one? Because CodeGen will give you all that for you out of the box, right?
Yes. So to launch CodeGen is the same as how you install the drivers. Let me maybe unplug this external monitor, then it should be probably a bit faster.
See, live coding, this worked so well 10 minutes ago. And you live code and look what happens. Always fun. Okay, so we're going to try again to launch CodeGen. And yeah, new terminal, and here we go. So yeah, we can launch CodeGen, and you can choose between the different, between the library, right? And between NUnit and MS Test, am I right?
Yes, you can.
So while that's launching, if this doesn't launch, then Will can just push that test because we've already created a test. So we can push that test to GitHub and run it on CI. Should we go ahead and do that, or we see if streaming live demo continues to cause us issues?
Something is happening.
Oh, it's happening. Look at that. The external monitor. It was all the external monitor's fault. Okay, so we have a browser window. That's what gets launched. And we have the inspector window. That's great. We've zoomed in there. Excellent. So we've now gone to that page, .NET Podcasts site, because that's what we put in the terminal. So now we can start writing.
This one is Blazor based, right? This one is Blazor based, so it's all available on GitHub.
Okay, so let's write a test, Max.
Yeah, so what we see on the right is CodeGen, right? You can select your target here. In this case, we want to use MS Test. Let's do this. This will give us a small test. So, and let's write a small test by, let's see, going here a little bit more down. While we hover over these elements, it will show you all these selectors, as you can see. Let's go first to discover more. And then we see a lot of podcasts, right? For example, Hello World and Maui and ASP.NET Monsters. All are pretty interesting. Debbie, what's your favorite podcast?
I mean, .NET Rocks by Richard Campbell, of course.
Very nice, very nice. Well,
Did you know we have a Playwright one on there?
I did not. That's cool. And let's make an end-to-end test. Let's say we want to make sure that this text is there, right? Let's click on it. So for the future, for later, these selectors are there. We will later transform it into actual assertions. And let's make sure this listen later feature works. So I've seen that on this site, a new feature got introduced recently. You can go to each podcast and you can click here on this listen later thing. And
Exactly,
then it
because
should
we're at a
appear.
conference, so we don't have time to listen to this podcast right now. So you want to click on later, and then it should be in that listen later. But look, as you're hovering, right? I just want to pause there. Get by role, area role link, listen later. So it's giving you all that, and it's making sure your site is accessible, isn't it?
Exactly. So by default, it's using these area role selectors, which are basically actionability selectors. So if you go to listen later, then we want to make sure this podcast is there, right? So let's click on it again.
Sure do.
To have here these clicks, and that's all what got generated. We can open it here to see it. So we go into the site, and then we are click on Discover More and the .NET Rocks podcast. Then we have these 2 clicks, which we want to convert into assertions. And we click on this Listen Later, and then we are going on the Listen Later tab on the actual site. And then we actually want to make sure again it's there. So let's copy this and make it a real test. Let's go back into VS Code. So let's close CodeGen and paste our test in. Let's close this and make it a real test. Let's say this here.
So now what we want to do is make sure, like the headings, because the user's not going to click on that heading to make sure .NET Rocks exists. That heading, we want to put an assertion and say, expect that to be visible on the page, right?
Exactly. And each assertion, each expect statement, like we have a lot of assertions available, as you can see here. So to be checked, disabled, empty, like for us, it was important to be visible. You can also use to be hidden, and you can negate them with .not as well. So let's use here to be visible. They will retry, like these are async expects, right? Async assertions. So they will retry over and over again, either until the condition is met or until the timeout is reached. So let's do the same here and then see if our test passes.
I mean, it should pass because CodeGen wrote it, so it should be fine, but you never know, especially since we made some changes. Got to make sure it actually works.
Yes. So,
and what I love about the locators here, while you're running that test, I'll just explain role headings. So it was very easy for us to go over the headings to make those an assertion. We know that the link, that's a click event, so we leave that one. So it's really easy to kind of modify those tests. And for someone new to testing, this is such a great way to get started.
It is. So you never have to worry about these selectors. They are all generated for you.
This is why I told you, CodeGen is my favorite feature. I love it.
And here you see passed 1.
Oh, it passed. And I didn't see anything because it was running headless, right?
Yes.
So this is amazing.
So what do we do next, Debbie?
I mean, obviously, like I want to make sure that everyone can listen to .NET Rocks and listen to my podcast and that test works and nobody comes along and breaks my code. So I don't want to run that test locally. I want to run it on CI. And we have an option for that. And I don't know how much time we've got to get it up and running, but I think we already created one and we pushed it to GitHub. Am I right, Max?
We did. Let me quickly open this so we can take a look. So let's open GitHub. Here we are. And let's open my account.
We're using GitHub, right? But it works on all CIs. So, you know, you can run your tests on any CI that you want, but we like GitHub, so we're going to run it on GitHub just by using a GitHub Actions.
Exactly. So, and here we have our .NET Conf demo. And this is essentially the same as we had before. We have our unit test 1, and it's essentially the same script. But what we added is like we first pushed it to GitHub, and the second is we added a GitHub action. And the GitHub actions are placed in the .github workflows folder. And here we do what we did before. We install the browsers and we run the test with .NET Test. And this means for every commit to your main branch and for every PR, it will run the tests. And these are like best practices you want to have inside a modern web application. So here you see it, test, and passed 1.
So if this test failed, you'd actually be able to go in here, see the log, and be able to kind of say, right, I'm not going to accept that pull request because that test failed. And yeah, then it's a lot easier to make sure that, you know, nobody's going to break your site, right?
Exactly. Once you change your Blazor site, then this GitHub check, they call it, will go red. And you can set up branch protection rules to not allow, for example, red status checks before merging them.
Excellent. I mean, Playwright has everything. I think it's just an absolutely amazing tool to help you test your Blazor applications. And I think that's pretty much all from us. Am I right, Max?
This is right. So for any further questions, go ahead, check out the documentation. We have them for writing, running, generating them, for debugging them in the cloud, and for using them with MS Test and NUnit. And we have a lot of guides as well, which cover a lot of scenarios.
Excellent. So this has been so much fun. The .NET experience with Playwright is absolutely amazing. Back to you, Richard.
Wow, Debbie and Max, thanks for all the great endorsements on .NET Rocks, and I hope you'll catch Debbie's show that we did together back at NDC Oslo in the Fishbowl. Not a fancy studio like this. You're seeing a bit of what it's like to do the work in here. Suddenly we're in the studio space, things are a little different. And here's the spot where we actually get all your questions to come in. And I've been having some fun with some of them here. Earlier on, we were talking about with Stephen Taub about doing testing, and our friend Jess Fritz pulled up the classic 8 million tests. And Jeff's here too. He's ripped through the glass there. There he is. Yes, he could be Dr. Evil, but he could be Jeff Fritz also. So beyond that, sometimes the conversations are technical, sometimes they're more about enjoying the great experiences that we have. I think I mentioned this earlier, Menran saying again about Taub, it's like we're diving deep on a subject that's so deep, I think none of us were swimming at that point anyway. So this is the studio experience, and we've had a great first half of the day here at .NET Conf, and we're getting close to the end of my time, but we're also crossing the streams a bit. GitHub Universe is going on as well, and so we're going to be able to transition over to them too. And I hope you've spent some time on the .NET Conf site at .NETconf.net, also checking out the secret decoder messages and getting your contribution in to be able to win some of that swag from our awesome sponsors. We've got the Code Magazine subscription, so grab that link to Code Magazine, get yourself signed up, and you can read all the same folks that we've been talking to today and their contributions into the mag as well. And certainly, last but not least, if you got a chance to check out a little .NET Rocks, take it on. See what you think. They're audio only. All the folks you talked to before, we've had Dan Roth on, we've had David on. In fact, we're now talking about that Architects panel being a separate .NET Rocks episode because it's all part of the fun of having those kinds of conversations and exploring deep on the technology. So if you want to learn more, there's plenty more places to learn. You've seen a lot of great sessions today live, but next coming up is many of these sessions are being pre-recorded, and you're going to be able to get them on Microsoft Learning to actually listen in on them too. So we're out there looking for Scott Hanselman right now and seeing if we can hook up with him and get into that conversation and what's going on GitHub Universe. We've got a little more time before all of those pieces come together, and I hope you'll be sticking with us and hanging out for all of that good stuff. Don't forget the survey. Links are available there. And Scott, if you're with us now, I'll hand it over to you. Hey, Scott, you there?
I am. How's it going?
Things are great, man. Wish you were up here. I hope you're having a good time.
Yeah, I wish I was up there. Sorry for not being able to make it up in this particular trip, but I appreciate that you're here.
Yeah, it's great to. I came down, so you didn't have to come up.
Exactly.
All right, so what do we do with GitHub Universe today?
So as I understand it, the folks at GitHub Universe are, of course, they're happening at the same time, so there's this live stream. And they are, you can see, actually, it looks like we're live looking at, actually, we can bring that up again. If we're going to just be, live TV, let's just be live TV, right? Mm-hmm. You can see the folks over at GitHub Universe are setting up. So we've just finished a session, and folks are setting up there in this center square at the Center for the Arts there. And they're going to bring in Brian Randall in a second here. I don't know if they even know that they're live, which I think is kind of funny. It's very likely that they don't know that they're live. Brian is going to come over and hang out, and we're going to chat with them about what's happening. But I can certainly talk to you about how I'm feeling before they get here. It's unclear what's going on at this point.
Sure. I had the thought from Ghostbusters that it's always challenging to cross the streams.
Yeah, it is. I mean, the thing is that there's 2 live streams happening at the same time right now, of course.
Right.
And you can see there's a, Gaffer just walked by, and there's cord management and stuff like that. So they're going to eventually take our stream and broadcast us to GitHub Universe, and then we are seeing, of course, a live feed. This is like the man on the street interview, of course. There's not a hurricane here, but there's just a hurricane of activity as they go and set up the machines there for the next stream.
I'm just appreciating all that sunshine because it's been pretty gray down in up in the Pacific Northwest. We keep forgetting time shifting. It's all the same time zone, but definitely different weather.
Yeah. Actually, one thing that you may not have seen, actually, Richard, let's bring me full screen, and I'll show you something that I've been doing with GitHub while we wait for them to set up. And,
code demo from Mr. Hanselman? I'm all over that.
Yeah. So let's go ahead and put me full screen here, and I'll pop something up here and show you something that I've been working on lately, okay? So here's the deal. We've got this website here is called Azure Friday. You've probably seen this before.
I have watched.
Let's see. Yeah. Let's see what's going on here. So if you can see that Azure Friday, I'm looking at the live stream because I want to make sure that I'm not in a two-shot here.
Yeah, it looks good to me, man.
You're able to see that okay?
Yeah, it looks fantastic.
Okay.
And your perfect zooming skills are still perfect.
All right, good deal. So Azure Friday is the website that I'm running for the Azure video podcast that we do. And if we scroll down to the bottom of it here, you can see right now I'm currently on .NET 6, and I'm in the process this week of upgrading to .NET 7, okay?
Right.
What I've done here is I've put this on GitHub, of course, and people can go up and look at that. It's public. It's pretty awful code, so lower your expectations. But within that, we've got this .github folder, okay? And in that GitHub folder, I've got a workflows with its Azure Friday.
Nice.
Okay.
Is that a YAML
I'm not a fan
file?
of the YAML.
Oh boy.
I'm not a fan of the YAML, but the kids love the YAML. And within this, you can actually see on GitHub that this YAML file includes information that Azure would need so that we might go and do a deployment directly from a GitHub action. So we've got .NET Core right here. So when I go and upgrade this to .NET 7, I'll add that to this YAML file, and that will tell Azure where the Azure web app's going to go, that it's the release configuration, and that we're going to be using whatever version of .NET that's going on here. All right?
Awesome.
And then the build and deploy job right here is running on Ubuntu, on the latest Ubuntu Docker file.
So that literally just grabbed the latest build.
Exactly. So that's going to use the latest Ubuntu that they've got set up there, and then it's going to use some of these built-in GitHub actions like checkout, which is a pretty standard action, but then set up .NET, right? So GitHub Actions knows about .NET, makes it super easy to do this. I'm going to set up .NET with that version that we mentioned then just before.
Right.
Then restore it, build it, and even I'm going to be running my tests on my website in the cloud.
So this is code, this is your unit test code, like whatever you've written?
Yeah, so this is going to be whatever I want it to be. So in this case, that could be Playwright tests, like we just saw from Debbie.
Yep.
That could be headless tests. Mine happen to be xunit.net tests, which is fine. And then we've got .NET Publish, which is an Azure Web Apps deploy. So this is really interesting to point out that here, let me go ahead and show you this again. That uses, and that uses are 3 different actions. The top one being one that's built into GitHub Actions for checking things out.
Right.
The second one is setting up .NET so that we can do that build. And then here we have an Azure one. So you get this nice sense of orchestration moving through GitHub. And I've got this kind of cafeteria plan where I can pick the actions that work for me and, and make that happen.
What's the @v2, then @v1, then @v2?
Yeah, that is literally the version. So in this context, that version appears after the end of it. So you've got your kind of your namespace, your name, and then your version. Does that make sense?
Awesome.
Yeah, it's pretty cool.
Yeah, no, and it's very clear, right? Those series of steps. Like, I know we're not huge fans of YAML because we've got to get the indents all right, but you can't argue that it's hard to read this, especially in VS Code. the character lighting and so forth makes very clear. This is what I'm going to run. Here's what it's called. Each of the phrases are there. You know what's going to happen.
Exactly. Like you say, you can say, YAML, you can say JSON, you can say XML. You can have opinions about your markup, but ultimately it's just name value pairs. And what's nice about this is it is very readable.
Yeah.
Now, what's cool about this, though, is that inside of that GitHub folder, we do have our workflows. We've also got my most favorite thing, Dependabot.
Right.
Right? This is fantastic. So Dependabot is actually looking at the NuGet package ecosystem, because that's the ecosystem that I care about as a .NET developer.
Right.
Right? And we're going to be looking at the package manifests, and that is going to be looking every once in a while for updates to what's going on. And that is going to then give me a report. So if I go into Actions, we can see these URL changes. This is me. You know how when you do a bunch of commits and you don't know what you're doing, you're like, small change, little tiny change.
Maybe this is the last change. Hopefully the last change this time.
Yeah.
Please
this
save
is
me.
Making a mess. And you can see...
they were all seconds apart, right? I could see
exactly.
19 days ago in X many seconds.
Yeah. But check this out. This is the part that I love. If I go to the pull requests, have you seen this? Have you spent any time with Dependabot?
No. Well, yeah, but not doing this. What are you doing? Okay.
So this is a joy. So remember, Azure Friday is just myself and Rob Karen, right?
Right.
This is not a team, right? I'm not a team of thousands here, okay? This is just me.
Right.
Hanselman International is exactly one guy, and then Rob Karen, who does my video production. But what's really neat about this is it feels like there's more people working for me.
Right.
Does that make sense?
Yeah, yeah.
So here we've got Dependabot, which is a bot that has decided to bump with a pull request. Hey, there's been an update to this particular.
That's Polly, right? That's
Polly, right?
VNX
Exactly.
guy
One of my
supporting
favorite NuGets,
Mhm.
and Polly has been bumped up to version 6.10. Now, what's great about this is the bot writes really good release notes, and it does that by actually sourcing them from here. So that NuGet ecosystem is rich and first class in that. GitHub Actions and that GitHub ecosystem. So I'm inside of GitHub doing my .NET stuff. It's first class, and then they'll go and link me out to those release notes. And then depending on how someone fills out their release notes, some of these release notes will actually include a detailed change log. Look at this. So they've actually copied in from other change logs based on the specific well-known text files, like changelog has a format, right?
Right.
So
and so for you as a responsible project owner, you've got enough information to make a decision about that pull request. Is this going to be good?
So you can see here we've got a standard changelog.md that is keeping a changelog, which is a format, a specific markdown format for changelogs. Dependabot knows that, so this means that I'm looking at a pull request that feels like a real person wrote it.
Right.
And they're saying, wow, here's the changelog. Should I upgrade? Yeah, I probably should take that upgrade. But then it'll even pull in the commits, and I can go and do a diff and see what changed, which is great.
Wow.
Okay. Then merge it directly. So it's almost like I've got these employees working for me, that those employees are actually bots. And that's really great. So that is built into GitHub Actions. And then these workflows can include testing, building, code QL, quality, and things like that. So later on today, when I go and upgrade my Azure Friday to version 7 of .NET, I'm going to be confident that that is going to work out well, because I've got all of those tests and I've got all that support, and it's all going to happen inside of Actions, which is really cool.
Well, and you have all those other possible PRs you could be doing, because Dependabot sorted that out for you and said, oh, by the way, that package has got an update. Here's the changes. Like, you don't have to dig around and do all that stuff you used to do yourself.
Yep, exactly. One of the other things that I've been working on that I think is really cool, that I'm looking forward to working on .NET 7 again later today, is if we go over to my podcast website.
I
kind
heard
of
of
fun.
that.
I think you do this too, is to use your personal websites as, as a test bed for these things, because it's just going to be my site.
Right.
broken.
Yeah. No, it's the right place to experiment.
Last week I got to speak to Randall Monroe, if you remember him from XKCD, so
I
folks
do.
can go and check that out. But we scroll all the way to the bottom. Look at this. Look at this. See how we've got, again, .NET 6 upgrading to 7, but look at this GitHub integration here. Deployed from this specific
Oh, I
commit.
love that. I know
Isn't that
what
cool?
build's running on my site right now.
Right. Now, you might like that idea. You might not, right? It just depends on how you want to run your site.
Well,
But,
we're this kind of geek.
Yeah, if you're this kind of geek. So in this case here, I want to see that. Now, I could put an admin block around that. So it's like, if admin show that, otherwise don't show that, right? You don't have to do that. But what's neat about this is then I can right-click on that commit, and I can go directly to it. So let's go ahead and just bring up that commit. And look, I just went directly to the commit 10 days ago. So I know that I made a change to one of my links, and I had it add, and I had a missing at here. So I know exactly what's in production.
Right.
And then because of those actions and builds, or if I'm using something like Azure DevOps or anything that's any kind of build server, whether that be GitHub Actions or otherwise, I can go and click on that link right here, and that'll take me directly to the build logs as well. And again, I could put if admin around that if I felt like that was important to me.
Yeah, you could hide it if you want to, but you get to see it if you need to see it. I think that's the important part, right?
Exactly.
How many times have we got a build-in test that we thought we deployed, but we didn't? And then someone's complaining about a problem. It's like, oh, I already addressed that. And then you have to, you don't know when you look at the production site that change hadn't gotten pushed up.
Yeah. And if I go back over to GitHub and I show you here under security, you can see that Dependabot and code scanning shows up right there.
Right.
So then I can click on Dependabot and see the specific alerts if there was something in the ecosystem I was worried about. Now, I don't have any alerts because I'm not having any security issues on the site right now, but
Don't
GitHub
jinx
Actions
yourself.
and GitHub will warn me as a .NET developer if something goes down.
Yeah. I'm not going to say I look forward to those emails, but I'm grateful when they arrive. It's like, you better go check. Because sometimes these are 0 days, like they're real vulnerabilities, but they're built as PRs. Many times you can just check them in and push your build and be good to go.
Yeah, absolutely. Yeah, learning about these dot files, these .github, or like this .dev container is a super important thing to do, because, for example, here I could even go and open up a code space and pull that dev container in as well. And that's another nice thing. And .NET developers really need to spend some time understanding what's inside of these folders. And if you bump into one of your favorite open source projects and they have one of those folders, go and look in there, see what actions they're using, see their code QL, take a look at how they are configuring their Dependabot settings, and you might learn something.
Yeah, that's an interesting thing to explore. We always learn from others that way. So,
yeah, exactly. I mean,
being able to look at that project and look at your project. Like, I think I'm going to use you as an example, Scott, and say, well, how did Scott do this? And then see if there's some things I could take advantage on run as.
Yeah, that's a great point, actually. You should figure out what are the things that you can do, because, one of the things that I like about this ecosystem is it makes me feel like a 10x developer,
right?
Even though I'm not.
Yeah.
You know what I mean?
Still trying to figure out if those people actually exist, but I get the idea, right?
Well, I'm just one person, right?
Yeah.
This is, like I joke about Hanselman International. It's just me,
yeah,
right? But if I can go and put up a dashboard that expresses what's going on, I can see here that there's, 200 users on my site right now, and I've got a couple of small errors. This makes me feel like I have an ops team, doesn't it?
Right.
Like I'm a real boy.
Well, a sense of activity and what's going on. It's like now you can go mine into those errors. Say, well, what's going on? Like, where are the problems? What's the actual action look like? And then see the effects of your work.
Yep, exactly. So now I'm excited to get, up to date on .NET 7. There's going to be a ton of stuff going on there, and I want to make sure that I know that. So I've recently just updated my Visual Studio just about 20 minutes ago. So I've got Visual Studio running here.
17.4.
Yep, and I've got 15.4, and I'm all set up, ready to go. So then when I load up, like, for example, my podcast website, then I'm going to bring that up and then go through and update this. And in fact, I noticed actually on Twitter earlier, just about an hour ago, Rick Brewster, the author of Paint.net, one of my favorite .NET apps, actually just upgraded it from .NET 6 to .NET 7. And Rick pointed out that it took him 5 minutes.
Wow.
And I was like, 5 minutes? And he says, well, I got a phone call in the middle, so that's why it took so long.
Yeah, I was thinking, what do you do for 5 minutes? It's just a build.
These are the questions that we're asking, right? I'm not exactly sure why it took so long. Well, yeah, it was a phone call. And he's like, a phone call? An actual phone call? Do those even happen anymore?
Yeah.
Right? So
That's
here
not
we
what I
go.
use
I've
phones
got
for.
.NET 7 as a choice right there, and I can make the right choice for me, for my website. And I'll be doing that in the next day or two.
And those little incremental updates, like I noticed one of your sites was 6.08 and the other one 6.010. Like, when do you decide to push those?
When do I decide to update those?
Yeah. Like to actually put those in.
All right,
That's a
let's
great-
get
that's a
to
great
it. Right
question,
now, we're
actually.
going to go live with Brian Randall at the .NET Conference.
Oh, I think something's happening here. Hang on a second, my friends. I think we're breaking in. This is great because we're doing 2 live streams. We're going to cross the streams here.
Here comes the stream crossing. Make sure your protons stay in place.
Well, while we're doing that, I'll show you. If I hit download right here, can you see that?
Yeah.
So here's the .NET website, and I can decide whether I want standard term or long-term support, so I can make the decision that's right for my business and my company.
Right.
I see Brian coming in soon here, and we'll figure out what's going on. I'm looking at the cam. What's happening? What's happening?
Good afternoon, everybody. How we doing here at GitHub Universe? Ooh.
I'll let
Mr.
you go,
Hanselman,
Scott. Have a great
is that your
conversation.
lovely face I see remote in Portland, Oregon?
Test. Are you there? Can we hear Brian? What's happening?
All right, I hear Scott. Do you hear me?
Hey, how are you doing, sir? We're crossing the streams.
This is crazy. I thought we don't do that. That's a Ghostbusters problem. It's gonna change the universe, man.
Cats and dogs living together, mass hysteria. So you have like like water behind you right now. You're in the middle of a fountain.
I am a fountain here in sunny San Francisco for GitHub Universe. Even the sun thought they should come out for a wonderful event.
Very, very exciting stuff. Well, thanks for letting us jump into your stream, and thank you for jumping into our stream. Appreciate that.
It's wonderful. We love .NET developers. So rumor has it, you guys have this amazing thing going on telling the world about a great new version of .NET.
We are in fact. Yeah, we just launched .NET 7, and just a few minutes ago I was talking with Richard Campbell and showing him how I've got GitHub Actions going and building my entire website, testing it, running Dependabot. I've got CodeQL, I've got security updates. I feel like I have a DevOps team, except it's just me, right?
A DevOps team of one, that's fantastic. Love it.
Yeah. So I put together a couple of things for you that might make you smile. First, I've got this lovely slide that includes the shiny GitHub universe. So we got the cooperative crossover for our friends at GitHub. But I think you might get a kick out of this here. You see my LEDs in the background?
Oh, what do you got going on there? Oh, glowing Mona. Oh, that is wonderful, Scott.
Put the Octocat up.
So you know what's wonderful about that is I know in your heart of hearts you're a tinkerer and you like to hack things. So have you got your mail yet today?
I got my mail today? I have not yet received my mail. Do I need to go outside?
Well, no, something's coming for you. We have sent you a special gift, a hackable Raspberry Pi GitHub Universe badge just for you.
Oh.
So Martin Woodward thought of you. It should hopefully even be there today. And we just want to share the love with our buddies. A little ink display, put your name on it, or tell a story, whatever you want to do.
Oh, that is very cool. Actually on my desk right now, I've got, Meadow.NET devices. Meadow just had their release 1.0 release candidate, so I can run .NET on tiny devices. I've got .NET running on Raspberry Pis with our friends at PyTop. So adding a Raspberry Pi device to my my pile here is going to be perfect. I've even got this Wilderness Labs project lab right here. And so in this case, I'm actually putting together a weather station, working on a weather station, again, powered by .NET.
It's a wonderful world we live in. It's amazing. So look for this in the mail and let us know what you think. Put some photos on Twitter for us.
Oh, absolutely. I appreciate that. Yeah. Now you've been heads down, of course, focused on GitHub Universe, but have you seen some of the cool stuff going on with .NET 7?
Yes, and I've actually been able to work with it. But why don't you tell the community what we've got for them? Because a lot of the hubbers are heads down today with our keynote.
Yeah. So, so it's a couple of the highlights here that I'm excited about. I just literally updated my Visual Studio just a few minutes ago, but I was pointing out to Richard Campbell that we've got native support for ARM64, which is really, really cool. So that's cool for a couple of reasons. First, I've got just over here on my standing desk the new Windows Dev Box, which is an ARM64 device. So we've got native ARM. So I've got both native ARM for .NET 7 and native ARM for Visual Studio itself, which is really cool. And right over here, I can grab my Surface Pro X ARM-based device, which I can now run Visual Studio and .NET 7 on. So we're starting to see a lot more action in the ARM space, which is really, really cool. And then
that is great news.
It is great news. And then, of course, Linux support just keeps coming, right? You know, we keep the hits keep coming with the Linux support on with .NET. You know, we're in the box with Ubuntu at this point. So, you know, when you have Ubuntu, you have .NET and you have that ability. So it's nice to just have that out of the box. And we appreciate our partners at Canonical for, you know, making stuff like that happen.
That's fantastic, because just, you know, reducing the friction to get started is wonderful.
Well, you're just nice to know that it's available and it's ready to go out of the box. So the other thing that is really cool is you can build container images with .NET without having to install anything. So you're getting container images out of the box without using Docker Desktop. You can build a container and then push it to a container registry. So developers can build containers locally and push them without any additional software.
Man, friction-free. Keep it up. That's great. What else you got there?
Yep, that's pretty cool. And then, of course, you know, cross-platform mobile apps, the .NET MAUI, the .NET Modern App UI, the ability to create applications that are going to run anywhere. You know, I mentioned before these devices that are running. Is that a DJ?
Yes, we have a DJ. We are getting ready to have some music at lunch.
Just casually. I want to go back to that. You just casually threw out a DJ. That's pretty cool. I'm showing my slides, and then suddenly there's a DJ available. It makes me feel like maybe we should have had a DJ here, and now you're just trying to show off at this point.
Well, it's great to have a live conference after the pandemic, man. You know how it is.
Yeah, that's very cool. I love that. That's cool. We're gonna have to step it up next time and get a DJ, because now you're just showing off. Yeah, so I was saying that actually I want to go back to .NET 6 is included in Ubuntu 22.04. So you just go apt install .NET 6 and you just get it, which is ridiculous.
That's beautiful.
Yeah.
Well, anything we can do to make, reduce the friction so the developer can do the magic and write code as opposed to work on infrastructure and all the stuff that goes into that and getting their machine ready is great.
Yeah. And then, for folks that are maybe on .NET Core 3 or .NET 5, and they're like, I don't know, what do I want to do? You have the .NET Upgrade Assistant now, which is like a step-by-step command line tool that'll walk you through the upgrade process, and it basically will perform the migration for you. So, one of my games that you might remember, Baby Smash,
yes,
is almost 16, 17 years old now. And in fact, the baby from Baby Smash is getting their driver's license this week.
Oh, you poor thing.
Yeah. But that's interesting because .NET is both mature, it's ready to go in containers, it's ready for cloud native, but it's also, there's a lot of legacy there.
Exactly. And organizations rely on it for their line of business software every day.
And Baby Smash, in the example, was a WPF app from 17 years ago. We ran the Upgrade Assistant on it, and we brought that forward. So if you might be using WPF, you might be using WCF, Windows Communication Foundation. You might be thinking, oh, the new .NET's not for me. Turns out it actually is.
That's wonderful. God, I remember when you brought that out. That was wonderful. My children played with it. It was great.
Yeah. I was surprised how easy it was to upgrade. It walks you through the process. It converts the things that you need to convert, and we're putting in analyzers and code fixers. So if you have a WinForms or a WPF, a console app, or a class library app, we'll have these fixers that will say step by step, and it's not automatic. And by automatic, I mean it's not like a black box where it does a conversion. It literally is like an interview. And it walks you through. I'm going to do this. Okay. I'm going to back up your code. I'm going to do that. So you can put those commits into GitHub really neatly and say, all right, upgraded this, upgraded those. And then if you want, squash the commit and do your thing.
Just think about the changes in the generation when you first built that to now you can build it on GitHub and share with the community, get feedback, get pull requests and contributions to just make it all that much better.
Absolutely. There's also a ton of stuff going on in the web space, in the ASP.NET Core on .NET 7. We've got support for HTTP 3 built in. So just when you're thinking maybe I need to upgrade to HTTP 2, too late. Now it's
too late. We're down 3.
We've got that as well. And if you have been out of the .NET space for a minute, it's really, really easy to make these web APIs small, minimal APIs. It's a really interesting expression of how to do a minimal API. So those are great for cloud native apps. I'm looking at the list here. There's rate limiting. We've got new support for output caching. We've got gRPC. The perf numbers that we're getting on .NET 7 are redonkulous and super, super fast. So it's the fastest .NET ever.
That's fantastic. Well,
Yeah.
we're working hard to make it easier for everybody to get started. So do you have another slide there by chance, maybe?
Let's see. Oh, look at this.
Look at that.
What's that? What's happening at GitHub Universe?
Well, we love .NET developers, and one of the things we announced today is code spaces for everyone. 60 hours free to do whatever you want. So that includes .NET on Linux with the click of a button, Scott. Don't even have to apt-get anything. Just open up a new code space.
So that just, do I have to click anything? Do I have to sign up? I don't have to. Do I just have a GitHub and I have this access now?
You have a GitHub handle. You go on, click on code spaces, and click the button. And we got new templates to make it easy to get started. Yeah, I know. What? It's absolutely wonderful. And then we've got, as you know, Copilot is available right now for individuals. You can sign up for a free trial if you haven't played with that. And now it's available for companies. We've had great response from the individuals out there. Over 100,000 people use it every day. And now companies want to buy it for their developers. And you talked about actions. We brought full support for ARM now in the GitHub Actions runners, as well as we have some monster size runners for Windows and Ubuntu. 64 cores, 256 gigs of RAM. I think you can build the next version of Baby Smash okay.
This is the Godzilla level computer machines.
Absolutely. And so we got a lot of other great features. But I think again, we got this new State of the Octaverse report, 10 years this year. And something I want to tell the .NET community, number one, C# is holding strong as the 5th most popular language on GitHub. And you ready for this? You're going to love this, Scott. Our fastest growing communities, the top 10, number 4, .NET MAUI, and number 5, Microsoft Playwright.
Very cool. We just, in fact, just a few minutes ago at .NET Conf had our friends from Playwright come and show us that. And again, running those Playwright runners in GitHub Actions is a really great way to get started with end-to-end testing.
It's fantastic. And of course, GitHub, we're the home for everybody. So Python, JavaScript. JavaScript continues to be number 1. So, if you want to get your web on, we've got lots of templates for that. And again, in security, as you brought up, you can be a DevOps team of 1, and we continue to offer, Dependabot forever for free and open source, as well as the new security report. And that's probably a good thing. If you find an issue in one of those community libraries you're contributing to, we can do private CVE reporting to help the community with those problems. So again, GitHub is all about community for everybody, and we love our .NET developers. So I'm so glad we're able to get together and talk. And I really hope you get a chance to hack on this little Raspberry Pi badge when it shows up at your doorstep.
I will head over to the mailbox right now. It's probably sitting in there. I didn't realize.
I hope so, because I really do. But if it doesn't, we'll get you a tracking number.
Very cool. I appreciate that. All right. So let's find out what's next. I think we're gonna call over to our respective hosts, aren't we?
I think we are. We're gonna say thank you to the GitHub Universe audience, and Scott, it's always great to see you, and our friends at .NET Conf. I think we haven't ruined the universe. I don't see any lightning or any Stay Puft Man coming over the building, so I think we were safe to cross the streams.
All right, good deal. Thanks for hanging out, and have a great show.
Thanks so much, Scott.
Wow, I got to get my hands on one of those badges. I want to play with a new Raspberry Pi 2 as well, Scott. I hope you got yours.
Yeah, I've got to go over to the mailbox and figure out what's going on. That's pretty cool.
Awesome. Well, I got to move on to the next
stuff.
talk. Anthony's right here with us. We're going to dig a little bit into the build experience with dev boxes. Over to you, Anthony.
Thanks a lot, Richard. I'm Anthony Cangelosi. I'm the Group Product Manager for Microsoft DevBox and Azure Deployment Environments. Software development's been changing a lot over the last few years, and so is the way that we work as teams. Hybrid work has become kind of one of the primary ways that many developers work today. It brings a lot of benefits for developers, but it also has a set of challenges with how we get tools and resources and devices out to developers that creates challenges for developers and IT alike. On the developer side, developers are really trying to get into a workstation and get their environment up and running as quickly as they can so they can get into their flow and stay inside of their flow. Now, slow setup and onboarding times has always been a challenge for new developers, but when you combine that with distributing hardware out around the world to remote developers and the supply chain challenges, it only compounds the issues, making it worse, turning a problem that used to be a problem for a few hours of debugging with a team member in the office to one that now takes days or weeks to get up and running. Now, we don't all have access to the same level of hardware and to the same kind of gear to run with. Some of our developers are running on aging legacy devices or have a slow internet connection. This means that our team members may be spending hours building or syncing their code around with their teammates around the world. And the truth is we're all working on things in parallel. You may be working on a feature branch, building a new feature, a bug comes in, a prior one issue that you have to go and address and tackle. You have to stop what you're doing and switch context. That switching of context can potentially poison your environment as you have to go and get your bug from an earlier version of your application up and running, leaving you hours to have to go and recover and get back up and running again. That's just time lost taking you out of your flow. Now, our friends over in IT are struggling with some of their own challenges. They really want to give us the flexibility that we need as developers to be fast and agile, but they need to do this and keep our environment secure at the same time. Now, this can be challenging with so many different kinds of hardware and environments that our developers need to get up and running. You may have one team over here that's working on an AI project, trying to get an AI project with some GPU to be able to do some diagnostics on some large data sets. But at the same time, a few weeks later, you may switch over and need to convert your application from Intel over to ARM. These changing resources mean that developers need to be moving quickly from device to device. Now, many of our engineering systems haven't been built for a remote-first development team. And so this puts a big strain on IT teams to deal with all the support requests that are coming in. Add all of this complexity into our remote environments, and it's ripe for attacks from malicious actors that are trying to take advantage of our systems. And so IT teams need to be able to identify security threats as they come in for developers that are running anywhere in the world. Now, there aren't a lot of organizations that have the scale and the capacity to deal with and solve all of these problems while also addressing their customer needs. And at the same time, those that do often would rather put that energy and resource towards actually solving their customers' problems themselves. And so that's where Microsoft DevBox and Azure Deployment Environments come in. Two services that help you take advantage of the cloud and bring the scale and elasticity of the cloud into your engineering systems. On the one hand, we have Microsoft DevBox. Microsoft DevBox lets your developers self-serve and provision their own high-performance developer workstations in the cloud. These are ready-to-code development environments that have all the tools you need to build applications for your specific project. The images that run and power these dev boxes are built and managed by your team. Your team can put any of the software that they can run on Windows onto these dev boxes. So any IDE, any database tooling, internal apps and configurations they need, they can build so that they have a ready-to-go environment that's always up to date. Now, these dev boxes are centrally managed by your IT team. They're enrolled into Endpoint using Intune. So all of your group policies, all of your conditional access policies are there so your IT team can manage them the same way they manage all of their physical devices. On the other side, we have Azure Deployment Environments. Now, Azure Deployment Environments lets you do a lot of the same things for running and deploying your application infrastructure. Rather than having to manually configure an application environment yourself, deployment environments lets you take a template that's built by you and your dev infra team, and it takes care of deploying that environment on your behalf. So you don't have to worry about how to configure your application. You just need to deploy your app into it and figure out how to get your code running. It also takes care of deploying that on behalf of the user. So IT doesn't have to give broad access to the entire subscription. They can have an identity do the deployment on their behalf so that it gets deployed into the right subscription for the right project. Again, developers don't have to think about where their resources need to go. They just need to focus on what they need to build. So let's take a look at a little bit about how this works in DevBox and Azure deployment environments. So I'm going to switch over to the developer portal for Microsoft DevBox. The developer portal lets developers kind of self-serve and create their own developer workstations that they can access and connect to from anywhere. These project-specific developer workstations have everything a developer needs built into them. So here, for example, you see I have 2 workstations already running. I have my main development environment for the podcast app that we've used for a lot of our demos here. And I needed to work on a project to upgrade some of our dependencies. So I've created a secondary box that I can go and do that work and test those changes without interfering with the feature work that I was doing earlier. And I can keep those environments separated and isolated. Now, I can self-serve my own dev boxes, as many as my enterprise or team will allow me to create. And I can create dev boxes from any of the projects that I'm a user member of. So I happen to be a member of the Orchard Core project, the Podcast project. Each of these have their own set of dev box definitions that are each tailored and customized for building those specific applications. Now, one of the key ingredients for the DevBox service is this idea called a DevBox pool. Now, this cold pool of devices has 3 ingredients that give you a number of different options of how you can set up development environments for your team. The first is the image that gets deployed onto the DevBox. The second is the SKU, or the hardware that we're using for it. And then the third is the network connection, ultimately a virtual network behind the scenes that's getting injected into that VM that's getting provisioned for you. Let's talk about how some of those come together. Here you see I have a few different named DevBox pool. I have a backend dev DevBox. I have a data engineer DevBox. The backend dev DevBox has an image with Visual Studio and all the tools for building our backend services. The data engineering DevBox, that image on it is running SQL Management Studio and Azure Data Studio with a connection specifically for connecting to some of our on-premise customer data. And then finally, our front-end dev has VS Code and some web tools running on it for our web devs. Now, the second is the SKU I talked about. So you see here our data engineering has a slightly larger disk, and once we introduce higher-end SKUs, it'll actually use one of our higher-end SKUs as well. Our front-end dev is using a lower-end, lower-count core for some lower cost and cost savings there. The third piece I talked about is the network connection, or the virtual network. This is a really powerful piece of Microsoft DevBox because it gives us a bunch of options around how we can define the security boundary of the dev boxes that we're using. So while most of these dev boxes have access to the public internet, we also have this privileged access workstation pool that we've created here that has a custom secure network on it that only has access to a few limited endpoints inside of it. It doesn't have access to the internet. It allows our developers to diagnose production environment issues when they come up in a secure, dedicated, isolated environment. I'm going to go ahead and create a new dev box inside of our West US3 region, which is our closest to us. I'll call this my bug fix dev box because maybe I just got an issue that came in that I need to create a new dev box and keep that work separate from my primary feature work. Now, it takes dev boxes about 20 minutes, maybe 30 minutes for them to provision. We're working constantly on reducing the total time for provisioning dev boxes. But what's happening in that time is actually the service is taking care of joining that dev box into your domain. Whether it's an AAD native domain or it's a domain controller on premise, it'll take care of joining that domain for you. It'll also enroll that dev box into Intune for you. That means that your dev boxes that your team members are using are all being managed using the same group policy, the same conditional access policies that you're using to manage all of your devices in your existing infrastructure and IT domain. Now let's go and connect to one of my existing dev boxes I have here already. I can connect to the dev boxes from one of 2 ways. I can either use the browser, and that's great. I love that when I'm on the road or away from my desk and I need to get back and make a quick change on my workstation, I have the full power of my workstation that is available to me anywhere on the road. or I can connect to this from within a Linux workstation if I'm natively logged in and I need to connect back and make a quick change. I can also connect through RDP. Now, RDP is a native application. It's running locally on the desktop, and this lets me take advantage of all of the capabilities natively available on the OS. It's available on Windows, iOS, Android, and Mac OS, and I can connect here. Now, let me sign in to this. Some of the things that you can take advantage of with the RDP client is, first of all, if I was logged onto the local machine with the same identity as the one I used to sign in here, it would actually use Windows Hello to log me in, so I don't even have to enter my credentials most of the time. The other thing is it takes advantage of 4K, high DPI, even multi-monitor support is available. So you can really take advantage of your full development rig from within this experience. Now, I've just logged into this dev box. Now, this isn't just a vanilla Windows image. This is actually a developer image that we've downloaded or using that's been pre-built for Visual Studio users to be able to use to have everything they need to build just about anything you can build with the Visual Studio toolset. This image has on it, and it's available in the marketplace for developers. It's available in the Azure marketplace as the Visual Studio images. It has on it Visual Studio. We have a version with 2022 as well as 2019 available. We have Pro and Enterprise versions available in those images. The images are built in with all of our PowerShell and Azure CLI tools. You can see it has VS Code. It has Git for Windows built in. It also has nested virtualization enabled on these because these dev boxes actually support cross-platform development as well. Now, I've manually installed Docker Desktop on this particular image because I'm able to actually build my container images and do my cross-platform development from this machine. It even has the developer mode enabled because this is really a developer workstation. Now, I've also just recently cloned down the source code for this project and pre-built it, but we're actually working on building a definition that will check into the podcast repository that will actually build the entire end-to-end workstation, including all of your source code and binaries, so that you can actually get right into your development and start incrementing your code, saving all the time of building your container images. All right, so with Visual Studio running, let's take a look at how this works a little bit behind the scenes before we go in and actually start making some changes. So I'm going to move over here to the Azure portal and talk about some of the unique things that you can do with this service as an administrator of Microsoft DevBox. Everything in Microsoft DevBox kind of anchors around the Dev Center. The Dev Center is kind of like the organization inside of GitHub or the organization concept in Azure DevOps. It's a high-level unit that you can use for your entire company or for a business unit that brings together all the projects that your teams, oh, you can get out of the way, stop that. All the projects that your team are working on. And I can create new projects for different groups of developers within our team. Here we have the podcast application running, and we have the podcast project, and all the users that are a member of the group that have access to use this project will be able to see and create dev boxes from the pools that we saw earlier. Now, I can go into the DevBox pools, and I can even see which dev boxes have been provisioned against each of these pools. You can see my main dev box here, as well as a few of the other dev boxes for my team members. Now, one of the questions we often get from customers is, how do I deal with contractors that I need to work on a project and contribute for a short period of time? I need to get them a full working development environment for my complex application, but I don't want to send them a dedicated machine because I have to figure out how I get that device back when our contract is over. I'm also worried about giving them access to their devices into my corporate network, because that means I'm letting unmanaged, insecure devices potentially into my infrastructure, creating more risk for my team. And so that's one of the great things that DevBox allows you to manage, is I can actually create a dedicated project for unique groups of users with their own sets of permissions. So I'm going to go and select the right subscription where my existing Dev Center is running. And let's select the Contoso Dev Center. And we're going to put this in the same Dev Center, but we're going to call this the Podcast Contractor Project. We'll create this. This will take just a moment or two to actually create that. And once this has been provisioned, I will have a project where I can set unique permissions that only the contractors on our team have access to, and that are more constrained and restricted for their use case. So I've got my project now set up. Let's go into Access Control. And let's give our contractors the role assignment for a DevBox user in this particular Dev Center. Select the members, and they are part of, we have an AAD group here for our contractors. And so any users in that podcast contractors group that gets added to there will also be able to access our developer portal and create dev boxes from this one project only. Now, the last thing I need to do is I need to give them a pool of dev boxes from which to create their own dev boxes. Now, one of the things is I can take advantage of all the work that I've done in my internal team, because they're going to be working on our back-end services. So I'm going to use the existing back-end definition that I created for my internal team. So this has the image that's been pre-built with all the tools that we need already on there. It also has the 8-core CPU. If I wanted to have a lower or a higher CPU for this group of developers, I could change that and create a unique definition for them. Now, the one thing I will change, though, from our internal team is I'm going to use this more secure or more restricted network connection for our contractors. Our contractors don't need the same flexibility as our internal developers. They only need to be able to access a few specific endpoints from my application. So I've configured this firewall to limit their network access to only those specific endpoints that they need, further reducing the risk of anything potentially sending information that I don't want outside of the network. Now, that little label is getting in my way, but the second thing I want to show you is that I can also define the level of user rights or access on that dev box. Again, these developers don't need the flexibility of my internal full-time developers, and so I'm going to set it to standard user because I'm already deploying all the tools that they need to build the application, so they shouldn't need to add anything else into that environment. Now, the last thing that I'm going to do is I'm going to set an auto stop time. This is a new feature that we'll have coming out very soon for DevBox in our preview. And it allows me to set a time of day when these dev boxes should shut down when they're not being used. So we'll set that to 5 p.m. and these devs are on the East Coast. So we're going to set an East Coast time zone of, where is New York City? Havana, New York. There we go. Great. So I've set my East Coast time zone. And now, as these dev boxes are running at 5 o'clock in the local time zone, they'll actually shut down automatically. But we're focused on developer productivity. So they won't just arbitrarily shut down a running workstation where a developer is getting their work done. It'll send them a notification first, giving devs a chance to be able to skip or delay that shutdown so they can keep getting their job done when they're busy, but us not wasting compute for resources that are not being used and are sitting idle. OK, so that was a quick rundown, an example of some of the things you can do to be able to provision your own developer workstations using the Microsoft DevBox service. Now let's talk a little bit about how you can do some of the same things with the Azure deployment environment. But first, let's talk about this application, the podcast app. It's a pretty complex application. It's got Kubernetes services, SQL Azure DB, SignalR, all running in an application. And if I was a developer joining the team, having to set up this environment ad hoc on my own is pretty complex. It's pretty time consuming and it's error prone. I might misconfigure that environment. And on the best day, I might misconfigure and not be able to deploy my application. On the worst day, I might misconfigure it in a way that I've left open a security vulnerability in my application. And so the way that enterprises will often deal with that risk is they will lock everything down. They'll say, OK, you know what? We're not going to let just anybody create resources in our subscription. We're going to have our dev infra team or IT admins do the provisioning for you. You as a developer can go submit a ticket to get one of these set up. Well, this just gets in the way of the agility and the speed that developers need to be productive. And so that's where Azure deployment environments come in. It allows developers to self-serve on demand the application infrastructure they need to deploy and run and test their application in what is a real running testing environment. So let's take a look at how that works. I'm going to switch back over to my dev box where I'm connected, and I'm going to come over to the developer portal again here. We're going to go to create a new deployment environment. Now, there are two ways that developers can create deployment environments. They can create deployments ad hoc using our developer portal UI. They can also use the developer CLI, and we'll see how both of those work in just a second. From the UI, they can create new environments for their project, and there are a couple pieces of information they need to set up here. First, they pick which project that they're focused on. Developers don't need to think about what subscription they're a part of or which resource they need to go in. They just know what project they're a member of. They pick their project, and that project defines the next piece of really important information, the environment types. Now, here a dev can pick which environment types they have permissions to. And when they pick an environment type, that connects up and says, for this particular project, which subscription should the service use to provision that environment for the developer, and which identity to use to actually do that on behalf of the developer, allowing the service to do it on their behalf so the developer doesn't need general contributor access to the whole subscription. The last piece of the puzzle here is catalog items. So what catalog items are basically an ARM template with some metadata around them that define all of the infrastructure for the podcast application. Anything you can define in an ARM template, you can put into a catalog item and you can provision with Azure deployment environments. Now, the UI is one way that you can do that for ad hoc, but I want to show you how we're using the CLI in a really innovative way to integrate it into our GitOps flow. Let's come back to Visual Studio over here. And I've got Visual Studio running, and I've got my solution open. Let's imagine for a second that our marketing team really wants to do a push on superlatives. And so they want us to really kind of emphasize that we are the first podcast app written in .NET. So let's go ahead and search for our landing page. And I can bring up my landing page here. And I'm going to search for our first announcement here. We are the first podcast powered by .NET MAUI. And so we really want to emphasize this. This is the very, very first podcast app written in MAUI. So let's go ahead and save those changes. And I'm going to move them over to a development branch where I'm going to push these changes up. And it's going to be our marketing changes. And let's create that. I love how Visual Studio kind of detects that I had some uncommitted changes and actually moves them over to the branch for me. So now I've got my branch set up. Let me go ahead and commit those into this dev branch. Marketing changes. Let's go ahead and commit that. And I'm going to push that up to my remote host. So now my changes have just gotten pushed up into our GitHub fork that we've created of the .NET app. And let's go and take a look at what's going on over there. So moving over to GitHub here into our project. Great. I'm going to go into Actions. And that's because here in Actions, you see that about 15 seconds ago, a new deployment environment was created. What we have here in this sample repository is a workflow that's been configured to actually create a dedicated deployment environment for me each time I create a branch, and then builds my application and deploys that application into that branch for me. So as I'm making changes, I can see those changes running live in that environment and test them and see them and see exactly how that's going to impact the running application. The other thing that we've done here in this sample is we've actually integrated into our pull request flow. So when I create a new pull request against our sample repository here, we're going to go off and kick off another environment provisioning. This one is now a clean environment that lets the code reviewers on our team who are reviewing our source code also see how those changes look in an environment, giving us a chance to detect any potential issues before they get merged in with all the other changes in our team, giving our code reviewers much more confidence in not having to guess about what these changes are doing. Now, I have already a pull request I've created because it takes about 10 minutes for this environment to get set up. So let me go to that. And here I can see in that pull request, it's actually published out a unique URL for the environment that was set up at the time. And here I can see those changes running live. This gives our code reviewers a much richer experience as they're evaluating my changes. Finally, when I'm done with that, I can go and I can merge my pull request. And when I merge that pull request, our workflow is going to go and delete that environment for me. So I don't have any extra resources sitting around unnecessarily. And when this closes the branch, it'll do the same and delete the environment associated with that branch. Now, switching back over to the developer portal, I said there were kind of two key things that kind of make Azure deployment environments what they are. So coming back to the Dev Center here, the first is your catalog items. The second is your environment types. Here in catalog items, the catalog of items that you can provision are basically sourced from a Git repository. This can be any Git host that you're using, GitHub, Azure DevOps, GitLab, etc. And what the service is doing is it's scanning this folder for any Azure ARM templates that are there, along with the metadata that it sees to discover that this is a deployment environment, and making those catalog items available for your developers to provision inside of a deployment environment. This gives you the flexibility to collaborate through a GitOps flow between your development project team and your app infrastructure team. The second part of it is those environment types. So I'm going to come back to the podcast app over here. First, actually, before in the environment types, you can see we have several environment types. I have dev, prod, and this is what wires up and connects the subscription specifically for this project so that the right subscription gets billed for this particular project on the team, as well as the identity that's being used to provision these resources on behalf of my team. Last, we were able to give our engineering team contributor access to the instances of the environments that are created. So you can collaborate and just get permission to the environments that have been created without giving broad access to the subscription. And so if we take a step back here, we can actually see in our environments list all of the environments that have been created through our automated workflow from the CLI, as well as the manual ones that we've created by hand. We can actually drill into the resource groups for each of those, even see the costs associated with each of these environments that are running and manage them one by one. All right, well, so that was a big, quick overview of how Microsoft DevBox and Azure deployment environments give your developers the ability to self-serve their own high-powered, project-specific developer workstations, as well as their application infrastructure. These services today are both available in public preview. We encourage everyone to give them a try and get started. We have a blog, and we have plenty of documentation to help you get started with these services. Thank you very much, everyone, and back to you, Richard.
Thanks, Anthony. And that's it for me. I've been having a great morning hosting, and I hope you've had a great time as well. I've got some new hosts coming in, so let's let them into the building. Myra and John, come on board.
Yay.
I'll let you guys do the Q&A.
Thank you. Good job.
Congratulations. Have a great
well done,
time.
sir.
Appreciate
Thank
it.
you. Thank you.
And that's all for me. Have a great .NET Conf.
Wow. All right. So we are the lucky next presenters. Woo. Hello.
Hi, everyone.
So we were on yesterday for a full session, and we have the privilege of hosting today for the next 5 hours.
Yeah. And we're wrapping up our GitHub section here. Anthony just finished the DevBox talk, so thank you so much, Anthony.
Yeah.
And I think we do have some questions, right?
We have some good questions. I'm not sure I can find it on the board. I was looking on my phone beforehand. There was one that was interesting, which was possibility of integrating with local compute. So if I've got a DevBox and I've also got beefy resources elsewhere, is there a way to kind of integrate those together?
Oh yeah, for sure. So one of the things that you can do is you can configure your network to be able to connect both to the cloud and your on-premise resources. And so you can set up your virtual network to have a VPN connection into that. You can access your on-premise devices, any behind the firewall resources. So you have a tremendous amount of flexibility of how you can configure those connections.
Great. And then what is kind of, as I'm moving into this, where do I think about roadmap-wise? What are some things that this could expand to in the future?
Oh, there is a ton of opportunities of where we can expand. There's only so much I can share now, but the thing I want to kind of leave folks with thinking about is really the focus is about giving developers ready-to-code development environments. It's about getting them kind of all the way to the point that they can focus on incrementally building their application, not having to go and do all that setup and configuration themselves. And so you can just start to imagine some of the things that we'll be doing over time beyond just pre-building the workstation itself that will give us really a rich, powerful environment for developers to build applications of just about any size for any size team.
Great. Let me see. I'm not seeing any other questions.
There's one about there from Richard, if there's going to be dev boxes in South Africa. Right at the point there.
In South Africa region? That's a great question. We have been building out our deployment, and so yes, we are actively expanding what regions we're available in. And so we've been looking at where capacity is in each of those, because as a production service, as a service where developers will be spending their full-time development, we want to make sure that we've got the capacity to deliver the best-in-class experience we can. This is something that developers will rely on, and so we're looking at all the regions where we can get capacity to deliver a great end-to-end service for us.
All right, thanks, Anthony, for that great session. And now let's move on to our next section of
we've been told we're actually not ready to move on to the next one? Great, okay. So actually now's a great time where we can talk about the structure of this morning, right? So we've had, at the beginning of the morning, we had some really kind of advanced content, deep into language features and some really advanced let's build a feature and stuff. Then we moved into a Blazor section, and that was really kind of cool, including the mind-blowing thing for me was Steve Sanderson live coding a live audio editor thing. I was like,
oh my gosh.
as Steve only can do, right? And he's doing audio wave visualization and playback and making it more performant and stuff. So we wrapped up the Blazor section, then we had the GitHub section, and then now we're going into a new exciting thing, which is low code and Power Platform.
Yeah, and Teams. So we're going to learn all about that integration. And we had our conference to conference connection here. It was so awesome to see. And I want a DJ for us here too.
That's right, that's right. And tie in there, but that was actually done using Teams. We've been using Teams NDI for these conference-to-conference calls and remote calls. We're using Teams for all of that. And it's amazing how Teams kind of scales up to handle all that stuff.
Yeah, and go on to .NETconf.net and fill out the survey. We have a survey for you to fill out. And then you can fill out a form and run like there are 25 bags that are sponsored.
Oh, that's right. Yeah. So yeah, it's a great time to, like, you can fill out and you can enter in to join that. Yeah.
Yeah. So great prizes.
Awesome. Okay, so we are ready for Caruana and Heather to tell us our first session, which is on low code and productivity.
Yeah.
Gosh, I'm getting the name wrong, but it's an awesome session.
Let's boost our .NET productivity.
There you go.
Right. Well, that's okay. Hello, everyone. It's okay if you got the name wrong. We know what we're talking about. Thank you, hosts.
Yes, for sure. Good afternoon, Caruana. How are you?
Good afternoon, Heather Newman. How are you today?
Fantastic. Smidge of a cold, but rocking through. So
excellent.
Yeah, awesome. Well, hello everyone at the .NET conference. So happy to be here with you today. We are talking about boosting your .NET productivity with low-code tools. So Caruana and I are going to take turns chatting with you. So a big welcome, and again, thank you to our hosts, and thank you to everyone who's been on this. There's just massive numbers, and it's just so great to see everybody here. So right on. So we're really excited about being here. My name is Heather Cook Newman. My pronouns are she and her. I'm a Power Platform and Dynamics 365 customer and community success lead here at Microsoft. I'm on the BAP team, so in Charles Lamanna's organization, and I pretty much think about all day how to build programs at scale for our community, for our makers and our users and all that kind of jazz. I live in Los Angeles, California, is where I'm coming to you today from here, and I'm originally from Michigan. I'm in the Mitten State, and I spent time in Seattle at the University of Washington, and I was a theater major. And yeah, jazz hands, everybody, jazz hands.
Absolutely.
Yeah, and I've been in around Microsoft for about 21 years. I've been back as a full-time employee the last 2.5. Thrilled to be back, and very excited to work with folks like Caruana, who has been an amazing partner for me for many years when I was in the community as a Microsoft MVP, and now back here at Microsoft. So Caruana. Oh, also, we have our LinkedIn QR codes on our slides. And so if you have a camera or a smartphone and want to do a quick snap of that QR code, then we're connected on LinkedIn forever and ever and ever. So awesome. I will make the slides go for yours, Caruana.
Excellent. Thanks. Hi, everybody. Caruana Gatimu, Microsoft Teams Engineering. I run the customer advocacy group. My pronouns are she and her. And much like Heather, I do community at scale. My team also delivers a lot of engineering solutions around Teams templates, the Teams Emergency Operations Center, adoption.microsoft.com, and more. So yes, snap that QR code, visit my YouTube channel. But let's go ahead and just hop in. You want to know more about us? You can always find us out there on the wire.
Absolutely. So, our jobs revolve around these 3 big items here on the list. And for me, my story is very similar to many in the world where I've been pivoting, learning, and upskilling around the way. And that theater background that I was talking to you about makes it so that I give a lot of keynotes and speak to students, mentoring, all of that kind of thing. Very passionate about women, people of color, and students and allies who are looking to do that career switch or who want to bring more value to their jobs every day. So every day we're talking digital literacy, digital equity. How do we bring these programs to scale and get people prepped for what's to come? And I think that's where a lot of you are thinking about what is to come from where we are today into the future. I know, Caruana, you have such passion around this as well. Do you want to say anything to this slide as well?
I do. I think that you're going to learn a lot about and deep dive into the technology capabilities that are available to you. But Heather and I want you to put that in the context of your broader career. We both feel really strongly that if you're not enjoying what you're doing right now, then now's the time to make a change. And we have so many programs and capabilities that are coming between the low code work that we're going to talk about, the collaborative apps, but also the metaverse that comes, that now is a time to really lean into, by attending conferences like this and taking online skilling and what have you, to really boost your career. So Heather and I are both products of the community. I know we both believe that we wouldn't have the jobs we have if it wasn't for what community conferences like this can do. And I think it's important for us to also reach out and help others who are coming along. Many of you have been around the Microsoft ecosystem a long time, and you probably understand it well, but it's changing. And so now is the time where you can leverage community and the new technology to make sure that you're positioning yourself for the future and being able to help others along the way.
Yeah, so a lot of this content came from a lot of blogs from our colleagues from the Work Trends report. And so you'll see a lot of statistics and data from that. We're going to talk a little bit today about innovations around low code, where I live and breathe every day, the infusion of AI, automation of business processes, collaborative apps, metaverse, like Caroline was saying as well. So, and a little bit about where we see the tech industry going. These slides have been around a little bit, but they're very important. There are some waves of change in development that have been happening, and it's changing the way we work and how we develop, how all of you develop. The first wave is really about the changing workforce. 35% of the workforce are millennials. Folks are graduating who have the iPhones in their hands at the age of 5 now. And so everyone's expecting that mobile first-class experience environment, not just on our smartphones, but in the workplace. And it's not really just millennials. It's all business cases and digital demand, because our workforce will soon be millennials, and you can see the numbers there on Gen Z. Similar, wave 2. This just changed. It was 500 million. It's now 750 million applications will be created in the next 5 years than in the last 40. Wow, right? That's huge.
That is so much. That is so much to think about. And to add one thing there, is your app going to be part of the ones of that 750 million apps that people love to use, that continues to live through the life cycle? It's really important that it's not just about the numbers, but it's also about the quality of the kind of development that you're doing. And that's where we hope we can help you a little bit today.
Absolutely. And I think it's professional developers. Some people have a bad taste in their mouth when you start taking the word developer and say citizen or pro or maker and all of that. And frankly, we're talking to everybody. We're talking to all of you who are our professional developers, of course, and you're awesome at what you do. And there's also all of these new low-code tools that are really exciting that are upskilling folks who maybe are in a marketing department or an HR department or doing other things that are helping contribute to the development process. And hopefully low-code tools are also helping professional developers go faster, right? Which is really exciting as well. And it closes that app gap that we are talking about for sure. I think this is another, this went from 1 million to 4 million very recently. So there's a 4 million developer shortfall. More than 80% of users and potential users of the low-code and no-code platforms say that they are willing to work for a company that invests in their technical upskilling. So if you're working at a company that's not helping you do that, people are looking for new jobs in places that will do that. So to fill that developer shortfall. What is that? What is the answer to this? It's not necessarily teach everybody to code, right? I think, Carolina, you and I have talked about it before. We'd love to potentially be plugged into the matrix without all the weird stuff so that we could, you learn faster, right?
Yeah, for sure. Yeah. I'd love that. I have no problem with that as long as it has an off switch. Privacy slider, something like that is what I would like. But yes, exactly. To the matrix.
Yeah. And, you're a solution architect. That was part of the background of you in the community, right? But your prior job. So that's part of your DNA. Yeah.
Yes, it is. But at the same time, it's not my favorite thing to do. So I differentiate between a cloud solution architect who lives and breathes in that code and has a very deep technical background. I have a deep technical background, but I am a business solution architect. I prefer to listen to customers, assemble building blocks, and use low-code solutions and out-of-the-box capabilities whenever possible to solve a customer's problem. And I think that this speaks to what you're saying about the diversity of people who do this. Can I code? Yes, I can. Am I fast anymore? No, I'm not. But it's also not what sings to me. So it's important to understand what makes you feel like you're getting meaning from your work as you are addressing these industry trends and issues. The bottom line is we're in demand. People who can navigate this ecosystem, leverage all the tools that are available, and solve business problems are going to be well employed over the next decade. And so you're positioning yourself really well by being here right now to build that skill set.
Absolutely. You know, it's one of those things where I come from a consulting background, owning my own business, all of that, right? So I was continuously looking into how do I build for people? How do we get new marketing solutions in there? How do we make sure that we're solving the problems every day for folks? And that is the life of so many of you who are consultants as well, who don't work for those larger companies, right? So this is the place to be. It's an exciting, exciting time. What is the answer? Right? Well, low code, AI, metaverse, hybrid meetings, all of these things from the Work Trends Index. And if you don't know what that is, that Microsoft, we're the biggest lab out there. And so there's lots of information from the Work Trends Index. You can type that in right now and go check it out. But the 85% have positive impact on work satisfaction from using all of these new tools because people love learning, right? And so, and they're very user-friendly. Right? So they're a more user-friendly model than we've seen in the past. And so that upskilling experience has a positive uptick on satisfaction and morale by users. Those are data points that's not me just spouting it off, but that's coming from our Work Trends Index. It's really exciting.
I'm sorry, Heather, I didn't mean to interrupt you. One other thing I just wanted to say, these stats may not land with you right now, or maybe you don't think they're super relevant, but they're very relevant when you're trying to make the business case for the funding for your next app. Right, or for your next development project, right? These pieces of information validated by Microsoft Research can help you move forward your next project. So that's one of the reasons we want to share them with you, is so that you're armed with this information as you're trying to get your next project off the ground or take it from an experiment into a production application, which always requires additional work.
Absolutely. And people, we want to instill confidence in each other, right? And so whether you're from a traditional software background or not, to see the value of your work contributing to your team's success is huge, right? Happy people are productive people. Productive people help drive more revenue, right? That's that wonderful combination right there. So some paradigm shift that's coming up with artificial intelligence and AI. So this is also obviously fueling innovation and technology, and it's allowing all of you to build software solutions using the same language when people talk to each other, like we're talking to each other right now, right? So natural language translated into programming language, and that paradigm shift is being driven by Codex. Most of you probably know what Codex is, but if you don't, it's a machine learning model from the AI company OpenAI out of San Francisco that translates natural language commands into a dozen programming languages. So get this, you're talking about this. Hello, Python, da-da-da-da, C#, da-da-da-da. That's amazing. That's where we are right now. And that Codex really descended from the GPT-3. Sounds like a robot, but it kind of is, right? Generative pre-trained transformer. And it's an autoregressive language model that uses deep learning to produce that human-like text. So once you give it a prompt, it produces the text that continues that prompt, right? And so all that learning for GPT-3 actually came from language data from the internet. So from everybody on this call and beyond, plus learning code from GitHub and other repositories. So you put all of the language on the internet and how we talk and how we speak, and then all the code together. Here we go. Artificial intelligence, AI.
And if all of that was just a bunch of wah, 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 because you might be new here, it matters because this creates an accessible portal for people to speak what is needed and not have to work as hard at some of the things that have been the bane of our coding existence forever. Where's the comma? Where's the semicolon? Are you a tabs or a spaces person? This sort of thing. And so being able to have a different sort of interface to unleash your creativity as a developer is what this is about. Right. I love going deep into what this all means and super impressed, Heather, by your overview of that. I don't think I could have done that well. It was really good. But I also want to connect that to why this matters to you, especially if you're new here. Right. Absolutely. This is important stuff moving forward.
Yeah, and it's somebody new to me too. And I was like, I went deep into this because I was like, I want to know what this is about, And so I think it is the marriage of what you're talking about. How do we make this real? And then where does this thing come from?
Yeah.
we often don't get the origin story sometimes on these things, and we just go next. But anyway, I think, I think there's really a call to invest in employee development, and low code really does empower everyone. We've got, business users, IT pros, pro developers, and we at Microsoft are definitely talking about fusion teams, which is these three together in the trifecta or triad, if you want, of bringing people together to work on these things and to build new apps and to solve business problems together. And so the thing is that those leaders and business decision makers out there, those of you who own businesses, you really got to critically examine the opportunities that are there for offering your employees an opportunity, one, to start working together more. Look at your IT teams, look at your business analysts, look at your developers. Do they talk to each other? I was at a business one time where the support team and my marketing team had never talked. And this was way back, and we were in person in an office. I won't say where, but I said, everybody get up. We got up and we walked over to the support team, and I had the marketing and support team meet because they had never met. Now, these days it's harder to do that, but it is up to leaders of business to be bringing teams together to work on these solutions together. And that's all about meaningful opportunities for career advancement, networking, because the person next to you is probably the person, or the next to you on the call can help you with what you're doing next and next and next in your careers. So anyway, that's what I have to say about that slide. So exciting. So Power Apps. So I'm going to talk about Power Apps for a second. We're creating software applications like Power Apps to make that app development even easier and faster for those fusion development teams, right? So that's that combination I was talking about. And also the capability to develop all the custom connectors with Microsoft Power Platform on the back end. Just one piece that I was really excited about that has been announced recently was, natural language and express design. So developers, citizens, professionals can create low code faster with this. This leverages a lot of that fun stuff that I was just talking about with AI. It's cognitive services, it's detection models. So, those of you who use Figma for your design, which is one of the leading, UI, UX design tools recently bought by Adobe, you can just upload a Figma design file. I was in front of a college last week, and they looked at me when I said Figma. They were like, huh? And I said, how about a PDF? And they were like, oh, yeah, I have those. So PDFs, PowerPoints, paper, a screenshot of a legacy user interface, even a picture of a hand-drawn app can now be converted by Power Apps into a working Power App within seconds, right? With a connected data schema. So these kind of innovations are what makes it so, a developer can go faster, a non-traditional developer can take these new low codes and make apps almost instantly. And this, y'all, is the trend for the next couple of decades that's coming out. So I was really excited about this Power. There's a million things that are happening in Power Apps, and you can check that out on the Power Apps blog or in our community, but this was one I wanted to point out to everybody. So we want to talk about teams a little bit. Caroline, you want to talk about teams and hybrid work?
Yeah. Oh, I'm happy to. Working in the collaborative apps and platform organization under Jeff Tieper is an exciting place to be. We've released 450 new features just in the last year, these 270 million users. Of course, that was tremendous growth almost overnight because of the pandemic, but we're seeing that growth stabilize and be retained because people are understanding the power of bringing folks together in an organization in a more modern centralized interface. And so Microsoft Teams is that center of gravity for the productivity experience. But when it really becomes powerful is when it's the center for app experiences, whether developed in this wonderful kind of fast way that Heather was just outlining, or custom developed apps. Teams is better when people have more of a reason to go there, more than chat and having a video call. Those are great capabilities. I use them every day, of course, and I love them. But what is really powerful about Teams is bringing in those app experiences. And as you think about really transforming business processes in general. And if we go ahead and click to the next one, a big piece of that is thinking about these immersive experiences. So the expectations of the new workforce, of the changing workforce, is something that we have to think about, right? And so, people who are digital natives, who had that cell phone in their hand, that iPhone in their hand since they were 5, expect to have a different sort and a more integrated productivity experience in their workplace, right? And the metaverse is going to help further transform this over time. When we talk about the metaverse, we talk about your portable avatar, being able to dynamically create different sorts of avatars for different sorts of experiences. I used mine this morning in a presentation about the metaverse with an innovation company from France. And it was the one that has a nice, than the one that I have for my team meetings. Those avatars are going to be portable, and they'll be able to interact with not only each other, but the environments that are created in the immersive meeting experiences. To get an overview of that, you can go and take a look at our Ignite sessions and what have you. But from a developer perspective, what matters is, if you, again, want to transform your career, certainly we are going to need more developer staff and creative talent to build these immersive worlds, right? The Unity 3D gaming engine is a big piece of what's coming and what we're standardizing on. And so it's very important to be thinking about this as we go forward. In the next graphic, we're just really showing the power of those connected experiences. So we all know, right, we're going to have a lot more apps and a lot more connected experiences. That's the end of the day. And that's the opportunity that's here. But again, I caution you, many organizations are diving into low code and to custom development and to collaborative apps and experiences. And we appreciate that at Microsoft, but we want quality experiences. We want you to think about the user interface. We want you to think about data governance. We want you to think about making sure that your app experience is accessible and can be trusted and has good best practices. And that's why learning and modernizing your development best practices is so essential. Like, some of us enjoy learning. Some of us are a little bit tired of learning something new every day. That would probably be me, just because it can be very overwhelming, right? But it is very important to modernize these practices as we think about what's coming next. And building these apps with the Microsoft Cloud is also important, because as we think about the graph and all of the data from Microsoft 365 application experiences living in the graph, it allows us to expand the capabilities, the business process improvement, the decision making that can be done. And you can sit down as a professional developer, even with just a simple business analyst, and say, give me an example of your process that needs to be improved. Sketch it out on a piece of paper or in a PowerPoint slide, and then go. And this idea of agile development, right? Agile doesn't mean, badgel, which is poor requirements and not enough user feedback. It means that you can quickly develop and iterate an experience, and especially in a collaborative way, but especially with the new tools around Fusion development, you can collaborate on that code together, leveraging the power of the graph and all of the other components, Azure data, the Dataverse, and all the data that comes from our user experiences, into evolving that experience very quickly. And that's what we encourage, because most organizations don't have the sorts of budgets that can be sunk into these very long, very expensive custom development projects. People expect faster results now. They expect more polished experiences, and they expect it with less, hours of investment there. So it's important to think that through as you're doing that. And then, keep going.
The co-authoring, that was new. That was just announced also for Power Apps as well. That was another big feature of that, finally getting that co-authoring in there, so you can be in there at the same time, right?
Absolutely. And I know we're going to continue to develop capabilities and APIs and feature sets that will allow you to meet users in the flow of work, right? Bringing your app into Teams, and also having other mobile experiences and web experiences is an inclusive act. And that way, you're also, by developing in this ecosystem, getting the benefits of the accessibility and compliance and security capabilities that are already built in to the Microsoft Cloud, right? You don't have to come up with a governance model or an app deployment model from scratch. It's already built into the Teams ecosystem with our upgraded app store and more. And so we are a platform. I know many people think of Microsoft Teams as the end user experience, but we think of ourselves as a platform for you to build upon. And so the creativity and opportunity is endless. And I think when we think about those collaborative apps, it becomes really important, to focus on the fact that we are transforming the people experience with better, ubiquitous, but governed control and access to data so that the process itself can be improved, right? This is the ecosystem that we have to operate in now when we start to think about app development. And I love this quote from Satya. I really want to make sure that we get to show this because everything I do as a business solution architect, everything I think about, and Heather and I think about as customer advocates and community success people, is about ensuring that employees are thriving in organizations, right? That is the differentiator competitively, from a career perspective, from a human satisfaction perspective, that makes all the difference. And it is all about this people first strategy that has led us to having a new frame of reference for the way that we approach development, the way that we approach solution design, and identify opportunities. And it really hinges on that last column there, which is about feedback. If you're doing development work right now and you don't have an established way to get feedback from your users in a structured manner, I would suggest you're missing something, right? Some of the best innovation comes from employees who are closest to the processes you're trying to improve. And so this is very important when you think about collaborative apps. I think it's important in general, but certainly in the collaborative app space, feedback from stakeholders, end users, and the people you're trying to serve is super important. And especially if you skip 2 slides to the scenarios, Heather, I really want everyone to think about how collaborative apps and ultimately the metaverse is going to transform these types of scenarios, right? Operational scenarios, understanding by the use of analytics and digital twins, the kinds of production or manufacturing line changes that can be made. We think about the industrial metaverse at Microsoft. And the data and AI and low-code access and collaborative apps that are going to express themselves inside the 3-dimensional immersive meeting space is what's up.
Yeah, absolutely. And I think one of the things that came out a lot about flexibility, right? Being flexible, having opportunities for people to grow, to change, to learn, to bring in some of these new ideas. Flexibility is a feature these days. It's not a fad, right? And all of these low-code solutions and other things that we're talking about, leaders who are not changing, 2019 leadership practices are not going to meet the moment for
no
distributed.
Nope. Bad idea.
Yeah, absolutely. So positive business outcomes depend on positive people outcomes. And if nothing else, leaving you with that about flexibility is a feature, not a fad. Remember that as you're looking for the new opportunity that you have and when you're giving opportunities as a leader, both.
Absolutely.
Yep. And I think we're at our time for questions, aren't we?
I think we are.
Yeah, and I'll put a couple of calls to action up there. If you'd like to join the conversation from Microsoft Community, follow Adoption and Community Twitter handle that Caroline and I and the team all work on together. And any questions, please let us know.
But just make sure that we're happy to answer your questions. And this community, this space, this revolution is open to everyone. There is room for everyone at this table. And I really want to, both Heather and I want to encourage you, take a look at your career, make sure you're finding meaning in your work. If you don't feel included, then join our community to feel like you are. I mean, the .NET conference community is an amazing place. I just want everyone to know that, across Microsoft, you are welcome and so are your ideas. And so we're really, really happy to get to be here. Do we have any questions from the hosts back there? Because, Heather and I, we can keep talking about this for a really long time.
Wow. Yeah, that was awesome. So I have a personal question I've had. As a .NET developer, I love low code. We use it a lot in the .NET team. We use Power Automate. We have things piped all over the place, write as little code, so write as few bugs as possible. And integrating with clouds resources is great. But I do wonder sometimes as a developer how to best integrate with development resources. Like, do I need to worry about version control? My question is, how do .NET developers integrate with people that are doing low-code solutions? Or how do we manage those things together?
I think that's a great question. So I will say the developer best practices like version control, code checking, and what have you, all of that applies. You shouldn't leave that at the door because you're using low code capabilities, really. I think as Microsoft, we could do a better job of automating those things and bringing those things together from a tools perspective. But certainly all the best practices I learned, 20 years ago still apply. So don't leave them. And I'm sure, Heather, you have something to mention about that.
No, I was going to sort of double down on what you said. Yeah, I think it's like keep your best practices, and also if the tools aren't keeping up with some of those best practices, we need to push on the tools to make sure that they are, right? Yeah. And so I feel like that's a really important thing. And then, GitHub is still, a best practices place to keep repos and all of that sort of things as well.
100%.
Yep.
Excellent. Any other questions?
Awesome. What do we got on the board?
Let's see if we have anything. I think we have mostly announcements. We had one from Jen just saying how awesome it is to have you two. You are so inspirational, two awesome women, and we're also gonna have our next speakers, also another awesome women. So I love to have like all this representation here on the conference as well. And I love the access to everyone, like creating that space for everyone to participate. Right, and you, John, you were talking about like how we use it, the Power Platform and Power Apps in our day-to-day. And so like one thing that we do for the .NET website, we have like the integration with Azure and our website to like get all those alerts to see if monitoring our solutions. So it's not just for like low-code developers.
One other thing, one other amazing thing. Sorry, we use it also in the .NET Conf system. When people create a new local event, they actually will fill in a form. The form goes through Flow. The Flow goes into an Excel spreadsheet that does use geolocation inside of Power Automate, and then it uploads it to an Azure blob, and then the website. So it's all this but it's stuff we wrote 3 years ago, and it still works, and it's so amazing, and it integrates with all these different services. So.
Yeah. And I was just going to add, if you're not using adaptive cards to get those alerts directly in Teams, that is something that every developer should know how to do. ACE is a reasonably easy thing to wire up and make such great portable user experiences. It's an awesome thing.
Yeah, John, maybe we can write a blog together on the question you just asked.
Oh, we sure should. Yep.
That's a great idea. I'll read it.
All right.
A bit more. So yeah, thank you. It's great. Yep.
I also want to thank you both for being here today. Thank you, Karan and Heather. And now we're going to move on to our next session. It seems like an exciting talk.
It sure does. So Julia Casper is going to be talking about using Power Apps on top of web APIs.
Hi everyone, and welcome to the .NET Conference 2022. I'm super excited to be here, and I'm a program manager at the Microsoft Developer Division, overlooking the end-to-end experience for developer and how to integrate and interact with the low-code tooling we just heard about. So today I'm going to talk about how to easily create a web application using Microsoft Power Apps and interact with some of our with a .NET REST API as well. I know probably a lot of people haven't heard of Microsoft Power Platform or haven't even heard of Microsoft Power Apps. So before I'm going to jump right into our demo, I first kind of want to touch on some of the fundamentals, and especially want to touch why as a developer I should be caring about this, or why is this super interesting for me, and what I can actually do with the Microsoft Power Platform as well. So for this, I'm going to kind of show the total overview of the Microsoft Power Platform here and what it is. And basically, it's a subset of different tools and services, and all of these are using low-code tooling. So here you can see the Microsoft Power Platform. In total, it has 5 different subsets of tools. So we've heard about Power Apps, which is basically just a low-code way how to rapidly build web and mobile applications. We are talking about Power Automate, which is the low-code tooling for workflow automation, Power Virtual Agent, which is all about chatbots, Power Pages, which covers the topic of business and external websites, and then we have Power BI, which is the low-code tooling for data exploration or dashboards and reporting. So something I think is very important whenever we talk about the Microsoft Power Platform and about low code, no code, and the professional developers, I think something very important to mention here is everyone is welcome. Like, even though it's called no code or low code, we want to make sure everyone feels welcomed here. And everyone can use this tool because it's basically just another tool for you to be used however you are building your web applications. So something all of these low-code toolings do have in common is a very wide variety of different data connectors. Right now, we are counting more than 800 built-in custom connectors or built-in connectors, which I will be touching on later during my demo. And we also, something that all of these tools have in common is the low-code language, PowerFX. So these are some of the similarities and some of the things you can see all across this entire ecosystem of the Microsoft Power Platform here. So one of the questions I'm getting asked very often, why Microsoft Power Platform, or why should I even care about it? And I think, and we've also heard this in the talk before, is the challenge of keeping up with our business demand. Over the last couple of years, and it keeps continue to be showing this kind of statistic, is something like a so-called app gap challenge. So we are seeing a growing demand for applications, but at the same time, we are seeing not enough developers out there to meet those requirements. And if we look even more in the future, we can see this gap being bigger and bigger. So why not, for some use cases, go back or leverage the functionalities of the Microsoft Power Platform so we can leverage time efficiency and also extensibility. Time efficiency, and I think we all know it, we have a lot of items, a lot of tasks backed in our backlog here, and we probably don't have enough time for all of this to deliver and to think about it. Especially if we've just watched a lot of the sessions during the .NET Conference 2022, and we are probably already thinking about, well, how can I modernize some of my web APIs? How can I build in all of the new features we've just heard about? So there just isn't enough time. So maybe for some use cases, why not just rely on low-code tooling and using some of the capabilities of the Power Platform itself as well? Something also very important, and especially from a developer perspective, is the topic of extensibility. We want it to be as easy to integrate with, not just from a front-end perspective, but also from a back-end perspective. And this is where the Microsoft Power Platform has very great and easy ways to integrate and communicate with your .NET REST APIs, which I'm going to demonstrate in a bit here as well. So when to use low-code tooling? There are definitely a bunch of do's and don'ts. I kind of want to touch on some of the most important ones. Starting with the don'ts, or the things you should be mindful about, is not every application is suitable for low code. It definitely depends on the use case, and it depends on the requirements you're seeing and how you want to build it. I, for example, also talked to a bunch of developers who keep telling me, hey, if I do, especially as a back-end engineer, if I do think about front-end development, I want to have the best front-end development experience I can have out there. So that's also a very suitable case. You should do whatever feels comfortable for you, but maybe in some cases, and especially thinking about time efficiency, you want to rely on some of those tools as well. Something we're also seeing is don't move your data. Especially with an API-first strategy or APIs are everywhere, we don't want to move our data. We just want to leverage our external databases, and we want to communicate and integrate with our APIs here as well. So what about the do's, or what do we want to empower? Is we want to enable API developers to focus on mission-critical solving problem business challenges here. You're the ones who are taking care of talking to our backend services, especially from an API perspective. You want to make it as secure as possible, and you want to expose those data endpoints to your maybe Power Platform users. So we want to enable you to focus on the mission-critical tasks here. We also want to empower API developers, and especially the ones who don't really care a lot about front-end, maybe use some of the low-code toolings out there to easily and quickly create an internal application, and you don't have to care too much about your front-end here as well. We also want to empower, and this probably is a more evolved step, how about so-called fusion collaborations here, or fusion developments, which basically means you're collaborating or working together with some of the business users and you as the developer, and you're together creating applications and you're just scaling your business impact here. So this means you're kind of evolving in the role as a teacher, as an educator here, and you're working together to meet those app gap challenges we've heard about before. So what you can basically see is APIs are everywhere, and we want to empower everyone to use them. And this is where you as the API developer come into place, and you can use this strategy to not just integrate with your Azure API management instance, but also from there to communicate to our local tooling, just like Power Apps. So now the question is, how can I get my web API into the Power Platform? And this is where the so-called custom connectors come into place. Custom connectors are basically just wrappers around a REST API that enables Power Platform users to communicate with your exposed web API. So if we think about different types or different web APIs in general, what we ideally, or what some of the best practices is hopefully adding them to an Azure API management instance, and from there easily create a so-called custom connector and expose your web APIs. Do I always need Azure API management in the middle? No, you don't. You also have the possibility to create custom connectors from within the portal. But especially thinking about that governance and security, it is one of the best practice way how to integrate and how to expose your web APIs and make Power Platform users communicate with your web APIs. So now let's look at the fun part of this session. Next, I'm going to show you a demo. I brought a very compelling use case with me. And the use case is, and generally, I want to show you how easy it is to build a web application using Microsoft Power Apps. And our use case is, we already have an entire architecture set up. We have a web API, we are showcasing a dashboard on a UI layer here. And the question is now, and you probably know this, sometimes somebody from the sales team comes towards you and is asking for, well, you know, this is great, we have set this up here, but I just need a tiny new requirement. And you know how it is, sometimes customers are calling, and I just need a very simple internal application where I can type in some of the parameters and just send it out and add it to all of the things we've already set up here. So in this use case, we don't want to rethink or re-architect the entire system. We want to leverage what we have already built. And in this use case, it would be our order service API. And we want to build on top of it a Power App as a front-end design. And we also want to use Power Automate to generate Teams notification. So yeah, let me jump back over to my demo for this. As I've mentioned, we already have our web API set up. Ideally, we've already added it to our Azure API management instance here. So what I typically do first is I'm going to check on, well, which APIs are already in here. Currently, we can see two different types of APIs. And if you remember our graph right here, the one we care about is the order service one. So what I usually do first is I'm going to test my web API within the portal just to make sure that it does work. For this, I'm going to go into my testing tab. I'm going to select the Get Product one, and I'm going to hit the Send button. As you can see, it's loading. I'm getting a 200, and these are my parameters I can now work with. And remember our use case. Somebody from sales comes to me and was asking about, we need a different front end where I can just basically type in some parameters and add it to our existing database. So now that I know the web API is working in Azure API Management, I want to expose it to the Power Platform. For this, I'm going to switch over to my Power Platform tab, and we talked about those custom connectors. You can see from within the portal, you can easily create a so-called custom connector. So you just have to select which API you want to expose you to. You have to select the Power Platform environment you want to expose it to. In our use case, because we're still in the development phase, we want to expose it to the development phase here, and then we can just easily creating by hitting the button right here. So as soon as we have exposed our web API, if I switch back over to my Power Platform portal, under custom connectors, I can see the web API we just exposed. But remember, we talked about the entire Power Platform ecosystem. So we talked about Power Apps, but also we mentioned Power Automate, right? So because all of these tools, they work together, you can also find in the Power Automate environment the same custom connector or the same API you just exposed. So now if I want to edit it or if I want to check, because we know security and governance is very important, we want to see what is the authentication type for this web API. So for a user who wants to interact with it, how can people interact with it? The Microsoft Power Platform supports different types of authentication types. So for example, OAuth. In our use case, we have implemented or we are using API keys. So if I switch back over to my API management instance and under APIs, if I check different types of settings, I can see that here I have enabled subscriptions. And this means I always have to provide this API key before somebody on the Power Platform side can interact with this API. Especially for mission-critical data, you want to make the API call as secure as possible. And in this case, the provider, the user who wants to use it, does need to provide this API key. So I usually also test it within the portal itself as well. And if I hit the get operation or get product operation here, you can see I'm also getting a 200 and all of the responses in my body. So now we talked about how easy is it for me to actually create a Power App. So for this, I'm going to go to my Apps tab right here, and under Near App, I will choose the Canvas app because I want to integrate and communicate with my REST API. Conf test app. I'm going to find a name. Now I have the option to decide between different formats. So in my use case, I want to create a phone web application. I'm just going to select this one and hitting the Create button. And there you go. This is how you can get started with Power Apps in particular. And you can see right now I have a blank canvas. Some of you might be noticing it looks very similar to like PowerPoint or like Excel. And this is where the whole idea of low code comes in, is where business users who are typically used to PowerPoint, to Excel, they feel comfortable here. So it could be easy to include them in the journey of creating this kind of web application here as well. So yeah, this right now, the application looks very blank. I want to include something fun here, so I'm going to upload one of the medias. I have a fun .NET icon here that I can just going to put right here. I'm going to make it a little bit bigger as well. So now I want to kind of have like a headline here, and you can see the insert button where you can select from different types of integration tools or different things you want to add to your Canvas app. This case, I need a text label, and my text this time is going to say .NET Conf test app. Let's make it a little bit bigger because I want to see this in a little bit bigger. I'm going to make it pop. So now we have our headline and we have like a fun little icon in here. How about if I have some kind of greeting for the people opening up the application? How about, hi, Julia? So as you can see, right now I hard-coded this, so it's a very static name in here. So what about if I want to make it more dynamic? What if somebody else is logging into this application and I want to display their name? So we talked about those so-called built-in connectors, right? And we saw these huge numbers of 800 plus. So what I can do within Power Apps, I can easily add one of these connectors to my app. And in our use case, under the Data tab, I want to add a connector called Office 365, which makes API calls to our MS Graph and retrieves the information from our Microsoft Identity Provider. And if I now call this connector, you can see I'm already getting a few suggestions, what I can do or what I want to do. In my use case, I want to make a My Profile call because I want to retrieve information and get information about the user who's logged into the Power Platform. So I'm going to call this one here. And in my use case, you can see I adjusted the dot here. And now I have a bunch of different informations I can display. So in my use case, I want to display the display name. So I'm going to hit this one here. And as you can see, down here, it just changed. So I don't need this name here. And now it's a dynamic variable. So whoever is logging into the Power App, their display name will be displayed. So now we talked about how can I interact with my .NET REST API, right? So as a next step, I want to add a button because I want to make an API call. So let's add the button right here. I want to change the color because I want to make it purple. I'm going to change the name of it as well. Data. And now if I want to change some of the properties right here, what I'm going to do is first, again, I have to add my connector to the Power App. So I'm going to search for the custom connector we've seen before. Red dog, there you go. There you can see I'm adding it to my Power App. And now every time somebody hits this button, I want my information to be displayed. So what I'm going to do here is I'm going to make this API call. And again, just by simply referencing the custom connector's name, I'm going to call my get product operation. And every time somebody hits this button, it will make the API call. So what about the responses? I need to save them anywhere, right? So before I'm going to do this, I want to save it in a so-called connection. So we have a function called clearCollect. I'm going to just call my collection data API. And now I'm making the API call, basically saving my response data in my just created data collection. I also want to notify, there you go. I want to notify every time, good job, that something has happened. And when it's successful, I want this to be displayed. So let me show you how this looks like. If I play the play button, I'm going to get the data. I'm getting the notification. Good job, got job. English is hard. So now it should be saved in my data collection, right? So I can check my data collection, look that I just created for my web application here. And here you can see these are the first 5 items in this collection. Just kind of as an example how this looks like, what are some of the column names, and now I can interact with this collection. So for this, I want to easily create one of those galleries. I'm going to search gallery here. I'm going to create a blank one. I don't like the layout, so I'm just going to switch up the layout here. And right now you can see it's actually using example data. So before I can interact or display any of this, I'm going to change my example data to my collection data here. And now I can edit some of the fields. I want to have the title being the product name. The subtitle, I want to make it my product ID. And you can see it changing in the back here as well. And the body in this case should be maybe the unit costs. So now you can see we use the Office 365 connector. We made an API call to get our data, and here you can see our gallery displaying the data we just got from our API call. So just imagine, it just took 10 minutes, right, to kind of simply set this up. How about if we include somebody from the business side because they were the ones wanting to show and wanting to add something of this? So let's just imagine, I don't want to save it. Let's just imagine somebody else had set up already a Power App for you. So I'm going to edit this one here. It's a little bit more fancy. I mean, I'm not a designer, so maybe somebody from the business side had maybe a day or something to had time to integrate and like to make this Power App really nice and pretty. And this is one example how this could look like, right? If we look at our submission screen feed here, and I just kind of want to show you what you can do while submitting one of the orders is. You can not just make a post order call, so you're basically making an API call to post an order, but you can also send it via a Power Automate flow to your Teams application. So let me show you what this will look like. If I fill out these here, I'm going to select one of the products. I'm going to hit the Submit Order button. I'm going to switch back over to my dashboard because I want to see if this actually worked. Here you can see, okay, perfect. I got my order request here. I can see my dashboard being updated. And now I'm going to switch back over to Microsoft Teams because remember, we called a Power Automate flow saying that we send out a message here as well. And as you can see, I'm already getting an update here. And in my order submission channel, via an adaptive card, I just posted the new order submission based on the parameters we put in here. So thank you all for listening. If you want to learn more about this, feel free to get started. We have a bunch of QR codes here that helps you to get started with Power Apps, with Power Platform, with API management, and with using some of the low-code tooling here as well. And now I'm going to hand it back over to our moderators, John and Mariah.
That was awesome.
Wow. Was great.
It's amazing what you can build in that amount of time. Yeah.
And I love the Teams integration because right now I live on Teams, and so having that connection to Teams is like my life.
Yeah.
And what I also love is to see like how you can use .NET with different front ends. So it's like you don't have to think about .NET just like as a full stack. You can use for your back end, you can use just for your front end. It's like you can choose what makes sense for your business.
That's great. Yeah, and it's, it's very tempting as a developer, a .NET developer. We're at .NET Conf. It's very easy to just sit down and bash your head and write some code. And it's really nice to not have to write a bunch of code because then you don't have to worry about the deployment and the maintenance and all that. I actually did have a question based on that, though. I was wondering, Julia, so let's say I want to make some updates. I want to make some changes to my API. What's the kind of best way to think about managing that so I keep my APIs and my Power Apps in sync?
Yeah, great question, and that's definitely a lot of developers do care about. And this is where we think Azure API management comes handy in place, because you cannot just have your CI/CD pipeline set up to easily deploy your updated changes to Azure API management, but you can also, from within Azure API management, update the custom connector you before exposed to it. You can easily just also update it from here. We are also working on a more integrated way. So for example, you don't have to manually click and select and update the custom connector. But in the future, we are looking at having an entire CI/CD pipeline, not just from your .NET API to Azure API management, but also to the Power Platform itself as well.
That's great. OK, we had a great question came in. The benefit of a Power App over building a site yourself. And I kind of want to build on top of that, or what are the times where you say, OK, this is not the right time for a Power App, and it's time for me to do a custom application?
Very good question. So Power Apps is definitely a tool for internal applications because it is part of your tenant, it is part of your, for all of the Office 365 users. So if you look at a high performant application, then I would typically go back and choose native app development. If we are thinking about, okay, some of our users are interacting with them, we need a very quick and easy way to also integrate with all of the Office 365 products. And before I have to build up all of these things myself, I think that's a good way to integrate and use the Microsoft Power Platform.
It's all about that use case that you were talking before. There are use cases for building your app on full stack, or sometimes using Power Apps to build that front end and get that like quick check of how your API looks and like how having something. And you can use both, right?
Yeah. And actually, that's part of the question. We had a question come in asking about this, whether whether you're going to hit cases where you have to do a full rewrite, like you're going to hit a limit and then you're going to have to do a rewrite. Is there something where, like, can you ease my mind about that, where I'm not going to have to worry about rewriting my code if I hit a limit?
I think I think talking about limits, and we talked about, or we touched about performance in general. It depends on how many API calls you're making. If it's like within a minute, is it within an hour? So it definitely does depend on your use case. And if we are thinking about internal applications, we already have the architecture in place. We just need something, some kind of front end to configure a new upcoming requirement for a subset of people or a subset of groups. That's, I think, definitely one of the use cases where we can see the Microsoft Power Platform.
All right, and we have lots of questions coming in.
We got one more good one here about versioning. So if I make a mistake, can I kind of roll back to a previous version?
So we have the Microsoft Power Platform CLI that does help with application lifecycle, with custom connector lifecycles. So if you think about versioning and what to do, that's what you can do here. We also always recommend, when we talked about the different environments within the Power Platform, it's always advisable to set up different environments where, for example, for the dev test environments, just a subset of peoples before we want to roll it out to a production environment, can test it first, they can develop it first, and then whenever we feel comfortable, we can push it to our production environment within the Power Platform and make it accessible to a much broader subset of people.
Awesome. Thanks, Julia, so much for being here and sharing us all of this knowledge of building front-end apps with Power Apps. And now we have another exciting talk with Aisha and John Miller that are going to talk about how to build a Teams bot with .NET and the Teams Toolkit.
Awesome.
Hi, everyone. So exciting to be here. Thank you, Maria and John. Hi, everyone. Thanks for joining our session. My name is Aisha Bush. I'm a cloud advocate at Microsoft. And in this session, my colleague John is joining me as well. Hi, John.
Hi, Aisha. Hi, everyone. My name is John Miller. I'm a program manager, and I'm working on the Teams Toolkit right now.
Awesome. So we have a full pack agenda to introduce you how to build a Teams bot using .NET and Teams Toolkit. Before we jump into the exciting live coding demo, we want to also walk you through what and why. So we prepared some overview of Microsoft Teams app, and then we want to walk you through the capabilities you can build for Microsoft Teams platform. And we have a live demo to show you how to build a Teams bot using Teams Toolkit for Visual Studio and .NET. And finally, we will share some resources for you to have some tutorials to learn self-paced and understand Teams Toolkit for Visual Studio a little bit more. So, John, why Teams apps in general?
Thanks, Aisha. Yeah, so getting started, a couple ways we could answer that question. I think the first way to think about that is, what type of information do you want to bring into Teams? What tools, what processes, and that helps you start to think about, like, okay, I'm working in Teams. This is where people are already communicating. This is where we're learning, we're working. So you can start to customize how users and how people in your business communicate and collaborate. And then if you think about it, the next way is how we might answer that is with social interactions. And that's really about connecting with your team, connecting with others. It could even be connecting with customers, so people external to your business. And that'd be a great way for you to provide services and share information in Teams channels or in chats. And then we can also think about how we bring or how we automate like repetitive workflows inside of Teams, or how we might reserve common resources like a conference room or something right from inside of Teams, or what other common business processes you might already have, and you can kind of bring that into the flow of work since you're already inside of Teams. Or you might have an existing business app that you've built, and you can extend that in new ways using Teams and surface that inside of Teams as an app. And that could help you avoid context switching. It could also help you grow the user base of that app inside of Teams, since that might be where a lot of your business is already happening. So looking at it a little bit more, like what are Teams apps? And Teams apps, they extend the capabilities of the Teams platform. And I'll show, in a second, I'll show a little bit more about what those capabilities are. Those apps can be personal or they can be shared. So personal means like I could customize an experience for the user that is using that app, unique to them. So it might be to show information specific to that identity and that person. It might be a dashboard, or maybe I want to send a notification just to that person and have them interact with that inside of Teams. Or it could be something you share. So when I start thinking about that, it's like I'm in a channel, I'm in a team, and it's where I'm talking, it's where I'm communicating. And so I can put an app and customize that experience as well. And there's different ways to do that. And getting a little more practical, Teams apps they're web-based. So they're web-based experiences. And I know it can be challenging when you hear the word app, like what does that mean? So I'm going to dive into that just a little bit, but Teams apps are web-based and they're hosted endpoints. So it gives you some flexibility of exactly how you want to create those experiences and where they live in the cloud or some other place.
Building Windows applications using WinUI 3
we start thinking about
.NET.
capabilities.
Now, actually, we're also going to be
really the word
looking at
that we use for how you extend
for those who
the
don't
Teams
know,
platform. So
WinUI 3,
where does this experience surface
now ships
in the
as
Teams
part
client?
of the Windows App SDK.
There's lots of ways to do this. So I put a little graphic here to give you an idea. And so we can take a look at tabs is really a way for you to bring a UI experience inside of Teams. So that's a primary way you can provide like a website or a web app or something that you want to put inside of Teams, like a dashboard or some other business process you might already have. That could be embedded inside of a tab. And then bots really give you a couple different ways to do things. So you could think of a bot as a conversational experience.
So we're going to be covering
if
both
you want to do something like Q&A or an IT help
Let's just jump
bot
into
or
it.
something
What
like that,
is
where you
the
have
Windows App
kind of
SDK?
questions
Well,
and answers
according to
back and
Microsoft,
forth.
it is
Those
a
are
set of
experiences you
new
can
developer
build. We also use bots to
components
extend
tools that
areas of the
represent the next
compose
evolution
surface.
in
So
Windows
when
app
you're inside of
development
Teams and you're typing a chat message,
It also
you can
provides a
extend
unified
that
set
with
of
what we call
APIs
message
and tools
extensions.
that
You
can
can
be
add
used in a
a
consistent
customized
way by
experience there.
any desktop app
And
on Windows
if you
11 and
have some
download
way
it
that
to
you need
Windows
to
10.
collect user input,
So
maybe in a
essentially, this
dialogue or
means that
modal type
Microsoft
of
is looking at
experience,
using the
those are
Windows
task
App
modules.
SDK as
You
the
can
delivery
start to see
vehicle
there's like
for
lots of different
new
ways to
developer
extend the platform,
APIs and
a little bit
features
of a learning curve
that
on this
will be
stuff
coming
and
to the
figuring out,
platform.
where exactly do I want to go? What
So
capability
it doesn't
might I
matter
want to
whether you're a
extend?
Windows Form,
But it really
WPF,
starts
or
to think
Windows
about,
UI
well,
developer.
where do I want to surface
You
that?
can take advantage of the WinApp
What's the right
SDK in order
user
to
experience
access
I'm
these
trying to provide
up
here?
and coming
So there's different ways to do
APIs
that. And
and
then as you
tools,
want to access
etc.
data and access
It doesn't
more about
supersede the Windows
user in the
SDK, that
context
still
of
ships
Teams,
with
you
the
start
core
to use
platform.
Microsoft Graph to do that. So
But
you're inside
unlike the
Teams,
Windows SDK,
users
which
are already
is
logged in. There's some things you can learn about them that way. There's files and things you can access through the Microsoft Graph. So I have a little bit of a developer background, so I'm still asking myself, if I'm listening to this as a .NET developer, like, okay, so what exactly is a Teams app though? Like, what does it mean? So I put this here. What is a Teams app? It is these three things. It's a JSON file, and it's two icons that are required to be able to display your app inside of the Teams client. The JSON file describes a little bit about your app. So you can see here, I have a little snippet that I've included of an example. It starts to describe what your company is, like who's the developer of this app. You get an ID for your app, so a way to identify it. And then you start to describe a description and things. And this is information that shows up in the Teams client when users try to add your app or install your app, whether that's within your company or externally. And then if we go a little further down into the manifest, you can start to see there's a little bit more specifics to this schema about how you define the capabilities that your app is extending. So for example, I mentioned tabs. That's a way to have some UI, which is a web, it's a hosted endpoint. It's a website. So here, the syntax for that is static tabs. That's what that is. And it starts to define, okay, it has a scope. It's a personal. So this is a personal, UI experience that's going to show up inside of the Teams client. And that's what this starts to define. You can see here, it shows you like an example of what the endpoint might be. And then we have another example with a bot. So you can see the bot has an ID. the Teams platform uses bot framework for these bots. So there'd be a bot framework, a bot ID for this. And then it defines, again, where that bot is going to surface. Where am I'm showing it a team here. It's available to install as a team or into a team. It's available to install as a personal experience and into a group chat. And of course, you could customize what that means within your app. So when you're ready, there's a couple options of what you want to do with your app next. You can publish it to the Teams store. So if you have a web service or some type of experience that you want to share with everyone else who's on Teams, that's what the Teams store makes available to you. So you can publish it, and then others could find it and install it. Or if it's maybe an internal business process or business app or something like that specific to your organization, then you can install it to just your tenant, which is just your Teams organization. And that could go through your IT admin process. And then if you are just developing, or you have just a very maybe specific use case where you want to share it with, just a team or something like that, you could install it that way and just share it with your team. Maybe you have a small group, or it's not something you're quite ready to share with your organization. And I put this here to show you a little example. There's already a lot of great apps available in the Teams store. So if you're not familiar, maybe you're like, oh, what? I didn't know Teams had apps. You could go now into your Teams client and at least take a look and see what apps are already available and how others are extending Teams with the platform. There's maybe some apps you've already recognized for other experiences that you use that are also now available inside of Teams, and then they've customized like what that experience is and really leveraged the platform in the ways that I talked about before. So what I was hoping is, Aisha, maybe you could show everyone watching how we can build these types of experiences now that I've talked for long enough. So maybe you want to jump in and show them.
Okay, so let me share my screen and take you over here. Okay, so first things first, before we jump into building a bot, I just want to share with you what you need to get started with developing apps for Microsoft Teams platform in Visual Studio. While you're installing Visual Studio, you will need ASP.NET and web development. And underneath, you have to make sure that you check Microsoft Teams development tools. So all the goodies about developing apps for Microsoft Teams is coming with this individual component. So make sure to use this when you're installing the packages so that you will get Teams app development capabilities in Visual Studio. Okay, so let's go to Visual Studio. As you can see, I already tested with the Teams apps a lot for today. Hopefully it will work fine. Let's create a new project and search for Teams, and we will have Microsoft Teams app. When I click next, you will have to give a name for your project. I'm just going to keep it as it, but you can just give any name you want. I will create this, and we will have a couple of options here. As John mentioned earlier, we have different types of apps you can build for Microsoft Teams platform. First off, you can build notification bots. It's actually a great scenario if you want to gather some information. Let's say whenever there's a new item created on DevOps, you can use APIs to get the information. Or if you want something regular, for example, every morning at 9 a.m. you want to gather all of your tasks, then you can use the timer trigger. So there are two options here. You can use HTTP trigger or timer trigger. You can use Azure Functions as a backend, or you can use ASP.NET Core Web API. It's totally up to you. And as I mentioned, HTTP trigger is there for using an API. Graph API is a great combination when it comes to building a Teams bot, so you can get some information from Microsoft 365, like if there's a new message in the chat or if there's a task in the planner, you can get a notification about that. Or time trigger, you can regularly get information from the API. We also have comment bot. It's a simple chat communication with a bot. So you can build a Q&A bot, which is a really great scenario for the comment bot. We actually have Q&A maker cognitive service, which works really great with the comment bot over here. You can get list of great questions and answers. Your bot can answer all of the questions you want your users to you want to provide to your users. And we have a tab. John also also mentioned about this. If you want to reuse your existing websites as a part of the Teams platform, or if you want to create a UI with a good-looking dashboard for your team, for example, to showcase all of the tasks across your team, you can use tabs to build a good-looking UI and the app experience. And finally, we have message extension, which can be implemented in the message. If you want to provide a action directly inside the message, then you can use message extension. Today, we will create a notification bot with HTTP trigger. I will just scaffold this, and then we will quickly walk through what is inside the code and then what we need to do to run the notification bot. When we first scaffold the bot, the first thing will come is the Get Started page, which gives you a really good quick start guidance, what you need to do. I think this is quite easy to follow for .NET developers. We will need to use ngrok tunneling for running the bot. And also we will have to prepare Teams app dependencies by using Teams Toolkit. This will prepare some of the dependencies for us in the background, and I will show you in a second what sort of dependencies we're handling with Teams Toolkit. This actually prevents you to go to Azure portal and creating app registrations and so on. So it handles all of this in the background for you. And then we will run the app by just debugging. Let's quickly jump to the controller, notification controller, and see what's going to happen if we trigger this notification API. If we trigger this, then this will go to notification controller. And over here, we have an adaptive card, and it's under the resources. We will use this adaptive card to showcase a good-looking card. You can create your own adaptive card by just going to adaptivecards.io. And here, as you can see, we have text blocks for title, app name, description. We just need to fill this in. So in the notification controller, whenever there's a trigger in the notification, we will just go to processing and read the adaptive card, and then fill in the adaptive card with the information we would like to provide to our user. In this case, it's new event occurred, Contoso app notification, and a notification URL, which is a button, so we can click go to adaptivecards.io, and we just send the adaptive card. That's all we do right now. Obviously, you can customize adaptive card, the entire process, and you can provide something more. Let's quickly go back to get started and see what we need to do to run our app. First off, we have ngrok. I'm using ngrok to create a tunneling in the background, and I will just, it's over here, copy paste, and I'm running this in the background. Secondly, as I mentioned earlier, we will have to prepare app dependencies. If you right click to your project, you will see there's Teams Toolkit. This option comes whenever you select Teams app tools when you're installing the related package. And in the Teams Toolkit, you have a bunch of options here you can go through. First off, you can open the manifest file John mentioned earlier, which carries all of the information about your Teams app. And you can provision, deploy, all sort of things about Teams apps. To run the app, to debug the app, we will have to prepare Teams app dependencies. When I click to it, it asks me a Microsoft 365 account. We are actually provisioning this bot in the Microsoft 365 account. If you don't have Microsoft 365 account, or if you have it, but maybe if you don't have the right permissions to test your Teams app, I highly recommend you to go ahead and create Microsoft 365 developer program account. It will generate you a free account where you will be the admin. You will have pre-sandbox. You can test everything out, and it will be useful for any other applications you're building in the M365 ecosystem. I already have a demo account I created in the developer program. I'm just going to use this one, and I will click continue. And this will start running my preparation. As you can see here, the app manifest is initiated and then it is created. We also have a bunch of other stuff running over here. The bot service provision starts over here, and Teams Toolkit automatically creates bot AD app. So it provisions bot registration as well. So all these steps are done by Teams Toolkit. And when we are done, you should, if you're interested in seeing these files, you can first off go to templates. App package has your resource, as John mentioned, the PNG files and the manifest file. And then we have Azure provisioning and Teams effects that carries all of our information about bot registration and AAD registration. And you can just check your information out from the templates. I think we are ready to run the app after the Teams app dependencies preparation. We just need to click on the debug, and when the project is ready, it will pop up the browser with Teams logged in, because I already provided my M365 account over here. So my Teams should pop up, and then it will provide me my bot. I will add the bot, and afterwards I will just test out the bot by just triggering the write notification API. Okay, the browser initiated, and hopefully my Teams is loading. Okay, as you can see, I'm already logged in, so I don't need to worry about logging in again. And our bot is ready to test. I'll just click add. And now this should bring me the chat with me and the bot for the discussion. Of course, to get anything in the chat, I will need to trigger the notification API first. So while this is adding, yeah, okay, it's already here. I just need to trigger this in the PowerShell, and I need to get a adaptive card, as I showed you earlier. Okay, let me bring PowerShell and run this script. This will trigger the notification, and then bot will send me an adaptive card. Okay, so it works. As you can see here, as we discussed earlier, I have the title, app name, description, and I have the URL, which directs me to adaptivecards.io. Of course, you can design this experience however you like, and you can also cover more questions, not just one API. You can change the API. You can use weather APIs, DevOps APIs, any API you like to create notification experience. This is the basic of it. And if you're interested, we have loads of resources to share at the end of this presentation. I think that's it about the demo. John, do you have anything to add?
Yeah, thanks, Aicha. That's really great. It's easy to see in about 10 minutes, you're able to create a Teams app and bring a notification in, and then you can customize from there, to whatever you need in your business. So let me go ahead and jump back to my my screen here, and I will just follow up with a little more information about Teams Toolkit. So, why Teams Toolkit? With Teams Toolkit, we really focused on how to simplify getting started. So earlier I showed that graphic where it shows like how you can extend Teams platform, and I recognize it can be a little bit overwhelming, and there's lots of terminology maybe you're not familiar with. So with Teams Toolkit, you can jump into the templates we provided. So I just showed notification bot, command bot. These are scenarios that we hear from other users that are building Teams apps that are common ways that they get started. And then of course, those are flexible. So while, it might start as a notification, then you could extend that to also be a command scenario or a full conversational experience as well. It's just a good way to get started with, some minimal code. So maybe it's a little less overwhelming. It also helps you save time with all the tedious configuration that would otherwise need to be done. So there's things like having to go in and set up that manifest and define that. Well, when you use our templates, we scaffold all that out for you. And then we have some commands in there that I just showed in the menu of your project menu, and that helps you register that app with the Teams developer portal. And if you want to do things like SSO, there's menu options there to help you add that code and create the Azure AD registrations and link those things together. It helps you configure bot framework and link that to your app. So there's lots of configuration that would otherwise need to be done that you can do in one click and just get right into code and get more familiar with just building your application before you need to go and maybe customize those things further. And then we also optionally provide some smart defaults to help you take that to Azure. And the way we do that is in that templates folder that I just showed. And that's where we put some bicep files. So this is our kind of opinion on how to host these solutions. So we have these templates, these project templates, and then we provide infrastructure as a code as our approach to, how do you bring that to a hosted environment like Azure. So you can use our tooling to do that. And that's where the provision menu comes in and the deploy option as well. And then you could go and customize what those resources are by editing those bicep files if you want, or put it into a CI/CD experience if you already have that going. And of course, use .NET. So if you're a .NET developer, then this is a great way for you to get started. You can use Visual Studio. You can stick with technologies you're probably already familiar with, and you can use C#, and you can go ahead and start building for teams. And another way that we help .NET developers, let me advance my slide here, is with the Teams FX.NET SDK. So we didn't get into this in the demo for the bot thing, but we also have a NuGet package available. It's Teams FX, which stands for Teams Framework, which is the open source project available on GitHub. And that includes the Teams Toolkit extensions, which is in Visual Studio and Visual Studio Code, and includes the .NET SDK and the TypeScript SDK. So that's where Teams FX comes from. And in that package, we have these types for the bot scenarios like I just showed. So we have some classes like notification bot, command bot that help encapsulate some of these scenarios to make it a little simpler. So maybe you don't have to dive into learning all of bot framework right away. That's a big framework, and maybe you don't need a full conversational experience. You have a scenario like I just want to bring notification in and customize what that looks like with an adaptive card. Then we help you build that easily. It also helps you simplify the identity access. So adding SSO could otherwise be tricky. And so we have some helpers to encapsulate that with Teams user credential and be able to get the token exchange easily through Teams, so you can create SSO in your apps and get a little more context about the identity of who's using your app if you want to do that. And we also help the lives of Blazor developers. So the tab template that we have is a Blazor server project, and the Teams FX.NET SDK includes some types that are basically Blazor interop classes to help you interact with the Teams.js library. So the Teams.js library is how you interact with the client. And to make that simpler for Blazor developers, we've already wrapped a lot of that and provided some helpers to make that a little easier for Blazor. And like I said, that's available on NuGet already. And if you want to get started, like Aisha mentioned, I think a great way to do that is to get the M365 developer program. So you can sign up for this for free. And that dialog that shows up in Teams Toolkit includes a link there to help you get started if you forget. And then that gives you a way to create a free kind of sandbox tenant where you could deploy these apps with full permissions. You are the admin of it. And then you won't maybe interrupt any other work if you're deploying some test apps and things like that. Gives you kind of a sandbox to play in. So that's a great way to get started. And here's some more resources for you to get started. We have lots of documentation. And like I said, the Teams FX project is available on GitHub, so you can go there, and all of these resources will be there as well. And then that's a great place to submit feedback or issues that you run into. And we have dedicated samples that are specific to our Teams FX project templates. Those are available on GitHub as well. And we also have some tutorials coming out. Like there's a great stock update notification that someone on Aisha's team has helped create. So that'd be a good thing to check out too if you want to see like what else can I build and maybe how to do it, and you could just run that app in your tenant as well. So I think that's all I have for you, Aisha. Is there anything else?
Yeah. I think that's all we have. The only thing is if you ever try Teams Toolkit for Visual Studio and want to share your feedback, your experience with us, we have a feedback form. It's an anonymous form. You can just go ahead and fill out the form. Any sort of feedback is appreciated. It will definitely help us improve the product itself. And I think that's all from our session today. Back to John and Mariah.
Awesome. That was amazing. It's amazing to see what people are building in a half-hour session, you know. I had a question about how you would integrate, like, is if you are expanding or working across more than one person working on a project, how do you deal with things like teams? And you know, are there authentication issues and different things that you need to manage for a group project?
Yeah, it's a great question. So we do have support for that, and we have documentation specifically for how you can collaborate on a project. So I would encourage anyone jumping into that, go and check out the documentation. But you know, we recommend each developer would have their own Microsoft 365 developer program account, so that way you can deploy to your kind of sandbox environment. It could be the same app, but when you're pressing F5 or start debugging from Visual Studio, it's launching into your own kind of environment. And if you need to share environments, then we have some documentation on how you can add permissions for different users to collaborate on the same thing in the same tenant.
And we have another question here from Jeff, our friend Jeff. What does the development and test environment look like for building Teams apps? Can I host on my own servers for testing?
Yeah, thanks, Jeff. Yeah, you can. Like I said, these are hosted in experiences. So your manifest needs to point to the right place on where that can be accessible. So for example, when you're developing, that manifest basically has all local host endpoints when you're pressing F5 from Visual Studio. So you're hosting locally. And then we actually how do I phrase this? We take the manifest, we make a template out of it, so that way you could have different environments. So the URL strings for these things could be templated parameter values. So if you have different environments, then those things can basically be swapped out. So you can create different things. By default in Visual Studio, I think we have two. We have one we call Dev, and then one we call Azure by default. So that's kind of how we've used the toolkit to be able to create different environments, I'll say, which are basically just different groups of endpoints.
Awesome. Okay, you mentioned the FX project and community building things, and so I'm wondering if you have like just a favorite thing that you've seen, someone in the community build or a sample or whatever.
And it doesn't count David Pine's joke bot.
Nope.
I think I have one.
Yeah, go ahead, Aisha.
Yeah, I think there are lots of scenarios built with the Teams Toolkit. I definitely recommend you to go ahead and check out the PnP community. Lots of people are using Teams Toolkit to build. Stockbot is a really great example for the notification. We also have one productivity hub which we build using Teams Toolkit. It shows you all of the calendar file and to-do task items in one single UI. I think it's a really easy practice if you just don't want to jump into different apps at Microsoft. You can just have your own me experience to go through what's happening today. I think that's my favorite when it comes to Teams apps. But there are lots of apps going on in the community. You can go check out the repositories that John shared earlier. We have so many samples you can go through.
Awesome. Thank you so much, Aisha and John, for sharing all about building Teams bots with us. We are wrapping up our Power Platform and Teams section of the day, and we're moving on to Windows development. So who's next?
Yeah, next up we've got Nick Randolph. He's going to be sharing with us building apps with WinUI, and we've got Windows Dev for the next segment of the day. So take it away, Nick.
Hey everyone, hope you've all been having a great .NET Conf. My name's Nick Randolph, and today we're going to be looking at building Windows applications using WinUI 3 and .NET. Now, actually, we're also going to be looking at the Windows App SDK. For those who don't know, WinUI 3, or just WinUI, now ships as part of the Windows App SDK. So we're going to be covering both in this session. Let's just jump into it. What is the Windows App SDK? Well, according to Microsoft, it is a set of new developer components and tools that represents the next evolution in Windows app development platform. It also provides a unified set of APIs and tools that can be used in a consistent way by any desktop app on Windows 11 and down level to Windows 10. So essentially, this means that Microsoft is looking at using the Windows App SDK as the delivery vehicle for new developer APIs and features that will be coming to the platform. So it doesn't matter whether you're a Windows Form, WPF, or Windows UI developer. You can take advantage of the WinApp SDK in order to access these up-and-coming APIs and tools, and etc. It doesn't supersede the Windows SDK. That still ships with the core platform. But unlike the Windows SDK, which is versioned with the platform, the Windows App SDK is iterated separately. And you can, as a developer, can choose when and if you're going to update to the latest version of the Windows App SDK. What's included in the Windows App SDK? Okay, well, these are the components that currently ship as part or the components that make up the Windows App SDK. So the first one being deployment options is actually come from the feedback from the UWP kind of experiment, if you call it that, where developers, a lot of developers liked the packaging format, but there were obviously some limitations and developers wanted more control in some scenarios. And so for the Windows App SDK, you can either use the packaged or unpackaged options in terms of deploying your application. WinUI 3, or just WinUI, ships with the Windows App SDK, and essentially this is all of those visual components that made up for UWP. Those have been detached from the Windows platform and made available as part of the Windows App SDK. Again, those are going to be versioned independently from the core OS, meaning your application can take a dependency on it without having to be tied into the versioning alongside the platform. The Windows App SDK also provides APIs around app lifecycle. So, for example, whether you want to be a single instance or multi-instance app and be able to reference the running instances of your application. It also provides APIs around power management and windowing. So you can create new windows, you can detect when power management changes on your device. And also there's support for push notifications and other app notifications within the SDK. Version 1.2 of the SDKs are soon to be released, and this includes a number of new features and a lot of sort of bug fixes and updates as well. One of the hotly anticipated features that is coming in as part of 1.2 is the ability for third-party developers to create their own widgets for Windows. Developers using .NET can also trim their application, so significantly reducing the size of the deployed application. Applications can also make better use of HDR displays, accessing the information using the display information class. WinUI 3 has been updated to include the media player element and the media transport controls. It's also been updated with the latest controls, styles, and behaviors from WinUI 2. So at this point, WinUI 2X has basically gone into sort of more like a maintenance kind of mode, and all new development will carry out on WinUI 3. So new controls and styles, etc., will come to WinUI 3. With only bug fixes and maintenance stuff being done on WinUI 2. And so essentially, this means that newer apps should take a dependency on the Windows App SDK in order to leverage the benefits of WinUI 3. There's also an app notification builder class that makes sending notifications easier rather than having to use the XML payload. And title bar customization is now available for Windows 10 based applications as well. One big note to note is that despite their original estimate for releasing the 1.2 SDK on November the 1st, it's actually been pushed back to November the 15th, just due to a number of last-minute bug fixes that had to be made. So let's just jump in and have a look at some of these new features. The first one we're going to take a look at is widgets. So here we've got a sample widget that's actually part of the samples that are available for the Windows App SDK. You'll see here that there are two projects. The first one is the sample widget provider app is essentially the implementation of our widget. And so right now widgets do need, the provider for widgets does need to be written in native code. And obviously there is a long-term view that the managed version will be made available. But in the 1.2 timeframe, the code needs to be written in native code. The second project is a packaging project, and so this is where we can actually configure the widgets for our application. So if we take a look at the package app manifest, take a look at the code, When we scroll down here, we can see that there's a couple of additional things here being registered. So we've got a Windows Conf server. So essentially, this is the registration of the implementation library for our widgets. And then down here, we've actually got a registration of the widgets themselves. So here we can see that there's a counting widget and a weather widget. And you can see here that there's a reference back up to this Conf server as the implementation for those widgets. Now, the implementation of the widgets, if we just drop into the code, we can see that we've actually got, essentially there's a button on the screen that when you click it, it increments the counter. So essentially, this is the logic that actually increments the counter. Now, in terms of the actual way that the widget is laid out, that's defined by these JSON files. If we open these, you'll see that it doesn't really make a huge amount of sense other than we can tell that it's an adaptive card with a bunch of text renders. So let me just grab this code, and what we're going to do is we're going to take a look at adaptivecards.io. So this is actually installed, it's a website, so adaptivecards.io, you go to the website, and this has been installed as a PWA, so it basically looks and behaves like an application, but it essentially is just a website. We're going to create a blank card, and from the host app type here, we've selected widget board, and this basically just controls the sort of the overall look and behavior of it. So if you're doing Teams development, you can actually switch to using Teams for the adaptive card style. We're actually going to drop our card payload into the screen down here. So this is the code that came from Visual Studio, and we can see that our card has been updated to look similar to what we'd expect it to look on a widget board. We can then go ahead and modify our text in here. So basically it says you've clicked the button X number of times. Okay, so hang on, there's a substitution here for count. So in our sample data editor, let's go ahead and actually include a count property in here. And so now we can actually see that it's rendering with one, you click the button one time. Now I'm just going to add a little bit more text to here. So we're going to say for .NET Conf. And you notice here that it's now going off the screen, so we now need that to wrap. So now we can update our code. We can grab a copy of this and go back to Visual Studio where we can just drop our replacement code in here. Now we can go ahead and actually deploy the packaging app. So this will build our provider app and then deploy it to the local environment. This will take a second or two. And once this is done, we can actually go to the widget board and we can go and include our counting widget, so we can actually see how it's going to behave on our widget board. So just take a second or two to build it. And build and deployed. Now we can go to our widget board and go to the plus at the top here. And from our widget settings, we can then find the count widget, select on that, and that's going to go ahead and add it to our widget board. So you can see the widget pinned. And what will happen now is our actual the provider app will actually be started up. And so if we go back to our widget board, we'll actually see that it renders correctly now. Give it a second or two to warm up. And there it's displaying, and it's going to go ahead and display in a second. There we go. So now we can hit the increment button, and it's going to go ahead and increment that counter for us. Okay. Now it'd be really good to be able to attach to debugger, and for that we can go to our debug menu, attach to process. And so this is going to return a list of all of the running processes. I'm going to filter that down to just the ones that include the word widget. It'll take a second or two. Select the sample widget provider and click attach. And I'm just going to check that we actually have a breakpoint set. So let's go to our counting widget. And yes, we've got a breakpoint set. So if I go to our widget now, and I click on our increment button, that breakpoint will be hit, and we can then step through our code to actually debug the widget. Okay, next up, we're actually going to switch across, and we're going to take a look at the WinUI Gallery app. Essentially, this is a demo app or an app that's available in the store. If you look up WinUI 3 Gallery, you can download it, and basically it's a showcase of all of the controls that are available for you as a developer as part of the Windows App SDK for WinUI 3. So let's go and open that. And you'll see here it's quite a nice styled app, and it behaves well on Windows. So as I resize, you'll see that things like the navigation view on the left-hand side resizes down to a list of icons. And then as I scroll back out again, it'll actually expand out again. I can search this for components that I might be interested in. So if I go and search for Windows on here, it'll give me the APIs for creating multiple windows. And so from here, I can take a look at the source code. So I expand that out, and you can see here that the code for creating a window is actually relatively straightforward. I can click on the button, and it'll actually launch a new instance of the new window. And so I can do that multiple times. The other thing that's really interesting here is the title bar support. So you'll notice at the top here, the title goes all the way into the top title bar. And the application looks as if it extends all the way into the title bar, so there's no defined title bar there. If I switch back to use this button to set the system title bar, you can see what the title bar would normally look like. So getting rid of that or switching back to the custom title bar just gives it a little bit more fit and finish to the application. And then you can override and set things like the background or the foreground colors of these buttons in the top corner as well. And again, the source code for this is included in this app, so it's relatively straightforward. You can define UI elements that are going to appear in that title bar, and then define that you want to specify a custom title bar. Some of the other things that are worth noting, if we take a look at some of the style elements in here, we can take a look at some of the things like the mica and acrylic backgrounds. So if I actually create a window with mica, you can actually see that it's got a different style background. I can switch between mica and acrylic, and you can see that it's got different bleed behaviors based on the different type of backdrop behaviors. So this is the Windows UI 3 Gallery style application. I'd highly recommend you take a look. It's got the ability to generate XAML code that you can just drop into your application to take advantage of those features. So far, we've really just focused on the sort of the fluent design that WinUI brings with it. Now, one of the really interesting things about WinUI and XAML is the ability to essentially restyle it. And so one of the core capabilities of WinUI and XAML is that it has this concept of lookless controls. And by that I mean controls that have got a control template, or just a template, that can be overridden to adjust the look and feel of a control without affecting the behavior of the control. So in other words, the look of the control isn't tied directly to the actual underlying behavior. And this is one of the things that's actually quite unique to this platform. And so whilst WinUI ships with the fluent design language, you can actually restyle all the controls to take advantage of that. And so the Uno team have actually got a set of style libraries that are available to support a Cupertino look and feel and a material look and feel. But since an Uno app is essentially a WinUI application that's been made available on multiple platforms, any of the sort of the investments that the Uno team have put into things like these style libraries, you as a Windows UI developer can take advantage of. And one of those investments has actually been in a Figma toolkit. And so we're going to take a quick look at the Figma material toolkit that's available for the Uno platform, and how we can then apply that and use it for a WinUI based application. So we'll switch across and have a look at the Uno platform material toolkit. For those people who are just getting started with this, there's a really good getting started guide as you get into it, and this will walk you through, configuring the styles, configuring the typography, the look and behavior that you want to get out of the toolkit. So it's worth walking through the style guide at the beginning, but then you can jump through the various components. So for example, if you want to adjust the colors and the typography and the elevations, etc., you can do that by the styles board. There are various components that are available here, and the nice thing here is that you can see the components and you can see all the variants of the components and how they would look within the application that you're designing. There's a number of other preset components, so lists and cards and swipes and stuff like that, that you can use within your application. And finally, there's an example application that shows you how easily you can use Figma to build out the look and feel of your application. Now we're going to come back to this in a little bit and show how we can take these designs and use the plugin that the Uno team have built to actually extract the design into a set of XAML files that can be used within your application. The next thing we're going to look at is the Uno extensions. And again, this has also been developed by the Uno platform, and it's pretty close to my heart since I've been fairly invested in helping the team with these Uno extensions. They're based on what Microsoft has done with the Microsoft extensions. And so it's designed to provide sort of a simple mechanism to bootstrap a WinUI or Uno-based application. So it provides fundamental infrastructure such as a DI container, logging, configuration, settings, and we've also added in a couple of high-level abstractions such as navigation and reactive extensions that essentially allow for a more MVU style development, or in our case MVUX, since we're still making use of XAML and data binding. So we're actually going to go ahead and create a WinUI-based application using the Uno extensions template, and then we're going to drop in the designs from our Figma file and see how that all plugs together. So we'll go ahead and use the multi-platform app, Uno Extensions app template. So this is a .NET New template that's available from NuGet. You can install those, and now once you install them as a .NET New template, they also now surface up within Visual Studio. So we can go ahead and click Next on this and go ahead and create our Uno-based application. We'll click Next again, and what we're going to do here is configure the target platforms that we want to make available. Now, for the purpose of this, we're actually going to remove all of them except WinUI, and we'll leave the testing and the reactive extensions included there as well. So go ahead and create that. And we'll reload our application. And you'll notice here that this has been set up as a more fully fledged application. So it's not just a single app that's basically just a hello world. It's got a number of pages that make up our views. So it's got a main page, second page, and it allows obviously some navigation between those. There's a separate project that includes view models. And as you'd imagine, that there are going to be some testing projects that jumpstart your ability to test both unit tests, but also UI-based tests, so you can actually run those as well. We're going to go ahead and run up this application, and you'll notice that it's a very simple application, but does provide some basic constructs around navigation between pages. Let's actually make sure that we're starting our Windows app. Set that as a startup project, deploy that. But one of the things that you will notice when the application runs and launches is that the style has been changed, and the style by default for the Uno extension is the material style. So you'll notice that the buttons now have a sort of a rounded style that's typical of the material design language. There we go, we can enter our name, and that gets then passed through to the second page. You'll also notice on the second page we now have this navigation bar that allows us to navigate back to the previous page. And so that's all using this sort of higher level navigation abstraction that's part of the Uno extensions. So what we're going to do is actually stop, we're going to open our main page, and this is the XAML that kind of makes up our page at the moment. So we've got a navigation bar followed by the text box and the button on the screen. We're going to switch across to Figma, and we're actually going to grab the search products page, and we're going to launch the Uno platform plugin. We're going to switch to the XAML, hit the refresh button, we can select copy all of our XAML from here, go back to our application, drop that into here, scroll up, and there's a minor build error here that I just need to add a namespace, and then we should be good to run. Now, when our application now runs, the XAML that we copied from Figma will now update the UI, and it should look similar to what we had in the Figma file. Now, obviously, we're not loading any data, but essentially the overall look of our page has mirrored what's come from Figma. And so you can imagine that this is going to streamline the process of design through to development as we start to build out our application. So the next thing we're going to look at is Template Studio. And this is one of the things that has been shipped and is supported for WinUI developers. And it's going to make it, again, easy for you to jumpstart your application using the Template Studio. So let's just switch back to our design, and we're going to go and use the Template Studio for WinUI. So this is an extension that does need to be downloaded and installed for Visual Studio. So we'll go ahead and create next. And what this then does is walk you through essentially a wizard for creating your application. So you can pick the project type. So we're going to go with a navigation page. We'll use the Windows Toolkit. We're going to add in a couple of extra pages. So we'll go, we'll grab a blank page, we'll grab a web view, and we're going to add in a settings page. The next thing we're going to do is come down here. We're actually going to tick the self-contained option. So basically what this means is that the Windows App SDK runtime components are actually going to be shipped alongside our application. This will mean our application deployment size is actually package's size is going to be bigger, but it does mean that we can then version our application independently of the underlying Windows App SDK. And lastly, we'll include our test project. We'll go ahead and create that. There we go, and we'll go ahead and actually run our application. And now with our application running, what we're actually going to do is we're going to take a look at some of these the tools that are available in Visual Studio to support our development. So let's just actually turn on the adorners, and we'll go ahead and select an element. So we hit on the main, and you'll notice that behind the scenes, the live visual tree has been updated to select the component that we've actually clicked on here. We can also go to the live property explorer, and we can see what the current properties are for that particular element. But what we're actually going to do is just drop into our main page. So let me go back to our Solution Explorer, come down here to our main page. And what we're going to do is actually put some content into here. So we're going to do text block, text equals main content. And I'll hit save, and we'll go back to our app, and we've got hot reload so we can actually view the element that's being displayed there. Now, we can't do everything. So for example, if I was going to actually add in a button here, and I wanted to say content equals click me, like that. And obviously this is going to create an event handler for it. Now we're going to get into the situation where hot reload won't work, and we will actually need to restart our application in order for this click handler to be wired up correctly. So the last thing we're going to really look at is just some of the performance characteristics of WinUI and how you can take advantage of some of the tooling to actually analyze your WinUI-based application. Now, the first one is if we run our application, you'll notice that the diagnostic tool panel basically appears, and we can actually see some runtime metrics for our application. So you can see things like memory usage, processor usage, etc. But if you wanted to get more information or more detailed information, you can actually use a thing called .NET Trace. And so what we can do from a command line is actually use .NET Trace, and we can start it collecting on a particular port. Now, in order for our application to take advantage of that, or to generate information that's going to be captured here, we actually need to make a slight modification to the way our application is deployed. And so for that, we'll go across to under Properties, we'll look at the launch settings, and under the unpackaged option, we're going to drop in some environmental variables. From the drop down here, we'll select unpackaged, and we'll then run without the debugger. And you'll notice as soon as this starts running, that our .NET trace that we had started running is now capturing information. And when we close our application, it'll actually complete that trace. And if I do a dir there, you'll see the net trace file. So this net trace file can be opened in Visual Studio, but there's another application called SpeedScope that's also pretty good at viewing trace-based information. In order to use that, though, we need to call .NET trace and actually convert the format type. Like that. And now we can come back to SpeedScope. We can browse for our SpeedScope file, we can open that, and now we can see a number of different views of our application and the way that it's performing. So we can use this to basically drill down and take a look at what's consuming time and what's taking time for the running of our application. The last thing we're going to look at is the ability to trace or to trim our .NET based application. And for that, we're going to come back to our application and we're going to apply trimming to it. So here, if we go to our project properties, and we're going to add in publish trimmed here, set that to true. And now if we build our application, what we should see here is that we're going to say there's going to be an error that is basically not yet supported. And this is because currently this application that I created with the Template Studio is actually referencing the version 1.1.3 of the Windows App SDK. So what we'll do is come down to NuGet packages, and we'll go ahead and update to the preview of version 1.2. Update there, accept that. Now when we go ahead and build our application, we'll actually see that there are a number of kind of warnings here. And so what's really important when you apply trimming, and I would recommend, particularly if you're looking at minimizing the size of your application, is to employ trimming. I would highly recommend looking through these warnings and make sure you test your application before you ship it. And that basically wraps up the session. Here's a bunch of more information that you can grab in terms of providing more information about Windows UI, the Windows App SDK. Of course, if you need to get hold of me, my name is Nick Randolph, nick@builtrome.com, or on Twitter @TheNickRandolph. Feel free to hit me up for some information about the Windows UI or the Windows App SDK. Thanks very much, everyone. Have a great .NET Conf.
Wow, that was great. So many cool things you can build with WinUI 3, and now I want to get started.
Yeah.
And I want someone to show me how.
Yeah.
And
I think our next guest will help us with that.
That's great. Now, what I would prefer is if it was like a friendly creature, like maybe a gazelle or a llama.
I think we will have you covered, John.
Oh, really?
But I have so many questions already. So let's go to Michael Hawker, and he's going to talk about how to build WinUI 3 apps with Windows Toolkit.
Great, thanks everyone, pleasure to be here. We're going to talk about accelerating your WinUI 3 app with the Windows Community Toolkit. I am Michael Hawker, also known as the XAML Llama, thus the hat. I'm a senior software engineer here at Microsoft, and I maintain and work on the Windows Community Toolkit, which is what we'll be talking a little bit more about later today. So just a quick overview of our session. We're going to be talking a little bit about what these community toolkits are and why they exist, giving you a bit of a crash course on why there's all these different Windows UX frameworks, how they came to be, and where we are today with that, and how to get started on the latest one. To do that, you might have heard of this thing called XAML. It's pretty common in Windows development today, and so we're going to give you a little bit of a brief overview about what that is and how that works, so you kind of have all the bases covered for getting started in your adventure in learning how to build a Windows app. And that's what we're going to be doing for the second half of this session, is diving into Visual Studio and using some Windows Community Toolkit components to get started building a beautiful app on Windows. So what are the community toolkits? These are a collection of different libraries that are for .NET-based technologies. They are all open source up on GitHub under the MIT license, and we're part of the .NET Foundation. It's really about creating this collaborative space for our community of developers, Microsoft MVPs, engineers working at the company on various different products and tools, like myself on the toolkit, as well as the engineers that are working on the teams building these platforms, such as .NET or WinUI itself. And so you can find out more about our GitHub org at aka.ms/toolkit. We have a variety of toolkits available. We have the .NET Community Toolkit, which is platform agnostic, so regardless of what .NET technology you might be using, I'd encourage you to look and see what's available there. There's a lot of different helpers, especially if you're doing very performance-critical scenarios. And if you're doing UI development, we have the MVVM Toolkit, which works across any different UX platform you might be using. And Sergio, who maintains the .NET Community Toolkit, is going to be giving a talk about that later, so I encourage you to check that out. If you've been following .NET Conf and hearing about this new MAUI platform as well, we have a MAUI Community Toolkit. They're giving a talk about that later as well, so be sure to check that out if you're interested in MAUI development. And then I work, as I said, on the Windows Community Toolkit, which is for UWP and WinUI 3 developers, which is what we're talking about today. And so we have a bunch of controls and helpers for that to help you get started on Windows development. And we've been doing a lot of our new work in this thing that we just released this year called Windows Community Toolkit Labs. So those are the components I'm going to be showing you today, the latest and greatest stuff that we're working on. And part of our goal here is to create components that work across this migration in the ecosystem from the current from UWP platform to WinUI 3 and this new world that's starting in that space, as well as looking at other spaces like Uno Platform brings the Windows XAML to other platforms and for things like WebAssembly, and they're going to be talking a little bit more about what they're doing with WebAssembly later here at UnoConf as well. So a few sessions to look at too. But the Community Toolkit's really empowered by our community, and so it's thanks to them that we're here and doing all this great stuff, and it's amazing to see what we can build together in the open. So I just really wanted to congratulate everyone and thank them for working with us. It's amazing to see what we can do and how we can empower each other to build great experiences. So with all that in mind, I wanted to jump back in time a little bit, way back into the 90s. Things kind of started on Windows UI development with this thing called MFC. It was for C++ developers and working with Win32. And soon, not quite so soon after, but eventually this thing called .NET and C# was introduced, and they brought WinForms along with it as this new way of creating UI applications. And then working off of that and thinking about how do we build large-scale applications and separate the logic of how we build the UI from the back end of how that application works, brought this notion of XAML with WPF, again for .NET based in the desktop. And at the time, each of these platforms is the latest, greatest way to build applications, but doesn't necessarily supersede the work that's been done before it. And so you still see apps being built with all these technologies as we move forward down this line. Then in the Windows 8 and kind of evolving in the Windows 10 timeframe, we got this thing called Universal Windows Platform, UWP, which you might hear about. And this brought latest touch device interactions and other permissions to users and part of the sandbox, but was also targeting both C++ and C# developers. So regardless of what programming language you wanted to use, you now had a framework that you could leverage on the platform. But as a developer, it was hard sometimes to create the experience you wanted with the sandbox restrictions. And so that's where WinUI 3 comes into play and kind of really brings things back together so that you have the power and access to all those Win32 platform APIs, whether you're a C++ or C# developer on top of these latest tools. And so that's what WinUI 3 is really all about. It's about having the latest and greatest Fluent controls and styles. Fluent is this design language of Windows, so that you'll see that on Windows 11. So when you're using WinUI 3, any component that you pull out for the platform is just going to feel like it belongs there and fits in with the rest of the operating system. And that gives you this native UI performance, whether you're using C++ or .NET. Of course, we're at .NET Conf, and so it supports the latest .NET versions and C# versions. The other interesting thing about WinUI 3 is that it's part of a NuGet package. So you can decide when you want to upgrade. It's actually part of the Windows App SDK. So you'll see these terms of Windows App SDK and WinUI 3 kind of usually thrown around together. And so they're part of this NuGet package. And so as an app developer, if there's an update, you're not quite ready to update, you're about to ship your app, you can wait and kind of do that later if you need to, because it's just a version that you update in your project to pull down the latest version. The other thing I wanted to call out is, I mentioned these multi-platform frameworks such as MAUI and UNO platform, and when they're targeting Windows platform, they actually use WinUI 3 underneath the hood to get that native look and feel. So that's kind of how these different technologies are kind of related to one another. The other thing I wanted to kind of touch on is, why is it WinUI 3, right? Why did kind of things start with version 3? And it didn't really start with version 3. We can kind of think of version 1 as the original operating system controls and kind of how the apps behaved. And so you'd build your app and it would release on a specific version of Windows. But if there was a new version of a control that you wanted to leverage, you kind of had to wait for your users to upgrade to that version before you as a developer could leverage that component, which was a little bit hard to kind of manage and time and make sure you were trying to take advantage of these latest and greatest features that we were releasing. And so that's where the WinUI 2 library came along. It was a set of the latest controls that were now agnostic to the operating system. So you as a developer could include this package, use the latest control, and then be able to run that on any machine without having to wait for your users to upgrade their operating system. And so the next kind of evolution of this is for WinUI 3, and this is really about combining both of those different pieces. So not only the controls, but all of the rendering aspects. So your app is going to run and look the same across whatever version of the operating system that you're using. And so we in the Windows Community Toolkit have been, in the past building components for UWP and the stack on the left, and now also want to take all those controls and build them for WinUI 3, since it's mostly compatible code-wise between these two frameworks, since it's the next evolution. And so that's what we've been kind of doing in this Windows Community Toolkit Labs, and what we're planning for the next version of the Windows Community Toolkit, so that all of our components are consistent and work the same across whichever framework you're using, whether that's an existing UWP developer, whether you're a new developer looking to start with WinUI 3, or exploring other technologies like UNO platform and bringing experiences to Android, iOS, or the web with WebAssembly. And so our goal here is that if you're a developer and using a component from the toolkit, regardless of which migration or what framework you might be trying to use or move a code base to, that the code from the toolkit that you're going to be using is exactly the same. And so that's our goal moving forward, and what we've been starting with our Windows Community Toolkit Labs. So how do we actually get started with development? So the first start kind of thing with Windows development to understand is this thing called XAML, which I mentioned before. And XAML stands for Extensible Application Markup Language. And it's a way that you can define your user interface in XML. If you're kind of familiar with web technologies, you can kind of think of it as a combination of both HTML and CSS. It both defines the layout and presentation of your application, as well as the style and the look and feel of those components within it. However, XAML developers will typically separate these concerns into separate files. So you generally have pages that are more content-driven and showing the structure and actual prose of your application, as well as resource dictionaries for the styles, which will define how things look and feel. And so you can kind of see this in this example here below. I have a text block with a text property. It says, of course, hello world. And then I'm referencing a style, which I've defined in this separate file, which is actually my global application. And so with this style, I can change things like the font size or the margin, and then use that anywhere I need to within my app. So that's one thing XAML lets us do. The real power from XAML comes from data binding, which is how we automatically update the UI when we change something with our code behind. So this really kind of reduces the need for manipulating our UI with code and trying to change the text when stuff happens, or toggle visibility. We can really kind of just focus on what our app is doing and how it's connected to the data. And this is usually handled by something called the MVVM pattern. I'm not really going to go into it much today, but as I mentioned before, we have a toolkit for that. Funny how that works. There's also some talks about how that is used later that we've done in the past as well. So I'm using a quick example here on the right. So I have a data object model that has an observable property. And that's the key piece there that has some text. And then on the left in my XAML, I'm using this xbind statement to do this data binding to actually connect to that object that I call data and the property, my text. And I've bound that to the text box. So now when the user types in the text box, that's automatically going to update that object in my code. Or if I have some other thing that changes it, then it'll automatically update and reflect that in my user interface. And so that's where the observable property really comes into play, rather than the UI constantly trying to refresh itself and pull every single property that we've looking for and say, hey, what's your value? Instead, it's up to the object with that observable property to say, hey, I've changed my value for this property, and then the UI knows where that property is and can just go more efficiently update the part of the UI that's actually changed. So that's where the benefit comes here with data binding. The other thing we do with XAML a lot is use these things called data templates. And so this is really, you'll see this a lot with lists. And so that's how we take that object that we had before, but translate it into some UI. So rather than trying to create a whole bunch of UI in our code behind, or trying to adjust our data and how our application works to fit into these UI concepts, we can instead kind of separate those concerns, have this data template on the left where we say, okay, this is what my item looks like, and I'm going to create 2 text boxes to display it and bind these, like we saw with the data binding before, to this ID and title property that I've created on my item. And so now, as you can see below, for each item in the list, I can use that data template in XAML and just automatically know how to translate this item from our code into some UI that we can use. So let's actually dig into Visual Studio now and figure out how we get started. So I'm going to be using Visual Studio 2022 today. We want the .NET Desktop Development Workload and the Windows 10 SDK. And I'm going to be using this cool extension called Windows Template Studio. You can find the Template Studio in your extensions catalog. And it gives you this new template for creating an application, which really kind of is this giant wizard that kind of does all this application boilerplate, so you can really kind of focus on your application's experience rather than having to worry about how to do all the nitty-gritty bits underneath the hood. And then I'm going to pull in a couple of Windows Community Toolkit Labs components, the latest things we're working on, to show you how we can use those to bootstrap our application development today. So let's jump over to the desktop here and start an application. So let me pull up Visual Studio, and we'll see in the solution, I basically just gone through that wizard already. I did all the defaults, so nothing really too new here. I'll point out where I've made changes to speed up our presentation today. But I've got this whole structure of an application all set up. I've got this nice README that pops up and kind of tells me where I can get started and what I can do and look at, and different things all set up all today. And if I go look over at the app that I have running here, we can just see it's this basic shell. It looks like a Windows app, has some basic navigation stuff laid out, but it's pretty blank. It doesn't do much right now. But it gives us this whole canvas to start working on to build an application. So I'm going to go into this Views folder. That's the default location where Template Studio creates our pages. And I can go to this main page, and here we see some XAML. I've got this grid. And I can just add a text block in here like we saw before. And we can see I have some IntelliSense here to show me what types of controls are available. And there's other attributes that I can adjust here, so we can have things like different alignment properties. I'm going to start looking at the text. We can talk more about alignment later. And so we can just say, welcome to .NET Conf. And I can close this tag. And then if I go back to my app, we can actually see that the application is updated based on the changes I made to the XAML right away. So you can use this hot reload feature to kind of make some tweaks and adjustments as you're working on your code and see things that are running. But let's spruce this up a little bit more first and see if we can add some pizzazz to our application. So in order to do that, I need to pull in some NuGet packages. NuGet is this location where and system where you can kind of pull in these external dependencies. And so we're just going to right-click on our project and go down to Manage NuGet Packages. That's going to bring up the NuGet interface here in Visual Studio. Now, by default, usually a lot of stuff is up on the main NuGet index, and you can just search for it and find it. In the case of our Windows Community Toolkit Labs, we have a separate feed. So I've just clicked a little settings icon in here and added a new item for our Windows Community Toolkit Labs, as well as have the URL in here. And I'm going to link to a blog post we have later that has the step-by-step instructions on how to add that in there for you. And you can see I've already pulled down these two Community Toolkit Labs packages. We have Settings Control and Rive Player. And so Rive Player is a way to add Rive animations to your application. Rive is really cool technology, and so I'll talk a little bit more about that in a second. And so we're just going to add one of these animations to our app. I've actually already added a file. You can see animation.riv here to my assets. And if I look at the properties, the only thing I've wanted to do is make sure that's set to content, so it'll be included with my application. And so now I can come back to my XAML and we can add one of these players to display that animation. So just like in C#, I want to add a using statement to be able to reference this. So I'm going to create an XML namespace. I'm going to give it an alias such as Rive. And so now I can say using community toolkit.labs.winui.rive. And so this will give us that option to use these components from that namespace now. And so now I can just do Rive Player, and let's say I want to give this a specific width and height. I can just set these properties in here, and I might want to configure some other options. And then I'm going to provide it a source. And so I can use this mx.appx URL to basically reference something within my application. And so here I'm just going to use the assets folder and that animation.rive. And so now I can run this application. So the cool thing about Rive is it's an animation editor and also this runtime that provides stateful animations for your application. So it's not just an animation that you can run and go through, but you can actually connect it to different logic in the state machine in order to do a variety of different things and make very complex animations. And so so once we get going here, we'll see this pop up. And we can see our little Yeti animation here. He's kind of bobbing up and down. We'll make him do some more interesting stuff there. His eyebrows just popped up. If you blinked, you might have missed it. But we'll come back to this. We want to add some settings here, right, and make our application feel a little bit more filled out and maybe provide some more stuff here for us to do. So I'm going to go right-click in our Views folder here, right? So I want to add a new page, and I'm going to use the Template Studio option to do a new page, and this is going to bring up that wizard. And so now I can have a settings page, right? Just something that's very common to most applications. It's automatically going to add theme selection and some storage to remember those settings and actually show us all the changes that it's going to make to our application. So now I can just hit create. It's going to go add in these pages. And so here I have a settings page. And we can see it just has a stack panel and some radio buttons in here. And so I'm going to run this and we can see what it looks like. And if we look at other applications, right, let's say it's a calculator, it has a settings page. I mean, there's not too many settings in calculator, but it has this nice little display and app theme. And so it can let us configure our app. And this is, all that theme selector and storage that Template Studio was adding into our app for us was kind of creating these behaviors for us. And creating the settings page. So we'll see what this looks like here when it gets going. And so now I can go to the settings page that's appeared, and we can see we have our light dark theme settings, but it doesn't look the same, right? It doesn't have this nice drop down and card look and feel that we kind of introduced with Windows 11. That's not something that's built into the platform, but as part of the Windows Community Toolkit and our labs, we've actually created a component that lets us easily add these experiences into our applications. So I'm going to go back up to our namespaces. I'm going to add a labs here. So I'm going to have UI. I'm going to add the Rive one back here as well. Labs.winui.rive. And so now I can add a spacing property in here. This is going to give some space for when we add different things in here. And I can actually include a settings card into our application, and I can actually go and look at our Toolkit Labs website, which didn't fall asleep there, but we have examples and settings on our website, which we'll be updating more shortly. But I can just grab the example that from our samples of the settings card and paste that in here. We're not going to want a name, and we're not going to toggle its that property there. We're instead going to add a description like select a theme, and we can change the header to app theme, and we can see that it has an icon here as well. We can go look up what that code is in a second. And I'm just going to grab this stack panel with these radio buttons that defined how we could toggle our option there. I'm going to put those in this settings card. So now we can see what this looks like here as we get started. And so, I had this code E7999, and there's actually this really cool app called Character Map UWP in the Microsoft Store. And I can actually just go and search for that in here, and we can see it's this aspect ratio icon. But, we wanted that color palette icon. I can go search for that and see that that's E790. I can actually just copy that code in here onto my clipboard. And so now we'll have that to try out in our application. Well, here's our settings now. So here we have the card. We can see that aspect ratio icon. But by default, the settings card has our radio buttons over on the right. We want to have that expander and kind of have them below. So let's go quickly add one of those in here. And so we can use this other thing called a settings expander. And it actually takes all the same properties. It actually acts like a settings card as well. So I can just copy these over here. I can change our card to expander here. It needs to match the above. And then it has a property called items as well. And so the items property just takes other settings cards. And so we can actually just copy the settings card into our item here and just close our tag. And then I'm going to add a couple of those alignment properties that I had mentioned before. I'm going to set content alignment to vertical to give us some more space in the settings card. This is a unique property to the settings card. And then horizontal content alignment to stretch. So horizontal alignment, horizontal content alignment, these are kind of common XAML properties that you'll see quite a bit in different cases and kind of define how things are going to be laid out and react to being resized in your application. So hopefully this is just going to look exactly like our calculator app here and give us this little drop down of the theme. And then there's just one other quick thing I want to go back to our animation for, and then we'll hopefully have time still for another question at the end. So there's our animation, and here's our settings component. We see how we have the updated icon, and now our radio buttons just look like they did in Calculator, which is really awesome. So let's quickly do something with our Rive animation before we run out of time today. And that's one of the things I love about XAML is I can just come over to my page here, cut this out of it, and paste it in my other XAML file and not have to worry about a thing, basically. And I'm going to add another settings card here, and I'm going to give that a toggle switch and give it a name called is hands toggle, and let's say it just has a header of wave hello. And then Rive has these inputs, like I mentioned, for the state machine. So I can actually add this Boolean input, and I can give it a target to is hands up, which is defined by the animation file in this case. But I can use our data binding to bind to my toggle switch. So I'm going to use the name is hands toggle.isOn. And now with that data binding, that toggle will be connected to this input for the state machine. And then I'll be able to control that animation with my application logic here. I mistyped it. Always a typo. At least it told me that it couldn't find it. So so sometimes you have to live debug on the spot. It happens. And so this will rebuild now, and so that's the kind of really great thing that I enjoyed with our partnership with Rive to bring this technology to Windows. It's really amazing that we can leverage the power of XAML with their runtime engine to control these amazing animations, as we'll see here in a second. So I'm going to switch back to our settings control. We have our Yeti, and if I can click on the button, I'm not sure what I did wrong. No. Oh, I put the header on the wrong spot. I put it on the toggle switch instead of the settings card. Oh no. Let's see if I have time to restart. Because it's really cool, I promise. In the meantime, I'll just quickly throw up the links here. It's just in the background. That's hard to see. I can't do that without switching everything up. But the most important one is toolkitlabs.dev. I'll flash these on a screen for a second so we can screenshot them. But here is our Rive animation, and here's our toggle switch. And so now he's a shy bear. But this is a really cool thing with Rive. Now we've directly connected this component to the animation and can really see some cool stuff that's enabled by this technology. So as I said, I have some links here. So we have our toolkitlabs.dev website that we will be updating shortly. I have a blog post that went up at aka.ms/ifdef that explains how to get started with all the stuff I showed you here today. And then we have our toolkit links as well, which are pretty easy to find on the web. But I'm running short on time. Hopefully we might have time for one quick question, but thank you so much. And back to you.
Live demos are hard, but you made it,
That was
Michael.
amazing. Suspense. Loved it.
All right. I think we don't have questions from the board, but make sure you post your questions with the hashtag .NETConf for us to answer live.
That's right. Yeah. Yeah. So you had a good question, though.
Yeah, I was wondering, like, with .NET MAUI and WinUI 3, like, what are the trade-offs when you pick one versus the other? Like, .NET MAUI is multi-platform, WinUI is specific for Windows development. So what do you get when you use WinUI 3 and the Windows Community Toolkit?
Right, yeah, that's a great question, and you kind of hit it right on the nail on the head there with, MAUI is geared towards multi-platform development, so if you're looking to do stuff across different platforms, that's where you get the benefit there. The advantage of WinUI 3 and the Windows Community Toolkit is that if you're just targeting Windows specifically, you get all the different power and flexibility to do whatever you need to do within your application, as well as make use of the wide variety of components like I showed today in the Rive player and the settings control from the toolkit in order to empower your apps.
Awesome. I just love the power of integrating in things like Rive. I've been looking at Rive lately and being like, how difficult is that to integrate? And you just showed it.
Super simple.
Super cool. Yeah. So I think we need to wrap up and move on to the next session.
Yes.
Awesome.
All right. So we have Michele, and he's going to show us how to modernize your desktop apps, WinForms and WPF apps with Blazor Hybrid.
Great.
Take it away.
Okay, let's start. Hi everyone, welcome to the session about how you can modernize your WPF and Windows Form application using Blazor. Sorry for my voice, but I have a bit of flu. If you are a WPF or Windows Form developer, the good news is that you can use Blazor to start the process of modernization for your Windows application. If you already know how Blazor works, you know that you can use Blazor in an hosting model called Blazor Server, where your UI is elaborated. All the elaboration happen in backend, and the difference between the previous DOM, previous state of your UI and the next are calculated as a diff and sent to client through our socket connection and applied to the real DOM on your browser. This means that if you have not connection with your backend, the application cannot work. You can use, instead of Blazor Server, another Blazor hosting model called Blazor WebAssembly. In this case, you download all your code in the browser, and thanks to a standard called WebAssembly, you can execute your real code, JITting your real code, thanks to a compilation.NET runtime in our WebAssembly standard. In this case, you can work offline and contact your backend only for read data or save or update data. From .NET 6, we have a new hosting model called Blazor Hybrid, where you can host a Blazor component or a Blazor application in a WPF, Windows Form, or MAUI application. Let's see how Blazor Hybrid works. You have your process, Windows Form, WPF, MAUI, and you have an instance or WebView 2 in your process. In this case, we use a special package of WebView 2 that is a naked package that contains the integration with Blazor. In this case, the web view show the UI, show your HTML, CSS, and execute your JavaScript, but the C# code, the R code of your component, your Blazor component, is executed in the process that hosts the application. Windows Form, WPF, or MAUI. This means that you can use all the native environment. For example, you can use System.io to access your file system, and the execution of this code has the performance of the native application. And this is the best way in which you can execute your Blazor code. With some low-level call between your process and web view, the UI are updated and all the call to your JavaScript are executed in the web view. But if you want to use Blazor in your Windows Form and WPF application, you need to port your application to .NET Core if your application is in full framework. To do this, you can upgrade your application using a particular .NET tool called .NET Upgrade Assistant. You can find some documentation on the Learn platform. It's a little different between WinForm and WPF, but it's very simple. .NET Upgrade Assistant can help you, but if you have some dependencies with COM object or some third-party component that is not portable to .NET Core, probably you have to interview it in manually mode. In this case, you need to change the the project file of your application with a new configuration block where the project SDK is Microsoft.NET SDK. In the XML configuration, you need to add a special element called use Windows Form or use WPF and set this element to true. And you need to update all your old reference. Also in this case, you can use, you can follow the documentation on the Learn platform. Just some tricks, few tricks to help you in this process. That is not a simple process, but it's a required process to use your application with Blazor. First, update your Nugget packages to the last version, because in this case you have more chance to have a library compatible with .NET Core or with standard library. And for all the features that are reported in Windows Form and WPF for .NET Core, you can use Windows Compatibility Pack. I have a little demo for you in this case. Okay. I created a simple application in Windows Form and WPF. Is the same application, same code, that simply load a JSON file and show the data of JSON file in a grid view. It's very simple, and you need only to complicate just a little just a bit the code. I add data contract, data member, and I use the data contracts JSON serializer for the serialization of JSON data. And in this case, you need to have a porting, and in this particular case, it's a demo case, the process of .NET Applet Assistant works fine. So you need only to start install your .NET Applet Assistant, update it if you have already installed, and launch your application, your tool to upgrade the code. Okay, we don't have the time to launch the tool, so I have a branch demo. You can find all this code on my GitHub page, where I already executed the .NET Upgrade Assistant tool. As you can see, the project SDK is a Microsoft .NET SDK, and the target frame in this case is .NET 6, but it will be .NET 7 without problem. Use Windows Form through the element that specify. In this case, the .NET Core is cross-platform, but for Windows Form and WPF, the execution of your process is only for Windows. Use Windows Form and some packages, for example, Microsoft Windows compatibility, to cover all the features that are not in Windows Form, in this case, in .NET Core, and some extension of your Upgrade Assistant for analyze the code before the upgrade. If I execute the application, it's exactly the same code. It's changed only the chest project, and the execution is exactly the same. Okay. Now your application is a .NET Core application, and you are ready to add Blazor Hybrid to your Windows Form or WPF application. In this case, you need to update the project SDK from Microsoft.NET SDK to Microsoft.NET SDK Razor, because we need the support for Razor for Blazor in this case, and add the Nugget packages Blazor Web View. It's a different packages for Windows Form without PF. You can find it in public Nugget feed. Add a www.root folder to the project, and in this folder you need to add a index.html with a basic HTML5 code. a simple div with an ID, a particular ID for inject your component in this particular div, and you need to link a particular Blazor web view, just a particular JavaScript that is responsible for the connection between web view and the process that hosts the web view. Remember to add an import Blazor file. You need mostly using ASP.NET Core component web, and configure your Blazor web view using the dependency injection, the dependency injection engine of .NET Core, using and Windows Form Blazor web view, or add WPF Blazor web view for WPF, and you are ready to load your component. Also, in this case, I have a little demo for you. It's the same application. Okay, you can find it on the branch demo 2. Okay, in this case, the project SDK is Microsoft.NET SDK.Razor. You have Microsoft ASP.NET Core component web view Windows Form, the Nugget packages to use web view in Windows Form to get the Blazor engine, and the folder www-root and the index HTML, simple in HTML5, a simple div with your ID up to identify this div, and the script that help you to start the communication process between, in this case, Windows Form and your web view. Okay, the import Blazor with using Microsoft ASP.NET Core Components Web, and you are ready to start with the component. In this case, I dragged from Toolbox the web view, but you can instantiate it from code if you prefer. From the button in the constructor of the form data visualizer, the form where I use the web view, I instantiate the service collection, add the service collection the Nugget package, the library to use web view, host page www-root index HTML with service provider to build the engine, dependency injection engine, and on Blazor web view root component, I add a simple component I created in the folder components. Is a very simple table to show your data. It's generic using reflection to build the grid, but it's a very simple example of a component that you can reuse in your application. As you can see, this code, the process, the code, the sharp code is the same of button load click. Is exactly the same. But instead of use the data grid view, in this case, I bind the data to a collection, and with a for each, I show the row. The same process for WPF. Okay, in this case, as you can see, I have the same component of the previous demo, and the Blazor component that show the same data. It's exactly the same behavior, the same code that I can run from my Blazor component, because, as you can see here, in the web component, in this component, I use system.io. This demonstrates that you can use the environment, the process that execute the web view that show your UI. It's exactly the same for WPF. Okay, with 10 minutes, I can show you also another demo. I have a demo 2bis. Okay, in this case, I want to see you how you can use with Blazor Hybrid the parameter for your component. Okay, in this case, I want to pass to component from the Windows Form or WPF process the data to show in the UI. In this case, when I add component to my root components, I use a second parameter with a dictionary of parameters. In this case, weather forecast is the name of my property. And I pass with this parameter a collection weather forecast that I created here. Okay. In this demo, I have one button. I show you that load the data on both the native component and the Blazor component. The problem in this case is when you share some data with your Blazor component, Blazor don't know when this data is updated. So I created a simple singleton service. I call this property change notifier with a method notify property change that can remember you something, and an event to alert the component that some data is changed. In this case, in the component, I subscribe the property changed and call the status changed preview that allow us to redraw the component. In WPF, there's the same approach, but in this case, I create a classical app state for your application. In this case, in the singleton service, we have the collection and an event that can be used to update, to notify to Blazor that something is changed. As in this case, set a startup project. The behavior is exactly the same. Okay, I load one file and show it in the native component and in the Blazor component. Okay, but Blazor WebAssembly, Blazor Server, Blazor Hybrid have in common the way in which we create the component. We use Blazor component and .NET. This allows us to share our UI component, Blazor component, in the shared library and use it from WebAssembly, from Blazor Server, from WPF, Windows Forms, or MAUI, if you want. Okay, and also in this case, I have a very little demo. Okay, on the branch demo 3. Okay, in this case, I have a shared library, Blazor components with my component, weather forecast, grid view, my model, and a service I called iWeather forecast data service with a method that retrieve the data for the component. I inject my data service, my interface, the implementation, my interface in my component and call it when I need to retrieve my data. And we have a Blazor WebAssembly, Windows Forms, and WPF application that use this library. Each hosting model produces an implementation of the iWeather forecast data service. For example, in Blazor WebAssembly, I use HTTP client to retrieve the data from a REST API. In this case, from a HTTP call to a simple weather JSON file. In WPF, for example, I use an implementation that use open file dialog. It's not important for the abstraction because in WPF I can do all I can use all the instruction that is compatible with the WPF, and the same is for Windows Form. Okay, I try to launch WPF demo. Okay, it's the same, but in this case I can use the component from the library, the shared library. For Blazor WASM, I can run the application from the command line. Okay, .NET build. Okay, just one second, perfect. .NET run. Okay. Open the browser. Okay. In this case, I call with the HTTP client the JSON file from the server, and show it in my component. It's exactly the same component, and I use it in Blazor WebAssembly, WPF, and Windows Form. Okay, I have 3 minutes. You can use Blazor Hybrid also in the MAUI application, so you can port your component also in macOS client or in iOS or Android application. It's generally available, and we have a generally available version also for .NET 7. And in the end, some takeaway: to modernize your Windows Form or WPF application, you need to port them to .NET Core. Is a requirement, and it's important because you can use all the features of .NET Core for your application. If your goal is to porting to a web application, you can start with Blazor Hybrid. Start the process with Blazor Hybrid, one component at a time, and in the end, you can use as final client technology Blazor Server or WebAssembly. If you need to share some UI component with the web team, or if you need a web client and a Windows desktop client with WPF or Windows Form, you can use Blazor Hybrid to share with a common library like in the demo tree, and using the power dependency injection to share your component with different hosting model. In the end, app modernization is a journey, and Blazor Hybrid can be your best companion in this journey. If I can avoid, I have a special thanks to my community, Italian community, Blazor Developer Italiani, and a special dedication to Damiano Andresini, a member of my community that leave us last October. And Damiano, this session is for you. Okay, I am in time. Okay, perfect. And if you want to contact me, you can use my my social pages, or you can send me an email to my Hotmail address. Thank you.
Awesome, Michele. That was so cool. Wow, I have so many questions, but first of all, like, my mind's just blown, like, with the idea of doing this. That's such a great kind of hack to be able to modernize your applications. I was wondering about, essentially for a period of time, you're kind of running two different things together, right? Because you're running like your Blazor application and your WinForms app. And I'm wondering like how, you know, if you have to worry about resource management, and then also like, I don't know if there are tools or profiling or debugging in order to kind of keep that kind of co-development in sync and efficient.
Yes, it's a good question, but if you have a shared library with your component, you can debug the UI part of your component in one of the hosting model or with a unit test. When you need to debug the behavior of your component, in this case, you need to start the debug process from each hosting model. So if you have a test, an automatic test that check your behavior, you can launch the test. In that case, you need to start the debug process in each hosting model.
Awesome. And we got a question from our Twitter feed. Can I open and use the developer tools window of the WebView browser embedded in the WinForm app while it is running?
Yes, you can. You have to add an extension method when you register your Blazor WebView for Windows Forms and WPF, and the name is add developer view. It's a specific command. Probably you have this command with a Pragma compilation with the if you are in debug, show the developer tools if you are in release mode.
Okay. So when you're going in, like a lot of the time when you're working on modernizing an application, it can be like a large challenge. Maybe it's multiple forms or, and a lot to think about. How do you go about actually like doing this in a real world application? Do you start with like diagramming and whiteboarding? Do you just kind of get started? What's the way to kind of move into this?
Yes, the modernization of a Windows Forms or WPF app is a journey, and you need to start this process one component at a time. So Blazor will help you in this process because you can start with some piece of your UI. You can develop just some piece, share it with your team, web team, and one component at a time, complete in months, sometimes years, the porting of your application.
And one thing that I was thinking here is that by using Blazor hybrid components, you will not only be able to like modernize your desktop app, but you could use it on new apps like .NET MAUI apps or anything that your team is building. Is that correct?
Yes, it's correct. It's the best way. Use Blazor Hybrid allow you to have a lot of possibilities to in client technology choices. I think this is the best way that you can follow.
Awesome. Thank you, Michele. That was a great presentation. Really appreciate it.
Thank you.
Yeah.
And so we are now wrapping up our Windows section.
Yep.
And soon we're gonna go into our modernization section.
Yeah, and modernization. I like the transition here because we've already been. Michele was talking about.
Yeah, you started the flow.
And so now we've got an amazing team. We've got Alia and Taylor and Mike, and they're going to be talking to us about modernizing apps using all the new kind of tooling and things. I love this. Like we've been writing guidance for people, and we've had like people asking us how do we do it, and we'd write like a big ebook, and then we'd say good luck. But it's actually really hard, and we have teams at Microsoft that engage with customers and help them through this. And I love that they're actually kind of systematizing this and turning it into, like some actual tooling and like I have a little success story of mine. So on my team, I work with James Montemagno, and we had the Planet Xamarin website, and it was running an MVC 4. Or it was MVC 5, but .NET Framework 4.8 something, whatever. And he said, hey, can you help me? This is like, something's messed up with Azure. And I looked at it, I'm like, James, this is horrible. Like, we need to get this in core. And I ran through with the right-click tools, Modernize, whatever, and that day I had it running on .NET 6.
Oh, that's awesome.
Yeah, pretty amazing.
But before we shoot back to them, I think we have some like
stuff to tell people.
Yeah, like some things to share.
Okay, so there's a secret decoder challenge.
Yeah, so what is that?
Honestly, you have to decode it yourself. Go to the website. I know you can maybe win something big.
Yeah, there are like, I think 14 prizes up for grabs. And so like go to .NETconf.net and find out more details about it.
Cool. And then later, so we have like this in-studio session running until until 5 p.m.
here in
And then what's awesome is after that we go to 24 hours around the world, which is amazing. So we've got community session speakers from all around the world.
Yeah, so you're not getting rid. Well, of us you are for us, but of .NET Conf, like we're going to be here for more than 24 hours straight, all around the world with sessions from amazing community members.
Cool. So I think we're ready to turn it over to Mike, Alia, and Taylor.
Awesome. Thank you. Thank you for watching this session. Let's continue modernization topic. And in this talk, you will hear how you can port your existing .NET application to the latest .NET. Well, first, let's clarify what your application originally can target. As you probably know, there are few different .NET platforms. There is .NET Framework that has existed for many years. Then not so long ago, we created .NET Core, cross-platform, open source .NET platform. We also have Mono that Xamarin applications target. And a few years ago, we've heard the feedback that there are too many .NET platforms. It's very confusing for our users to make a decision what to target. And we decided to take the best parts from each platform and create just one .NET platform going forward. We released it 2 years ago. We called it .NET, and we gave it a version number 5 to emphasize that that's the latest .NET. 5 is bigger than .NET Framework 4.8 and .NET Core 3.1. So .NET 5 was the platform going forward, and that's the platform that would iterate through years and receive all the upcoming updates. Another change we made, we switched to scheduled releases. So another feedback from you guys, it's very hard to plan our updates when you don't know when Microsoft is going to release the new version of .NET. So now we're sticking to a fixed schedule. Every November, we are releasing a new version, and every even numbered version is long-term support, LTS. So we're going to support it for 3 years. And every odd number is standard term support, but it's not less reliable or higher. It's same quality, same reliability, it's just different support policy. So just yesterday, we released .NET 7, and that's the latest .NET. We are going to talk about how you can upgrade to that version. So why would you want to upgrade? Besides the fact that that's the platform going forward, meaning that all changes will go to .NET 7, 8, and so on. We're not making any changes to .NET Framework or .NET Core. So if you want to stay on the latest tech, I highly encourage you to upgrade. But besides that, we've made so many changes and improvements. And first that I want to mention is performance improvement. Every year, with every version of .NET, we improved our performance, and our engineer, Stephen Todd, published a blog post with every new version of .NET from .NET Core to .NET 7. His latest blog post has 255 pages, where he talks about over 1,000 PRs related to performance improvement. And the highest win would be when you're upgrading from .NET Framework to .NET 6 or .NET 7, you will see the huge jump in perf. So by simply retargeting your app from .NET Framework to .NET 6 or 7, you make your application run much, much faster. Besides performance, we also make improvements in language. So .NET 7 comes with C#11 and allows you to write less code and get more done. Also, we're constantly adding new modern controls. We are making improvements in accessibility. Accessibility is extremely important. These days, it's a new standard for modern software. And we're making sure that not only our tools are accessible, but also we're helping you build accessible products for your end users. And there are a variety of deployment options. Now you can no longer worry about the setup of your end users' machines. You can package .NET Framework together with your application. You can create a single exe file and just ship it to your users without thinking that they need to install some .NET. And of course, for each area, such as ASP.NET, WinForms, WPF, Xamarin, Entity Framework, we're making improvements specific to those areas. So this talk won't be enough time to cover all the improvements we've made. Just check it out, see for yourself. And there is a path for upgrading for any applications. No matter what kind of app you're building, you can upgrade to the latest tech. If you're building WinForms or WPF, we highly recommend upgrading to .NET 7. And there is a very easy way how you can do it. We have a tool called Upgrade Assistant. It's available on that link. And just go ahead, download that tool. That's a CLI command tool. It's gonna guide you through the migration process. It will let you choose if you wanna upgrade to long-term support, .NET 6, or standard term support, .NET 7. And WinForms WPF have the highest rate of success of just like running this tool and upgrading to the latest .NET. Check it out. If you're building UWP applications, there is a path for you too, and it's called WinUI. The latest version, WinUI 3, is available. It's a successor and much more improved offering for the UWP applications. And we have a few talks specific for WinUI, so check it out if you have not yet. If you're building Xamarin Forms, we have a new offering, .NET MAUI, and we also have numerous talks on .NET MAUI, one specifically about how to migrate from Xamarin Forms to .NET MAUI. So check that out. If you're building WCF, some time ago it was not easy to port to the latest .NET, but now we have a solution. We have CoreWCF that allows you to keep using the APIs that you used in the past. And we have a separate talk covering how you can migrate to .NET 7 with CoreWCF. For ASP.NET, we're going to focus on this migration in this session, and Mike and Taylor will tell you how to do that. And we also have another session on that that dives in more details. And if you're building libraries, you can leave them targeting .NET Standard 2.0 if you need those libraries to be used in both .NET Framework and later .NET applications. But if your libraries are consumed only from .NET 6, 7, and up, retarget it to .NET 7 as well. So with that, let me put some information regarding other sessions focused on migration. And feel free to ask us questions. If you're in your migration journey, you're getting stuck, you don't know how to move forward, feel free to reach out to me on Twitter or email, or reach out to any team members. We're happy to help you, provide you needed information, look at your case, and you, in return, are helping us to make our tooling better. So based on your feedback, we can build a better experience for you. All right, with that, let me give the virtual stage to Mike, who is going to talk more about the migration process. Mike.
Thank you, Olia. Yeah, so like Olia said, whether you're using WPF or WinForms or ASP.NET, there is a path forward to .NET 7, and I want to talk about what that looks like. Now, the details will depend quite a bit on the app model that you're using, because the experience of upgrading a WinForms app is very different from the experience of upgrading an ASP.NET app or a WCF app. But the overall workflow is the same, and that's what I'm going to talk about on this slide. When you think about upgrading to .NET 7, you want to start with some analysis so that you understand what you're getting into. There are some upgrades that are very fast. You can be done in an afternoon. There are other upgrades that might take weeks or months to finish. And largely the difference between those will be the sorts of dependencies that you have. So you want to understand what dependencies you have that may not be available on .NET 7. This might be .NET APIs that aren't available, or it could be NuGet packages that you need to update the version for or find an alternative for. It could be project-to-project dependencies within your own code base, or even loose binaries. So for these, we have tools available that can help analyze whether you're likely to be able to move forward very easily, or if you're going to have to replace dependencies. The .NET Upgrade Assistant tool, which we've demoed in the past and Olia mentioned, will help you look at all of these and understand whether they're likely to work on .NET 7 or if there's changes that are going to need to be made. So after you've done that initial work of sort of analyzing your solution to understand what work you have ahead of you, to actually start the upgrade, you want to upgrade the project file, because like all versions of .NET Core, .NET 7 uses the new SDK style project file format. So you'll want to make sure you're using that new SDK style project and that you're using package references to your NuGet packages rather than something like packages.config. Again, we have tooling that can help with this, but there's an important decision to make at this point in the upgrade process. You have to decide whether you're going to upgrade your project in place where it is currently on disk, which can be the fastest path forward, or if you're going to have two projects side by side and gradually move code over incrementally from the original .NET Framework project to the .NET 7 one. Going that route can take a little bit longer, but allows your app to be usable during the upgrade process. And we're going to talk about this decision on the subsequent slides because it's an important one. Once you've done that, though, and you have a project that's targeting .NET 7 or .NET Standard, you need to upgrade your source code and your other project assets like your views, your config files, and so on to work with that new target framework. Now, at this point, you will have to decide whether you're going to target .NET 6, .NET 7, .NET Standard, or in some cases, maybe even stay on .NET Framework, depending on your particular scenario. But as you're making these changes, we have tooling available, again, that can help. This is where the .NET Upgrade Assistant can help if you're upgrading in place. And we're going to be showing off today some new tooling in a Visual Studio extension that enables incrementally migrating your application that can help if you're going to be in that side-by-side incremental scenario. And then finally, I don't want people to think that that's the final step, because a lot of times when people think about upgrading to .NET 7, they imagine just going in and upgrading their source code. But you also need to test these changes. There are differences between .NET Framework and .NET 7 that only show up at runtime, especially if you're going to be running cross-platform. And so it's really important that you go through and test to make sure that things work as expected after you've finished the upgrade and everything's building correctly. If you don't have a great suite of tests, getting some unit tests in place might be a really good preparatory activity as you look forward to doing this upgrade in the near future. Also at this point, you would want to think about how you're going to be deploying, because once you've upgraded to .NET 7, you have a lot more deployment options. You can deploy your application self-contained with all of the .NET binaries needed bundled with the application. You can deploy with a framework-dependent application that uses the machine-wide installation of the .NET runtime. You could install as a single file exe, which is just a single binary that the user has to download, and many options like that. Depending on your workload and your app model, you may have the option of running cross-platform and deploying on Linux. So you'll really want to think through what deploying and running your application is going to look like after you've upgraded. Okay, so I talked about this idea that you can either upgrade in place or you can upgrade side by side, and I really want to drill into that because that's an important distinction. When we talk about upgrading in place, let's say we have this example solution. Upgrading in place means you choose one of the leaf nodes that nothing else depends on, and you change it right where it is to either target .NET Standard, if it's a library that can target .NET Standard, or if you need to not target .NET Standard, you can multi-target and have the project file target both .NET 7 and .NET Framework. After this upgrade's done, you then work your way up, and you would have maybe library 3 would be the next one you would upgrade. And then once all of the dependencies are migrated, you can migrate Web App 1. Like I said earlier, this tends to be the fastest path forward because you're not duplicating any code. You're making all of the changes right there on disk where the project lives today. For a lot of our types of apps, this is how we recommend that you upgrade. For things like Windows desktop applications, Xamarin apps, console applications, including Windows services, and for most class libraries, upgrading in place is recommended because these are often fairly straightforward upgrades that take a matter of a few days, maybe a week or two, and if you upgrade in place, you're going to get to that finish line sooner. We don't at this point recommend this for ASP.NET scenarios, though, because ASP.NET upgrades are unique in that there are so many changes between ASP.NET and ASP.NET Core. A lot of the concepts are the same. You can share your controllers, your views with small changes, but there's enough differences in those app models that it's often a lot of work to upgrade from ASP.NET to ASP.NET Core, even though, like Olia said, there are a lot of benefits to be realized once you do. Because of that, it can be difficult to upgrade in place because you'll end up with a solution that while you're upgrading isn't able to be built and deployed. But you're still going to need to presumably patch your solution, maybe add features, fix bugs, and so on. And if you have this separate feature branch for doing the upgrade, it's going to begin to diverge from that main branch. And at the end of the upgrade, you're going to have a real nightmare of a merge to do. So for web scenarios specifically, and also for very large class libraries that might have lots of distinct use cases, we're recommending that you actually upgrade side by side a little bit at a time as a way to make those upgrades more approachable. For other scenarios, though, the in-place upgrade is still recommended, and this is the approach that's supported by the .NET Upgrade Assistant tool. So if you find yourself needing to upgrade in place, go ahead out to our documentation. I've got a link here on this slide where you can learn about .NET Upgrade Assistant, and go to the GitHub page. Upgrade Assistant is an open source project that's developed in the public with the community. Would love to take contributions, whether that's issues, pull requests, whatever. And that's the path forward for these sorts of apps. Now, when we talk about upgrading incrementally, instead of just upgrading Library 5 in place, I'm going to create a new Library 5 next to it. So you're going to have two different projects, one of which targets .NET Framework, one of which targets .NET Standard or .NET 7. Now, because you have two separate projects, you don't have to start just down in the leaf nodes anymore. You could start with Web App 1, create a new .NET 7 version of it, targeting ASP.NET Core, that sits alongside the original web app. Like I mentioned on the previous slide, this is going to allow you to have two apps that can build and run, that can be deployed even before you've migrated all of the code over. Of course, as you move over parts of Web App 1 to the new .NET 7 version of that app, if they depend on Library 1 or Library 2 or Library 3, you'll have to migrate those libraries as well as they're needed. But you can sort of pick and choose the vertical slices of your application that you want to start with. As mentioned, this is what we're recommending for ASP.NET scenarios, as well as very large class libraries. And to support it, we have some new tooling that folks may not be familiar with because it's just now available in a preview state as of a few months ago. But it's a VS extension that we've developed that enables this incremental migration workflow right inside of Visual Studio through some right-click gestures and can help make this easier. We've got some blogs about this. The latest blog is linked here on this slide. You can go read that, and from that blog it links back to the previous ones. You can get all of the historical context. And again, you can go out to GitHub to get connected with the team. This is where you're going to find the latest documentation and where you can connect with us if you need to report issues or open pull requests. Now, one of the things you may wonder as you look at this slide is how it works to have two separate head applications, because your customers need to hit one of these, and how does it work for some of the app to be migrated but not all of it? So in order to enable this scenario, that VS extension that I talked about actually wires the two projects together using a reverse proxy. So from the user's point of view, it's still just one solution. But on the back end, what's actually happening is we have a new ASP.NET Core app that the VS incremental migration tooling helps you create that is linked to the original ASP.NET app with a YARP reverse proxy. YARP being yet another reverse proxy. It's a proxy technology that the ASP.NET team developed. So now when a request comes in, the ASP.NET Core app is going to try to serve that request. If you've migrated over the controller and the action method that are needed to serve the request, the response goes back to the user, everything's great. If the ASP.NET Core app can't serve the request because we haven't yet migrated that endpoint, the app will transparently to the user forward the request to the original ASP.NET app, which will serve it. So in this way, you're able to have a solution with some of your endpoints running on ASP.NET Core, while others are still running on ASP.NET, but they are debugged and deployed as a single unit that can be presented to the user as this one unified solution. And then over time, as you move more and more of your endpoints from ASP.NET to ASP.NET Core, eventually you'll reach a point where all of the APIs are available there. You remove your ASP.NET app and you're completely migrated, all without having to pause your normal operations to do some sort of giant merge, because you've been able to build and deploy this app the whole time you've been working on the migration. So we do have a follow-up session that's going to be presented later. It's at 8:30 Pacific time. It's called Migrate Your Legacy ASP.NET Projects to ASP.NET Core Incrementally with YARP. It's going to do a demo and really dive way deeper into this experience. But to just give a taste of what it looks like, you can see once you have that VS extension installed, you're able to right-click on a project in the Solution Explorer and choose Migrate Project. That will walk you through some new UI in that extension. It will show you which portions of your project are already migrated, which ones still need to be migrated. It will set up that project for you, wire it up with YARP, and then from there you can begin choosing individual controllers that you want to migrate. As you pick these controllers, the tooling will find all of their dependencies, and it will copy the controller plus any of the classes, NuGet dependencies, or other dependencies that that controller is going to depend on, copy all of those over into the new project. Along the way, it will, similar to Upgrade Assistant, make a best effort to upgrade your source in your classes that are being moved, to upgrade the NuGet dependencies that are being moved, to versions that are going to work with ASP.NET Core. Now, both of these tools, the incremental migration tooling in the VS extension and .NET Upgrade Assistant, neither of them are silver bullets. They're not going to completely automate this process, so you have to expect there's going to be some amount of manual fix-up to do afterwards, but they both will automate away some of the easier changes so that you can focus on the more interesting ones. I have a link down here at the bottom where you can download the extension I've been talking about. It's also linked from the blogs and the GitHub repos I showed on a previous slide. And so I'd encourage you to go out and check it out. As you're doing these migrations, you will come across scenarios where you need to share code, whether that's in a class library or whether that's in some code that's maybe moving from ASP.NET to ASP.NET Core that depends on system.web. And you need to be able to use these in both head projects. In order to enable that scenario, along with this extension, we also have a new NuGet package called System Web Adapters that makes that work. And so to tell you all about the System Web Adapters and how that fits into this solution, I'm going to hand it off to Taylor Southwick to guide you through the rest of this presentation.
Thank you, Mike. As Mike mentioned, there's some runtime support that we have added in for the to help you as you migrate from ASP.NET to ASP.NET Core. And this is a set of adapters that simulate the API surface area that you are maybe used to in ASP.NET. So this is things like HTTP context, HTTP request, and other APIs similar. This package also contains a number of middleware and services that help enable this behavior. There's a number of behavior that if you migrate to ASP.NET Core, you may be expecting, but it's not there. Things like the input stream is not fully buffered, that it's not a single threaded environment. Session is not strongly typed. These adapters provide APIs to help enable some of those scenarios to help you migrate away from that behavior. One of the benefits of the adapters is that it allows you to compile all of this business logic into a .NET Standard 2.0 assembly. And this allows you to run on both ASP.NET Framework and ASP.NET Core. When running on ASP.NET Framework, it will type forward to the types in system.web.dll. But on ASP.NET Core, it will be backed by types that are found in the ASP.NET Core space. These adapters are thin pass-through implementations, meaning that anything that you do in one will be mirrored in the other. This allows you to convert between the two to help you migrate and choose which representation may be the best for you at the moment. So at this point, we'll jump into a quick demo of what the code might look like here. So if you look at this, here's a usage that may be common in code bases that have been built up over the years. It uses HTTP context.current, it accesses session, and expects a counter variable to be an integer, and then it increments it. We can then hook it up in our web application using minimal APIs and a simple syntax similar to the rest of the ASP.NET Core stack. One of the key differences is that some of the things you have to set up that you didn't on Framework, such as registering what session keys are. So if we were to run this, we can then see it being used in an ASP.NET Core app. So we run this, and we can see 0. And then as we increment it, we see a new that value being incremented. If we go over to a different session, we see that it has its own session ID and its own value. And this uses business logic that is compiled to .NET Standard and allows you to move your code slowly over to ASP.NET Core. So I'm going to pass it back to Olya to finish up and let you know what you can do from here.
Thank you, Taylor. Yes, so what you can do today, get latest .NET 7, upgrade your application using existing tooling, and check out other sessions on the migration. One coming right after ours, focused on WCF. And please give us feedback, because that's how we know how to build the best experience for you. Thank you so much. I'm handing it to Myra.
Hi, thank you so much. That was an awesome talk. Thank you. But I have a new host here.
Hello. Good to see you, Myra.
Welcome.
My name's Jeff Fritz. It's good to be back on this side of the camera for a little bit today.
You've been running the show.
A little bit. There's a lot going on.
We brought you here because you know all the details of what's going on with the conference.
There are so many things going on behind the scenes, so many things that are happening that you can be a part of. Now, not the dog there sitting next to you on the floor. You behind the keyboard, head on over to .NETconf.net. There's all kinds of prizes and things out there that you can win. We have the Secret Decoder Challenge out there.
So
now,
tell us what that entails.
So this is a series of scavenger hunt types of puzzles. Go to various sponsors that we have. You can find them all on that page at .NETconf.net. Go right below the video, just below us here. You can click the link for it, and you'll find links to the various sponsor pages. Click through to the sponsor page. There's a little riddle there that sometimes involves their product, and you don't have to download or run anything, but click through there. You'll be given a letter. Bring that letter back to the main page, unscramble the phrase that pays, and you could win a prize that's $500 US or more.
Wow, that sounds fun.
Oh my gosh. There's even a swag sign-up list where you can win one of 20 swag bags. We have a free subscription to Code Magazine, and we've even got a survey for you to fill out to let us know what you think of .NET, what you think of .NET Conf, and tell us how you feel, what you think, and what we can do to improve all things .NET.
Yeah, because we want to do our best show here, and every year we try to improve and put the best out there, the best product, the best conference, and we need you and your feedback to make that a reality.
And gosh, I mean, some of the things that we've done. This year, we went and did a whole new branding on our websites.
Yes, on both our sites.
Yeah, both .NET and .NETconf.net, and I'm feeling the purple gradients now.
Yes.
It feels so good. I got to figure out how to color my hair so one side's the one purple and the other side's the other
And
purple.
we have some like shades of orange, like as secondary, like.
It feels good and modern. The bot's nice and 3D, and gosh, I really enjoy the new look.
Yeah, and I would love to hear the feedback of what you think about the new look as well. Like
Absolutely.
We're always like looking to bring that fresh new look, and like that was like the site hasn't been changed in like what, I don't know, 5 years or so.
Yeah, few years.
And so we're trying to show what you can do with .NET.
So a couple other things that we've done. You now have wallpapers available. If you check out our digital swag, there's wallpapers available that are in that theme. So you can find the .NET bot on a faraway planet, planting the flag for .NET 7 and flying a drone. And we've also got a .NET bot that you can install in Visual Studio Code as a pet.
Aww.
And he'll wander around inside Visual Studio Code and play around. Really cool stuff. Check it out at the digital swag link just below on the .NETconf.net website.
Awesome. And we're going to continue with our modernization soon. I'm excited about this next talk coming up as well.
So I was a big fan of WCF. I used WCF for a really long time when I was younger, before I started at Microsoft, and for a little bit, not gonna lie, I was responsible for WCF as a program manager, and it was one of those products where we had a lot. There was a lot of responsibility to it. There's so many things you can do with WCF, and we always looked at it and said, how are we gonna upgrade this thing to .NET Core, .NET Standard, .NET 6? And to hear that there's a path forward now is so great.
I'm excited. Yeah, and so a lot of our customers rely on WCF, and so like let's look at in terms of like how we can modernize your app and move to .NET 6 Plus. With Sam and Matt, they're gonna take over and talk about CoreWCF and how to modernize your WCF apps.
Hi, I'm Sam Spencer. I'm a program manager. I'm here with Matt Connew, and we're going to talk about using CoreWCF to unblock modernization of WCF apps. So what is CoreWCF? Well, the elevator pitch is that it's an open source, wire format compatible port of WCF server to .NET. That's quite a mouthful, so let's break that down. So WCF is Windows Communication Foundation. It's an RPC mechanism that was introduced in .NET Framework 3 in 2006, and it enables you to make cross-process calls in .NET. WCF is wire format compatible, so we use the same SOAP and binary XML protocols. And we are a port to modern .NET technologies. So we're compatible with WCF, but we're not just a direct recompile. So we're now implemented as ASP.NET Core middleware, so you get to take advantage of all that's in ASP.NET. And we work with modern .NET technologies such as async and await, dependency injection, iLogger, etc. And we're a port to .NET. So we work with .NET Core, .NET 5, 6, and 7, and also on .NET Framework, and we'll talk more about the significance of that later. Because we work in .NET, we also work anywhere the .NET works, including Linux and containers. So you can now use WCF in containers in the cloud. And we're an open source project, so we have contributors from around the world, including Microsoft employees, and we also have Microsoft support. So we have a number of large customers who depend on being able to call when they have production issues. So Matt, can you do a demo of CoreWCF for us?
Yes, I can. I have to apologize for a weird size on my screen. My Windows just decided, just as we're sat here, to shrink the screen down to a really tiny screen, so we'll do the best we can with it. So we've actually shipped some templates for CoreWCF. So today I'm going to create a WCF service and a client to communicate with it. So the first thing we need to do is install the new .NET template, sorry, the new CoreWCF template. So we do that by installing the CoreWCF templates package, and then after that we going to create two projects. One's going to be using the CoreWCF project, which will create us a server. So we're just going to call that simple server, and then I'm going to create a second application, which is going to be a console app, which will generate the client for to communicate with our service. Okay, so first we'll go into our simple service and open up the project. Let's see how Visual Studio does on a tiny little screen. Okay, so first thing I'm going to look at is service contract. So let's open up, let's clean things up a little to make it usable as best we can. Okay, so here we have, those familiar with WCF will recognize the service contract. With WCF, you have a service contract, which is an interface which defines all your methods, and then you have every method which you want to expose. You put an operation contract attribute on that method. This is actually identical, other than namespace, to what you would get if you're using the classic .NET Framework WCF templates in Visual Studio. Okay. So now let's launch this app, and So just trying to find the output window for this. Okay, here we go. So you can see that it's we've actually got our metadata, which is WSDL for service, which I'll show you in a minute, is exposed at this URL. And if we click on through on here and look at this page, this is the service helper page for the metadata, which is actually identical to what you would get on WCF if you're running on .NET Framework. We kept this absolutely identical in the content because there are some customers who they use this page as a keep alive ping check against the service, and so if the content changes, it could break some tooling. So we've kept it as identical as we possibly can on at the wire level. And so we can actually check out the WSDL, which is an XML document which describes the service. And we're going to copy this into clipboard because we'll use it again in a minute. So now let's go back to our client app and I'm going to open that in Visual Studio. And this is just the regular Hello World console app. So right now there's nothing in there other than a console write line Hello World. So what we need to do is we need to add a reference to our service. So we're going to say we're going to add connected service. And we're going to choose to add a WCF service.
And so this is exactly the same experience with CoreWCF that you have with WCF.
Yes. And this is going to generate into our application the service client implementation, which I'll show you in a minute. It'll have all the exact same interfaces and everything that is actually in your service. So if we go to Solution Explorer and look at the implementation, you'll see that we've got the same composite type that we had, and we've got the same iService with the same methods. There's a little bit more verbosity in the attributes. It's explicitly putting values in which are normally implicitly done on the server side. But yeah, this is identical to what you see on the server side. So now if we go to program, we can actually call the service. And let's run it. We've still got the server running in the other instance of VS. And you'll see hello, it says you entered 42, which is all that the default application does, is it takes in an integer and just returns a string, you entered, and then the number which you sent. So you can see that our service is up and running. So that gets your basic service up and running. But we've done a little bit more in CoreWCF. We've actually embraced the new way of doing things, and we've got a whole bunch of DI capability in here now. So what we can do is we can go to our program and add into DI our service type. And now CoreWCF will check DI first to see if it exists in DI, and will return us the instance from DI. So what this allows us to do is now have dependencies being passed in to our service via constructor. Where's my code snippets? It's not showing me my code snippets.
Toolbox. View toolbox.
Is it under view?
Yeah.
Nope. Okay, it's lost them. Okay, let's. I know this off the top of my head, so I can just put logger private logger of service is my logger, and then I can add. I can add a constructor, for my service, which takes an iLogger of service, and then just set logger to that logger. And then in our code here, we can do logger.log information and
so this is now using ASP.NET Core's logging together with in the implementation of a WCF service.
Yeah.
It's a pretty good integration between modern technology and stuff from a while ago.
Yeah. Oh, the reason why Toolbox wasn't working is because the process was still running. Okay, so now if I come to command line to launch it, because we want to be able to easily get at the console output. And then we come to the client and run that. We will now see that we've got the log output on here saying that you entered 42, so that's the logger that's got injected into our service. But we didn't stop there. We had a look at what was happening on Web API and the way they were doing things, and saw that you can inject parameters into your controller methods there. So I thought, well, that's a good trick to do, so we'll copy it. So that's exactly what we did. Now, there's a small bug in the current templates where it doesn't add a required package. So we're just going to do .NET add package CoreWCF.primitives. So this is needed because we have a code behind piece and it lives inside of this package. And the template only adds CoreWCF.http, which is perfectly fine if you just want to use a vanilla scenario. But you need to explicitly add primitives to get the code generator to work. So then once you've got that added, then there's two things you need to do. First thing you need to do is make your class partial. And then you can inject into your operation. So just need to add system text. So you can see here that the getData method, now we've added two new parameters. We've got which are attributed with the injected attribute. And so we've got HTTP response and HTTP request. Now these two, along with we also support HTTP context, are special case because they're not, they don't directly come from DI normally. But any type which is in DI, you can add in here. Now the reason why we had to add the partial keyword is because this method with these two new parameters no longer matches our interface method, because the interface still only has one parameter on it. So what we do behind the scenes is we regenerate the missing method to match the contract, and in there we then go and pull the items from DI and call your new injected method implementation. So now if we save that, and then all we're doing here is we're just outputting all the headers via a string builder, so it's just a single log. Now when we do a .NET run, then when we run the client, when we go back to server, if everything's worked correctly, we should now see there is all our HTTP headers now being output in the logs. So we can see that we've got the HTTP request object with its headers via injection, and didn't need to do any particularly complicated code to be able to get access to it.
Sweet.
And there's one more trick that we have got. So if you look at the interface, it's the attributes are in the CoreWCF namespace. And so got some feedback from customers saying, but I have code which is shared between the client and the server, and on the client it's in system service model. And so if you add the system service model primitives client package to your project, you can actually use the system service model attributes instead, and it works just exactly the same.
Great. Okay, so let's talk about what is included in CoreWCF. So what's available now is the service definition using interface contracts, which Matt just showed. He also showed the WSDL for client generation, so you have exactly the same experience as you would with .NET Framework. We have the set of basic bindings. We have partial support for XML configuration. WCF was very configuration happy. We can parse many of the attributes from those config files to set up the configuration. And we have most of the extensibility APIs. What's coming soon is integration with ASP.NET's authentication stack. So you can then use JOT and other modern authentication schemes. The top request we've had from customers is named pipe binding, which is for local communication between individual services. Because that is Windows specific, we'll also be doing Unix domain sockets, which works on Linux and modern versions of Windows Server. Another customer request is message queue. And again, we're being abstract here. We're enabling kind of a provider model so you can plug in different message queues. So it can work with Azure, RabbitMQ, etc. And then lastly, reliable sessions. Kind of showing this visually, this is the classic architecture diagram for WCF. If you search for like WCF architecture, you'll get this diagram. But it's a good way to show what support we have. So everything in contracts is supported in CoreWCF. In the service runtime, we have everything apart from transactions. And that's because .NET Core doesn't have the same transaction support that was in .NET Framework. From a messaging level, again, we're missing the transactions, and then named pipes and MSMQ that I just talked about. And then activation and hosting, that is where everything's fundamentally changed because we have been re-implemented as ASP.NET middleware. So we can run anywhere ASP.NET Core can run. If you want to do a console app, you can just do a console app. If you want to be a Windows service, use IIS, etc., we work in all those. So the title of this talk was how CoreWCF makes it easier to modernize applications. So we know customers have a large investment in WCF, and that was one of the factors that was making it hard for them to move from .NET Framework to Core or to .NET. And so CoreWCF gives you a much easier way to port those services. All the service implementation is exactly the same. It's just the ceremony about how you instantiate and expose those services that's changed. So your API contracts, those move across unchanged. XML configuration we talked about. And the other cool thing is we support CoreWCF on .NET Framework. So if you've got a large app with many services, what you can do is migrate individual services at a time while on .NET Framework, keep that application running, and then once you've done all those ports and you're ready, you can then flip the framework underneath, and it's much easier to do in one go. But the other cool thing is the previous talk was talking about the Upgrade Assistant, and we have support now in the Upgrade Assistant for WCF apps. So Matt, can you give a demo of using the Upgrade Assistant with WCF?
Yes, certainly. So here again on my tiny little screen, we have a basic calculator service. It's got a few, add, subtract, multiply, divide methods with their implementation, and the main bulk of the main method creates a new service host and opens it, and it gets all of its config from the app config file. So this is where via an app config or web config you can specify all the information you need to know about your service, what endpoints you're listening on, URLs, behaviors, that sort of thing. So this is what a .NET Framework application looks like. So if we want to upgrade it, well, first of all, let's have a look at it running. So let's get the service running. Simple as that, and run the client, and see the client sends 4 different operations to the service, and tells you what the answer is based on what the service returned. And so we can say on the server side, we also emit a console write line saying all the things which have been asked of us. Okay, so so let's upgrade this application. Well, actually, before I do that, there's one thing I meant to do, and that is to go and get the WSDL from it. So this is the from existing service, and just like on the previous demo, you can click through and find out what was get the WSDL for it. So now let's convert this service. So the first thing we need to do is we actually need to install the upgrade assistant. So it's a .NET tool install -G, so it's a global tool, upgrade assistant. And so that's going to download and install. A global tool, for those who don't know, means that you can launch it from anywhere, not just inside the repo that you're using it in. Okay, so now we've got that. We're going to launch upgrade. I think I typed that right. Nope. Upgrade assistant. We're going to say upgrade, and we're going to pass it the solution file. So once we've launched that, first question it's going to ask us is which project do we wish to be converting. Just need to wait a little bit more. Okay, here we go. So the first step is to which entry point or which project is one to convert. So we're going to say we're going to convert calculator service, and then
this is where you press enter a lot, right?
Yeah, I think it was 12 times. There's a whole bunch of steps, and we get to CoreWCF step after, I think. Where are we on this? Okay, no, we're back with step number 4. We'll see that step number 7 is the one that we want. So it takes a few more. Okay, here we are. We're now at the update WCF service. So we go look at what the project's like so far. Up to this point, it's being converted to a SDK application. But if you look, the code is still the same, but it won't compile now because things like service host aren't available anymore. So let's just finish off the upgrade. So a few more enters. I've been told that they're planning on making it a little bit less verbose on stepping through.
Oh, I thought you needed one of those little rocking parrot things.
Oh, yeah, that would work too. Okay, so now it's being converted. Let's see what it's done for us. So we've still got our service contract, but if you look now, it's in the CoreWCF namespace. And then if we go look at startup, this code has completely changed. So it's replaced the code with all the code needed to start the application using ASP.NET Core, with all the new APIs there. And if we go look at app config, you'll see that all that's left in there is a comment saying that everything's moved to a new file. Reason being there might be other config stuff in there for other aspects of your app, and so we don't want to touch that. So if we go look at the WCF config, some of it has been ported across, and the things which we don't support have been commented out, been left in there but commented out with a comment about what's going on with it. And so if we launch the application, so we go, well, so actually there's a couple of bugs that we're having to deal with right now. One of them is, and I don't think this is related to the CoreWCF piece, there's a assembly info file which we'll just delete. It's got some stuff in it which isn't supported on .NET 7. And the other problem is it's not using the latest versions of our packages, and that will break the WSDL side of things. So if we...
And this is all because we just released .NET 7, right?
Yeah. So get rid of the older versions. And then we should be able to run the app now. See what I did. Okay, so it's running now, so we can actually go and look at, and this is a service now running under ASP.NET Core with CoreWCF.
Great. So, call to action. We're a open source project. Our repo is listed here. The project templates that Matt showed I have listed, the NuGet packages, the upgrade assistant. We have a blog with our announcements and a monthly community stand-up. If you want to come ask questions, see what's going on with the project, want to contribute, we'd love to see you there. Thank you very much. Over to you, John, at the big board.
Awesome. Yeah, so we got a question from Basim asking if there's tools or libraries or whatever to support people depending on remoting. So what recommendations do we have for people working on remoting?
I don't know. That's not .NET remoting is like real legacy at this point.
Yeah, like on .NET Framework, the answer was migrate away from .NET remoting to WCF because there was some unfixable fundamental design issues with .NET remoting, which made it really hard to secure. And so you're not going to be able to bring your remoting solution across to .NET 7. I would recommend first step is moving across to WCF and .NET Framework first, because it's the closest match because it uses the interface style RPC, and then move to CoreWCF.
Awesome. And I was recently working on the support policy page for .NET website. And so is it officially supported by Microsoft, even though it's like an open source project?
Yeah, so we're kind of unusual here. We have lots of customers who are big enterprises and they like to be able to, they kind of want things that are supported by Microsoft. So we actually have a support agreement specifically with CSS, that's our internal support organization for CoreWCF. So there's support, I think 6 months for each version until after a subsequent one is released. But like it's production support, so as long as your thing works, it's not for adding new features, but if you suddenly discover a problem in production because a service pack or something broke things, we're fully supported, and Matt will get the call at midnight to come fix your problems.
Awesome. Always good to know I can get a hold of Matt whenever I need him. Okay, so you mentioned it's an open source project. Of course, Microsoft's contributing to it. Who else is?
So we have people from around the world. There's one of our main contributors, Guillaume, is now an MVP. He's based in France, and he did project templates. He's now also working on the ASP.NET authentication integration. That's really cool. Surprisingly, we have quite a lot of contributions from AWS. They are a big .NET host, and they have customers who need to port their WCF apps, so they've been contributing as well.
I think it was about a year ago that we went over the threshold where I was no longer, I had no longer contributed. Well, my contribution was now below 50% on the total code base.
Yep.
So it's not just a me-only house.
That's awesome. And so for developers that are interested in this, what's the best way for them to get involved in the project?
Go to the GitHub repo. If you, all the activity is happening there. If you have issues, questions, raise an issue, use the discussion tab, or come along to the community stand-up. That's streamed live, and you can call in and see our ugly faces and talk to us directly.
And we've also got Gitter. We've got a Gitter channel, which is linked on the page, and there's quite a bit of communication goes on there as well.
Great.
Yeah, and speaking of community stand-ups, we have like awesome like weekly shows that we host on .NET/live.
Yeah, live.net, whatever.
Yeah.
So
you can see the blinking red when there's a live show on the .NET website. And so we have weekly shows, and a lot of our team members are there talking live with the community.
Great way to kind of connect with the team and give your feedback and everything. Awesome. Well, thanks for an awesome presentation. Really appreciate it. So it's time for Myra and I to say goodbye to you.
Yeah.
We are actually done hosting for the day, but you are not done. We've got some amazing things coming up. We've got 24 hours around the world sessions in the near future. And for now, we're turning over to James.
Yeah, it was a pleasure to be here. Thank you.
So we're going to hear from James in Singapore about gRPC.
Hello everyone, my name is James Newton King, and today I'm excited to talk to you about gRPC on .NET. So the agenda for today's talk, first we'll give a quick introduction to gRPC for anyone who is new to it, and as part of that I'll demo testing a gRPC app using a testing tool such as Postman. Then we'll take a look at what's new in .NET 7, and that will include performance improvements, a new feature called gRPC JSON transcoding, and gRPC support on Azure and how it's improved in the past year. So what is gRPC? It's a popular open source remote procedure call framework. RPC frameworks make it easy for apps to talk to each other. Now, gRPC is run by the Cloud Native Computing Foundation, the CNCF, and what Microsoft and the .NET team has done is we've written a new implementation of gRPC that uses the latest and greatest features in .NET, and we've contributed it to the CNCF. gRPC is cross-platform. It's supported by every major programming language, be it C++, Java, Go, Node, Ruby, Python, C#, Rust, you name it, there's an implementation for it. And these are all interoperable with each other. You could have an Xbox game written in C++, call a gRPC server in the cloud written in .NET. They can happily talk with each other. gRPC is contract first. That means the messages and methods and services are defined in a contract known as a protofile, and that is then used to drive code generation using tooling that the gRPC project provides. gRPC, it's not new. It was originally open source in 2015, but it's a union of two modern technologies, HTTP2 at the protocol and transport layer, and then protobuf as its serialization technology for producing very small, fast binary messages, and also the contract format. So protobuf is the language neutral syntax that you'll find in protofiles. Okay, with that, let's demo building our very first gRPC app. So what I'm going to do is come to Visual Studio and we'll add a new project, and we'll choose to create a gRPC app from a template. So we include a basic Hello World gRPC template in the .NET SDK. This will create an app hosted in ASP.NET Core with an example service set up ready for us to use. So we'll create this. The first thing I'll do is I'll just update the log levels so we get a bit more logging while I'm demoing stuff to you. Okay, let's take a look at what we can find in our solution. So we've got this greet.protofile. This is the contract I mentioned to you earlier. This is where our messages are defined, our services are defined. You can think of the contract as kind of like an interface, and then there's an implementation for that interface. So the implementation is found in greet service. So this will use all the types defined in that greet.proto, and this is where you place your business logic. So this is where you place a logic to handle an incoming message. You can respond to it, you can validate it, you can use it to call off to a database, save files to disk, and then eventually return a response. And then finally, we've got program.cs. That's the standard startup location where everything's wired up. So let's start off by taking a look at our greeter service file. So this is a standard C# class. We've got a constructor here. We're doing a bit of DI to inject a logger. We're not going to use that today. And then we've got this say hello method. So you can kind of think of a service as a controller, an MVC, and then a method, a gRPC method like an action. So this particular method takes a request, it returns a reply. So on that request, we have a name property. We're concatenating that with hello. We're sending that back to a message, and we're returning it to the client. So it's hello world. We give it a name. It'll say hello to that name. But looking at this type, this file, we have some types that are never defined anywhere in our solution. We've got greeter base, hello reply, hello request. Where are these types coming from? And the answer to that is code generation. So if we go to the definition of this greeter base file, we can see we've got an abstract base class being generated for us. It's got this say hello method, which is virtual, so we can override it. And then we've got a whole bunch of code to wire up routes and serialization. It all looks kind of ugly, but the beauty of code generation is it's writing this code so you don't have to. And we can confirm that it's all coming from code generation by looking at the header. We can see this is auto-generated. It's coming from the greet.proto file, and it's been generated by the Google protobuf compiler. So where has this been driven from? The answer to that is this greet.proto file. So this is where we're defining the contract for the APIs that our app's going to provide. So in this case, we're saying we're going to provide a service called greeter. On that service, we've got a say hello method, which takes a request, returns a reply, and then we've got our name and message properties, and these are typed to be strings. Okay, but how does Visual Studio and the compilation know to do the code generation? And that's wired up in our CS_proj file. So I've got this protobuf element that references greet.proto, and then we're specifying we want server code generation. So we want a service-based type that we can then implement in our greeter service. An alternative value here could be client, in case you want a strongly typed client to call the gRPC service. And then we've also got this package reference. So this is bringing in the gRPC server implementation along with the serializer and the tooling. So if we run this app and then browse to it, we'll see what happens. So let's just open up our console app. So this is standard Kestrel logging to let everything know it's running, and it's launched on this port 7160. If we browse to this, we get this message saying communication with gRPC endpoints must be made through a gRPC client. So unlike REST, where you can just navigate to a URL, enter some a path and some route parameters, maybe some query string values, and get back some JSON, with gRPC, both the client and server need to know about that greet.proto file because it's contract first, and our browser doesn't know anything about it. Now, there are a couple of ways we could test our client, our server that we've just created. We could create a .NET client using that greet.proto file. But what I'm going to show you today is using a testing tool called Postman to invoke our server. So Postman is probably all pretty familiar to a lot of you. It's always had great support for invoking RESTful HTTP APIs and has all kinds of advanced features. But recently it's added support for gRPC requests. So in Postman, we can say new gRPC request. We can then specify a URL that we want. So this is what we just entered up here in our browser. We're using HTTPS, so we'll click the lock. And then if we choose select method, we don't get the methods to get. We don't have say hello on this dropdown, and that's because Postman still doesn't know about that pesky contract file. We need it to let it know about greet.proto. Now we could choose to import the greet.proto file, but what I'm going to do is I'm going to set up something called gRPC server reflection. So server reflection is kind of like Open API for RESTful APIs. So Open API is a JSON file. It's located on your server, and it has definitions about all the services that your server provides. gRPC server reflection does the exact same thing, except it is a gRPC service providing information about other gRPC services. So we want to set that up on our server, and there is excellent support for it built into gRPC and .NET, and I will show that off to you right now. So first thing we're going to do is we're going to add a new package. So this is the server.reflection package. Then in our program.cs file, which we haven't looked at yet, we're going to add a service. So we're going to register some services with DI. So just like we're registering gRPC, now we're registering some additional services for gRPC reflection. And then finally, we're going to register map a gRPC service in our HTTP pipeline. So previously, greeter service was registered, so we were able to call our implementation here. We also want to register our reflection service. Okay, so that's all we need to do. If we now run our app again and we go back to Postman, we can click try again. And when we click that, Postman client goes off to the server. It downloads the available information about potential services. So we've got one service here and then one method. And we can now start using this to invoke our gRPC service from our client. And we can verify that by taking a look at the logs that get written by our Kestrel app. So we can see a bunch of HTTP requests have gone off to this server reflection service, and it's downloaded reflection info, and then Postman has used that information in the client to make our call available. So Postman knows about the messages that we send and receive, so we can click generate example message and then enter the message we want to send. So let's say .NET Conf 2022. Although I'm entering JSON here, this is just like a visual representation. Postman will convert it to protobuf when it sends it off to the client, off to the server. So we just click invoke, and we can see our name specified here, went off to the server and was concatenated with hello, and our server was invoked. And again, we can verify that by taking a look at our server logs. We can see that our say hello method was invoked and it called off to this say hello service, and we got a result back. So the great thing about gRPC and server reflection is once you have it set up, it's very productive to work with it. So if we want to add a new gRPC method, let's call it gRPC new method, click save there. Code generation will automatically run, so we just need to override our new method. And we'll just copy and paste the previous implementation, and we'll just modify this slightly. Say hello new method, cool name equals this. We run our app. We go back to Postman and we choose refresh. Our new method is immediately available. We can choose it and we can invoke it. So that's how fast and iterative and productive gRPC can be by combining features like contract first, code generation, and tooling with gRPC server reflection. So a quick overview of what we just did. We created a server. We set up server reflection. Only took a couple of seconds. And then we configured our testing tool to use that reflection. Usually this is just as simple as entering that address. The endpoint for server reflection is known, so tooling will just go off and check to see if it's available, and if it is, it will just automatically use it. Now, I demoed using Postman. Postman has a lot of features. Some of them are commercial, so keep that in mind if you want to use it. An alternative free open source tool is something called gRPC Web UI. And if you want to use the command line, gRPC curl lets you invoke gRPC services from the command line and get responses back. So let's talk about what's new in gRPC for .NET 7. Every year we try to make gRPC faster, and we've made some great improvements in .NET 7. Now, gRPC runs on HTTP2, so high performance in Kestrel's HTTP2 stack is critical. A long known issue to the ASP.NET Core team is a bottleneck when writing a HTTP2 response on a busy connection. Now, the way HTTP2 works is there are multiple requests running in parallel simultaneously on one TCP connection, and this is called multiplexing. However, only one thread can write to a connection at a time. That means we need to limit access to one thread, which was previously done with a simple C# lock. Now, locks are a great choice for thread safety a lot of the time, but in this situation, the lock had a lot of contention. There were dozens of threads fighting over it, and this was hurting performance. The way I like to imagine it is perhaps there's a small door and there are dozens of people trying to get through it simultaneously, and they're all pushing and shoving each other out of the way, knocking each other down. It's a very inefficient and wasteful process. So what we did in .NET 7 is we switched that lock to instead be a queue. Instead of fighting over a lock, threads would now line up in an orderly fashion, place some work on the queue, potentially go off and do other work while they're waiting, and then get notified that the write is complete and they can resume working with the request. So this CPU re-architecture saved CPU cycles from fighting over that lock and better utilized machine resources. Now in a benchmark, we saw a server streaming benchmark, we saw an 800% increase in requests per second after this change. Now, this particular benchmark really stresses that lock. It's probably a worst case scenario. But even in more typical gRPC and HTTP2 usage, we still notice a nice improvements after this change in .NET 7. Another improvement is HTTP2 upload speeds. They're now much faster when uploading large messages and there is latency. So HTTP2 back pressure was limiting upload speeds when there's latency. The reason for that is the client would send a burst of data to the server. The server would say, hey, slow down. I can only handle so much data. The server would then process that data and then send a notification to the client that it can resume sending. Unfortunately, because of latency, that means there is a pause when sending and receiving data. So you can imagine data being sent in like bursts in a start-stop fashion. So what we did in .NET 7 is we increased the buffer sizes to find a better balance between memory usage and throughput. So previously, uploading a 100 megabyte file in .NET 6 would take about 27 seconds. In .NET 7, there is a 6-fold improvement. Now it's just a bit over 4 seconds. Finally, I'd like to talk about a .NET gRPC performance results benchmark from a community-run benchmark. Thanks to the great improvements in .NET 7, from low-level API improvements and the BCL, improvements to JIT, improvements to profile-guided optimization, all the way up to major re-architectures in our HTTP2 layer, .NET performance now meets and even exceeds really fast frameworks like Go, C++, and Rust when it comes to gRPC performance. I think this is a real testament to the kind of performance you can get out of .NET and also the quality of .NET's gRPC implementation. So gRPC JSON transcoding is a major new productivity feature in .NET 7. It's an extension for gRPC that allows a service to act as both a gRPC API and as a RESTful API at the same time. JSON transcoding is useful for anyone who wants to provide both types of APIs to their clients without having to build them twice. You don't want all that duplication of building things once with REST, once with gRPC, and then having to maintain them forever. Wouldn't it be great if you could just do it once and it worked for both? And that is what gRPC JSON transcoding allows. So let me demo this amazing feature. So we'll take our previous app and we'll extend it to include gRPC JSON transcoding. So again, we're going to add a new package to our CS project file. So we're going to add the gRPC JSON transcoding package. Then in our program.cs file, we're going to add a new service. And then we're going to add a couple of new proto files to our solution. So the reason we're adding these new proto files, and these are located, these are annotations.proto and http.proto. The reason we're adding these new proto files is we want to add some annotations to our say hello method to specify how it maps to a RESTful API. Like we need to specify a route to be able to call this. So after including these files, we then want to import one of them. So we're going to call import Google APIs annotations.proto. And then finally, after that, we'll just comment out the previous method. We're going to add the annotation to it. So the annotation is this particular bit of code down here. You can think of an annotation like an attribute in .NET. It's like metadata we're adding to the call. So in this case, the metadata we're adding is we're saying, if you want to invoke this call with HTTP, this is the route you use to call it. So it is a get route, it is v1 greeter, then this route parameter of name. And this name route parameter it maps to the request property. So name down on hello request. So whatever value we enter here will get mapped down to here, and it will be used when we invoke our gRPC service via REST. So theoretically, if I've done everything just right, we'll compile our app. That succeeded. And let's launch it again. And we'll come back to our browser. So previously, we got this warning saying we need to use a gRPC client. Let's see if we can now use REST. So we'll type in v1 greeter and then .NET Conf 2022 and success. We can see our GET request is now returning JSON from our protobuf gRPC endpoint. And we can verify that again by taking a look at the logs. Our request came in, it was a GET request to that URL we just specified. It got mapped to that gRPC endpoint, and then it returned a response. And in this case, the response was JSON rather than protobuf. So that's pretty cool. So this is just a very simple example of an annotation. You can also support post, you can support multiple route parameters, you can support binding query parameters, incoming JSON bodies, all kinds of verbs, get, put, post, delete, you name it, you can do it. And once you have JSON transcoding set up, it's very easy to add new methods. So we can just add greeter new method, and we're already set up and ready to go. So REST is great. The thing which takes RESTful APIs to the next level is OpenAPI. And what I'm going to show now is adding OpenAPI to our transcoded methods. So again, coming back to our CS-proj, we'll add a new NuGet package. This one is gRPC.swagger. We'll add some new services to our startup file, program CS file. And we'll add some Swagger middleware, some Swashbuckle middleware. So this middleware will be familiar to anyone using Swashbuckle. We're going to register use Swagger and then use Swagger UI. Now, if I launch this and come back to it with the browser, I can now navigate to Swagger and I get the Swagger UI experience. And I can see my 2 endpoints are showing up. So I can come in here and I can invoke it just like you usually would. Hello.net and click execute, and we get back our message. And also if we take a look at our swagger.json, it's just your standard Swagger, except instead of talking to a RESTful endpoint written with minimal API or MVC, in this case we've got a RESTful API written with gRPC. So that's gRPC JSON transcoding. It's a very cool feature, but also very powerful, simple to easy to use, and a great productivity boon if you want to serve both gRPC and REST at the same time. So let's do a quick overview of how it worked. Imagine we've got a gRPC client that's talking protobuf. We use a google.protobuf serializer to deserialize to our hello request, and then we invoke our method. Imagine we've got a RESTful API client. It's got a custom route, which is got a route parameter. We bind that to hello request. We invoke the same method, and we're good to go. And even though I just showed off invoking it with REST, there's no reason you can't still keep using protobuf to use it at the same time. It's not one or the other, it's both at the same time. All right, finally, I'd like to talk about gRPC in Azure. I'm happy to say gRPC is now fully supported on Azure App Service. This request was ASP.NET Core's most commented on and voted on issue, and it's great to be able to get that done and mark it as closed. The actual work to do this was a joint project between the Azure App Service team and the .NET team. What we did together was we replaced one part of the Azure App Service infrastructure, this thing called a App Service front-end role, and we replaced it with a YARP, which is a proxy toolkit that runs on top of ASP.NET Core, and in this case, we're using Kestrel. It means that we can fully support gRPC because Kestrel has great support for HTTP2. There was an 80% throughput improvement, which is great. Potentially, we can decommission the number of proxies we have, create greener data centers by using less resources and energy. And also, because Kestrel has great support for HTTP3, it provides a gateway for future features to get added to Azure App Service. That's all I have time to talk to you about today. There's great documentation available for gRPC on our docs website. Everything I've talked about, including testing with gRPC server reflection and JSON transcoding, is documented here. And there are also many examples available on the gRPC.NET repository, including gRPC reflection and transcoding. So thank you everyone for joining today. I hope you're all excited about gRPC on .NET, and I can't wait to see what kind of apps you make. Back to the studio.
Oh my gosh, James, thank you so much for sharing with us about gRPC, the updates for transcoding. As somebody who really enjoys using Swagger, to be able to get that now with gRPC and protocol buffers, it feels like a win the whole way around. You got chocolate in my peanut butter here, buddy. That's great stuff.
Yeah. This concept of JSON transcoding, it's not a new one, but I think the way we've implemented it in .NET makes it very easy to use. Alternative solutions did require like setting up a new proxy server that would sit in between your gRPC server and the internet. But because of the power of ASP.NET Core and Kestrel, like we can integrate everything into one app and make it as easy and as simple as just adding a NuGet package, a bit of a configuration, and then you're good to go.
And I get all my Swagger UI that I'm used to. Love it.
Yes.
Oh my gosh. Thank you so much, James. We really appreciate you joining us for .NET Conf and sharing a bit more about the advancements in gRPC for .NET developers. Well, friends, we're nearing the end of day 2. There's so much that we've accomplished. We've now done 2 days, 9 hours each day. That's a lot. That's a lot of time that we've spent together here in these studios. But we're not done yet. There's so much more going on. There's more on the website. I want you to get out to the website. Open up your browser, open another tab, grab your phone, go to .netconf.net, all right? Scroll down a little bit just beneath the video. Look at that, you even see it's right over there. Check out, but thank you so much, my friends, for the lower third. Head on over there, you could win swag bags. We have swag bags from all of our sponsors. We've got more than 20 sponsors helping us out with today's event. Check it out. There's all kinds of product in there that you can have sent to your home. All kinds of great stuff. Check out the Secret Decoder Challenge. Some of those sponsors, they've set up websites where they've hidden a clue on their website. Click through to there, solve that clue, and you'll find a letter. Bring that letter back to the Secret Decoder Challenge page, unscramble those letters that you find, submit the phrase that pays, and you could win one of, I believe it's like 17 prizes that are valued at $500 US or more. Huge, huge opportunity for you. And taking a look, not too many folks have gotten the Decoder Challenge right yet. So it's a big opportunity for you to win big, big prizes. All right, so check that out as well. We have a free subscription to Code Magazine I want you to check out. Once again, on .netconf.net, check just below me. There's a tiny URL you can click there. It's tinyurl.com/codefocus2022. All right, click that link that's right below me and you're going to be in great shape. Now, it has been a fantastic 2 days here in the friendly confines of Microsoft's DevRel studios in stately Redmond, Washington. But we're about to depart. We're about to take a whirlwind trip around the world. We've got all kinds of speakers coming to you from just about every time zone. All right, we've got 6 of the 7 continents covered. Sorry, Antarctica, we couldn't find any penguins that wanted to talk about .NET. But We're going to be going around the world. I want to say a quick word of thanks to all the folks that have been helping here in the studio for the last 2 days, okay? I want to thank our floor director here, Sarah. I want to thank Matt, the director, Ricardo, Juliet, Allison, Ryan, Matt, the editor. Cameron's been helping out. Our hosts, Richard Campbell, Myra Wenzel, John Galloway, Maddie Montequilla, Matt Sukup, and of course I can't forget my partner in crime, Javier Lozano, Mehul Harry, and of course our buddy PJ helping out from marketing. We are just about there. It's almost time to take our first step. We're going to be going to Oregon to get things started with our whirlwind trip and community sessions for day 3 of the event. All right, friends, we are just about there. It's been, what are we talking, 18 hours so far, and now coming up, we're going to go 24 hours straight. Doesn't matter what time you're at. Doesn't matter what time of night it is. All of this content is being recorded for you. It's going to be edited, and you're going to find a playlist of videos available on .NETconf.net that you're going to be able to review and see all of the videos if you don't catch it live. Get some rest, get some sleep, and tune in for our next sessions starting right now.